Hey, Anna. Welcome.
Hey, Nikolai. Hello, everyone. Welcome to the live stream of Java 21.
Yeah, how's everybody doing? Hope you're having a good time. I saw lots of people already letting us know where they're from. Germany, Russia, Mars. Somebody's on Mars. Adam. Hi, Adam. That must
And
be a long
somebody
delay.
said that the release happened 1 minute ago. Good to
Oh,
know.
really? We don't have
So we
time
were
to check
just
for
on
that
time.
here because too much else to talk about.
Yeah, sure.
Earlier today, I asked people on X/Twitter and also on Mastodon what their most liked features about that they're most looking forward to the most. And you're not going to believe what came out first. Do you want to take a guess?
Virtual threads?
Yeah, it's virtual threads.
Why
It's
are you
virtual
so
threads for like a big
disappointed?
margin, too.
Okay, so why are you so disappointed?
Yeah, right.
Why don't
So,
you...
yeah, let's do that. First of all, let me show you that vote. Just to, I'm not just making this up. I'm honest about this. This is. Oh wait. Well, I'll be there in a second. Give me there's too many tabs here. There we go. Okay, so virtual threads, and the one on the one on Mastodon looks very similar. Right, so yeah, virtual threads. I mean, no wonder that so many people are so excited about it. Like, it's a big change that comes to Java here. And I think we're going to have much more time later to go into the details. Jose will be here virtually. He will explain to us via video how that all works. And we're going to have Ron Pressler there to explain it to us too afterwards with the Q&A. So we're going to have a lot of details on that. But just like the very high-level pictures, virtual threads are kind of like virtual memory in the sense that you don't have infinite memory on your machine. And sometimes you will notice and you will run out of it. But much of the time before that, all the systems on your program, all the programs on your system actually occupy much more memory than you really have. You share a limited resource in a way that makes it appear plentiful and available to everybody. And that's basically what virtual threads do with threads. Threads are a valuable resource, but virtual threads make it seem abundant. And just like you usually don't care about real memory versus virtual memory, you most of the time won't care about real threads versus virtual threads. You will configure probably your web server or your web framework to use virtual threads for you. It will run your stuff in virtual threads instead of regular threads. And then you can just have basically as many as you want. And then you can block on those, and it doesn't matter. So there's really a lot of potential for those apps who are bound at the moment by threads. So not bound by CPU, who are not otherwise bound by memory. They're not bound by outside services. All of those resources could do more. It's just that they ran out of threads. And that's going to be a big difference for all of those. So we're looking forward to that. And many people are apparently as well.
Yeah, I've seen somebody saying in the chat that virtual threads are going to create a new business for troubleshooting. I have something to add here. Virtual threads are very good from observability point of view as well. So if you're going through the JUG folks, you're going to see a part that's addressing exactly observability and how it's easier to observe what's going on now with the threads and see all the stack and everything. So I don't think troubleshooting will be a problem, but let's see.
Yeah, and there's also virtual threads work correctly with everything, with synchronization, with thread locals, but some of those things may hinder scalability a bit. And so, for example, we have a scoped values API that is in preview in Java 21. And that one is not a full replacement for thread locals. It works a little bit differently. But yeah, so that's one thing that people can take a look at to make sure that their app works better or scales better. It still works correctly anyway, but it scales better with virtual threads. And then, of course, if you have infinite threads, you can unlock new program paradigms. We're looking at structured concurrency. That's also a preview API. And that's one where you can really make use of those threads to write concurrent code that is easier to read and understand for you.
Well, speaking of performance and scalability, I want to tell you all about GenZGC. So GenZGC is Java's newest garbage collector that focuses on scalability and low latency. What I like most about this new garbage collector is the fact that it withstands higher allocation rates, more CPU. It has lower CPU usage, lower heap headroom. And starting with JDK 21, you can enable it via two flags, UZGC, that probably you're familiar with if you have used CGC before, the previous, the one that was since JDK 15, but now the Gen Z GC can be enabled with -z generational flag. And it has automatic tuning. So this is pretty cool about it because it has dynamic generation sizing. You don't need to set the dynamic number of threads or any other thing except for heap size, the -xmx. And when I say about the garbage collectors in general, the biggest changes on garbage collectors is the fact that between JDK 18 and 21, it's now everything is a generational garbage collector. So it's more performance. If you want to hear more on performance and garbage collectors, we're going to have something later for you, a video, but also a guest that's going to tell us more about how garbage collector help its business and its product that will soon run on JDK 21. So stay tuned for that one as well. And
yeah, I'm really looking forward to that, because it's always one thing that all this technology improves and gets better and performance gets better in the abstract. But it's nice to see how people who are using this in the real world can actually confirm that. They can say, yes, look, we ran the numbers. There's some changes here. Some go up, some go down. But in total, we see a positive development. And so we're really looking forward to hear from Geoffrey de Smet about that later.
And if you're not familiar with CGC, or if you would like to learn more about garbage collectors, you can go to Inside Java. There's a tag called GC, and you can find all the articles that have been published on garbage collectors. There's a lot of research going on fine-tuning, comparisons on different use cases. So there's a bunch of stuff that can help you in your day-to-day life regarding working with garbage collectors, not necessarily maybe on JDK 21, but you can see a list of all of the improvements, all the research that folks have done throughout time and shared with the community, of course. And moreover, there's a stock walker video done by our colleague, Billy, who will join us later, on ZGC. So exclusively on ZGC, if you want to see that one, get introduced to the topic, find out what is Z standing for. And
wait, it stands for something?
Yeah, but people have to watch the video, so I will not share that.
Oh man, now I have to watch the video.
Lol. This is how good colleagues we are. So watch that, dive into Inside Java information that you find on garbage collectors. And of course, stay tuned for what's coming later on performance with our guests as well. But performance is great, is cool. But we also like changes that are related to language and to the way that we're working. And a feature that has been wanted for a long time by all of us has been working easier with strings. So far we have been working with strings when it comes with, I don't know, when we need to repeat the same string all the time, or we need to concatenate strings. We are usually using the plus operator because it comes in hand and is probably the first one that we're learning to use when we're coding with Java. Then we're probably using string builder because we see some posts on the internet, string builder is better. You should always the time append everything. And then later on, if you're more advanced, you can go with message format. So yeah. And maybe lose a little bit of the, meaning of what you were writing there with message format and do more ceremony and so on. So starting with JDK 21, you can preview the string templates and those make it simpler for you to express strings that include values computed at runtime, enhance readability of code, and there are safer results out of the box overall. But the most important thing is that it will simplify the use of strings in APIs that accept strings, like the APIs that work with XML, with JSON, and with SQL. And without further ado, I want to show you string templates in action. So let me see if I can. I'm a little bit nervous.
Who wouldn't be? That's a big audience. By the way, we see you in chat, but I've got to say I'm a bit overwhelmed by the amount of things that you're saying and that you're asking. And we have Q&A portions later when we hopefully get to questions like the ones you're having. Don't worry if we don't pick up anything you're saying right now. It is just a little bit much. We'll get to you. Don't worry.
So this one will be later. String templates, right? I thought to take a real use case that I actually kind of encountered recently. this case of JSON converter. So probably many of you that have worked with databases have converted from an entity to something else, or from something else to that entity when storing in the database, to make this conversion. And maybe you have implemented as well attribute converter for that specific entity that you're working with, or for a specific DTO for conversion, to further process it somewhere in the database. Now, for this example, I will use records, but in the case of a real database, I was using classes, as records are immutable. So, how do string templates help me in this case? Well, if I am to test this, and I have a very nice unit test here, I would need most probably to provide to it a string template to it. So, or not a string template, but I would need to provide a JSON. And most of the time that I would use to write a JSON for my test would be as follows. Let's say string JSON, and it will look something like this. Okay. If I'm not using anything before 13, or actually 17, just to keep it to LTS. Because I need some tabs. I need also some new lines, and this looks very, very ugly when it comes to testing, right? I mean, it becomes cumbersome to maintain this. It becomes difficult for me to replace values. And if you're writing multiple tests, you'll end up writing many times the same thing, and very difficult to manage all these. And I've been in that situation where I had to write such as JSON many, many times, where it was very difficult to maintain this over the tests, and everything was very long and so on.
Anna,
So,
do you have a chance to increase font size a bit? People are saying it's a bit small.
Okay, yeah, sure.
Maybe I put you on this side. Okay, there we go. Thank you.
Welcome. Okay, so I should have entered presenter mode, the presentation mode, but it's okay. Okay, so this is one option. We don't like it. Let's move to the next one. Okay, still string JSON. Then we go with text blocks, right? Because we can also do text blocks starting with certain version. Let me see if I have a shortcut for generating a text block for this one. JSON T, key, and value. It's because I don't want to write a JSON by hand now. Okay, so this one looks better. Okay, let me write it by hand and do it. Name, Jane. It's our person record from here. I will put it some age, put it at 30, give it a key for address, and put it city. Sorry for this country. Okay, and here are some hobbies. I will not care about the values of the hobbies. Anyway, if I want to use this with strings with text blocks, how we're going to use this? Well, we can also use the lovely, replacement of S everywhere, or D here in this case. Do it like this, and replace this with string or with int by hand. And then furthermore, do it like this: JSON.formatted, and give a list of arguments here for our person, and say Jane and the age and everything. But this gets us to like a very, very long JSON. So it's going to be, let's say, put city, country, and what was that? The hobbies. Hobby. Reading. Gardening. Okay. I forgot some strings. That looks really, really nice to read and so on. And now that we have this, we can go to our and test a little bit our converters. So let's do this. JSON converter. Say JSON. No, sorry. JSON converter. Okay. New JSON converter, and JSON converter to convert to entry tree attribute of this. Okay. And let's make this as a variable. Now, even though that this looks better for testing further along, and maybe they're not know of person, it still is a little bit cumbersome. And even if we move this in a variable above, again, it's cumbersome to maintain this and not to forget what we replaced earlier in our overall string, in our overall JSON. How do we transform this to something better? We can transform this something better with the string templates by simply working str, putting str in front of it. Remember that we have JDK21, and we can import it. And of course, because we're working with a person, so why not assume that I already get a person in the beginning and make a person and say new person. And change this one to result, just not to have conflicts. And make this a new person here with the same values from formatted. But now working with it more meaningful, because person actually has address. And we can make a new address and say that here. But also the hobbies is a list. It's not a random string thing, just what I gave here. So why not give it as a list and import the class? So now that we're done with this, we can go here and express this more meaningful and say person.name. What was that? Yes, person.name for this one. And of course, we need to prefix this with a backslash and put it in the parentheses. Now, the next thing is going to be the age, and it's going to be the same thing. So we're going to go through the person more meaningfully than with the regular patterns that we had so far available. Now that we're getting here, because we're having the address, we just can put the person.address .city, and of course person.address.country. And for the hobbies, I'm going to use something that's going to look a little bit interesting. Because it's a list, I'm just going to go and say get hobbies. No. Hobbies, because I'm always getting the two of them. And person.hobbies last. Okay, and now that we're done with this, let me put my JSON here. Yes, my IDE still doesn't recognize a few things, but let's see if it's going to work. Okay, cannot find symbol country. Oh, I forgot something. This one has street, city. And this one is city. I forgot how I defined it. Okay. Good. Now let's run it. Actually, I need us to run this one. Okay. Error while parsing my. Probably I forgot something in my.
So Anna, I gotta ask.
What?
You're using str there. Is that the only option that you have?
No,
Can you
it's
show us
not.
that str line, that line 32, right? It says str, and then so what's that about?
So the str is the built-in processor that you get for processing strings. So there are two of them, str and fmt. Fmt is for formatting. So and it's not the only thing that you can do with it. You can define your own. And actually, if you're working with the Alfred formats, you can define your own, or the libraries can define their own. Or in a different way, you can also use the processor to not just all the time return strings. So in this case, all the time I'm returning strings, from, let's say, from a string, I'm processing something as a template to another string. But I can also use the string template processor to get strings and take and return that as a new object, like a JSON, for example.
Oh, I mean, that's pretty good, right? Like, I imagine, for example, you can return JSON or maybe SQL, because the issue at the moment is when you interpolate strings, when you put stuff like variables into strings, you often run the risk that not only are you violating the syntax of the specific language you're building, HTML, JSON, SQL, whatever, you might also, do the wrong thing, get a Bobby tables, get SQL injections, run the risk that not only is what you're building maybe not syntactically correct, but it might be correct syntax, but then misbehave at runtime, right? And you might get, for example, injection tags, which is probably the worst possible outcome, but still a bad outcome. So I can see also how this could improve security if you can have something that parses and understands SQL, and then make sure that it's not just treating it as a dumb string, but returns, but processes it as SQL and tries to figure out whether it's valid SQL. Could maybe use a prepared statement. So like in general speak, by the way, like it's also like we get language features like these, we get platform features like virtual threads, but overall the platform is evolving too. We get, for example, security improvements across the board, right? There's way too much to go into here. From between 17 and 21, for example, there have been just so many changes. It's continuous work to phase out old algorithms, to bring on board new algorithms, to extend, for example, default key lengths. So if you're working in the network space, roughly and in general, then you should definitely look into different sources. One of the sources you should always look into is the Java crypto roadmap. So that's a big thing that you can always take a look at. Let me see. That would be the Java crypto roadmap here. We're not going to go over it because it's a huge document, right? Just you should know it exists, and it explains for all changes, why they were made, and what the possible repercussions are for your code, what you might have to change, what you should definitely avoid doing, in case you need to work around some of these changes, what you can do to revert for a while. So that's definitely something you should check out. And one thing I can only recommend is the Java security blog from Sean Mullen. So Sean Mullen works at Oracle for OpenJDK security. And as you can see, writes run blog posts every 6 months. that's the most dedicated blog I know. And so I'm expecting at the 22nd of September, so later this week, the JDK 21 security enhancements post. I'm going to drop that link into the chat. You should definitely check that out. As I said, if you're security minded, if those things matter to you. And there's also a Road to 21 video that we did earlier that you can find on the Java YouTube channel that Anna did, where she goes over like all the details that you have to be aware of. So that's definitely a big change in the platform. But one other thing I want to show you, by the way, sequenced collections. So here's one thing. Wait, where'd my mouse go? Oh, I ran out of battery. Look at that during the live stream. So here's something I want to show you. Look at this. So it's not. Let me full screen this because people have been complaining earlier that it's too small. This is the largest I can make it. Look what I'm doing here. I'm having a list, a DQ, a sorted set, a linked hash set, some random data structures. What do they have in common? They have in common that they have something called an encounter order. Things in a list always in the same order. Things in a set, not generally, but things in a sorted set, things in a DQ, sorry, it's called a deck actually. Things in a linked hash set always appear in the same order. And how you can work with that? How do you get the first elements? There are these ugly methods. How do you get the last elements? That's even worse. How do you iterate in a reversed order? It's really weird. All of these data structures have something in common. They have an encounter order, but none of them exposes that. None of them helps you with that. And that's something where Java 21 really made an interesting change. It's not terribly large, right? It's not a big thing that's coming here. It's just a thoughtful evolution of a workhorse of everyday Java development, the collections framework. And what we get now is we get first in all of these. That's basically that's the whole big thing. We now have get first in all of this. I know that is not rocket science, but not everything has to be rocket science. We also get last. That's good, right? So now you can get the last element. But the biggest one,
increase the font.
It's the font that it is.
No, please increase the font.
It's the font size that it is.
Okay.
Right. So we also get the last element here. But the big change is, arguably, the most interesting one is how you iterate in reverse order. Because at the moment, this is different for all of them, and it's never nice to do. You can basically never stream in reversed order. But now, it's really simple. All of these now just have a reversed. It's list reversed, and then you just do a for loop over this. Or you stream over that, right? You want to stream over the deck in reversed order? No problem. Just do reversed stream. And there you go, right? So there are a bunch of new interfaces called sequence collection, sequence set, and sequence map. They were added in Java 21. And so yeah, you can start using them. There's not a preview feature. Put them in production, put them under pressure, put all your code that you want on these new collections.
That's very good, very, very good to find out. But these new collections can introduce some incompatibilities because, well, as they are new, some folks maybe have thought of already implementing it. So there are cases when people really needed these before this current implementation. So you might have some conflicts if you already have done these kind of tweaks with your Java code and kind of built your own sequence collection within your internal framework for your app. Moreover, speaking of incompatibilities, please check out the release notes of JDK 21 because there are a lot of fixes happening there, a lot of improvements that happened over bugs that were reported on the previous version that were a bit annoying. So please do check out those as well. Maybe you didn't know that that thing is happening and now is fixed, but it's good to be aware that if there was before a problem, now is fixed with JDK 21. And if you want to know more about the problems that you can have from upgrading from a JDK version, let's say 17 to 21, you can always check out YouTube for upgrade hurdles to Java 21 done by Nikolai. So Nikolai, speaking about changing things and moving to a new version of Java, what's new with pattern matching?
All right, that's been a big one, right? So over the last years, Project Amber has been working towards pattern matching and has made switch more powerful by turning it into an expression and more easy to use with the arrow syntax in there. It has started to work on type patterns. It has started to introduce sealed types. Records are great on their own, but records also play a role here. So all of these things really came together in Java 21. Now, for the first time, all the basic features are finalized, because one big thing that you definitely always need for that to really work out is a switch with patterns. So what I'm having here is a simple example where I want to do some math. I want to do some computation. I want to add 1 plus minus 2, 3 minus 4, the absolute of that. And the way that your calculator might do that, it will parse this and create this kind of node, this tree structure of nodes where we have an add node and a number node and a negate node, another number node. Right? You see where this is going. And now we want to evaluate this. And how do you do this? Well, I mean, node is an interface. So clearly, you can't just put an evaluate method here. That would totally work. And in this specific example, that would be the best way to do this. But there are cases where you want to separate the operations from the data structure. And let's say this is one of those cases. Again, specifically this one isn't, but it's a simple example. So in case where you want to put the operations elsewhere, you don't want to have maybe the evaluate method on this interface tree. So you want to have your own evaluate method. And how would you do that? And this is where pattern matching comes in. I'm just going to copy paste the code in here. No, wait, that's the evaluate code here. So can I scroll on further? There we go. And right, so this is one way to do this, right? I'm getting the node. And what I'm doing now is I need to figure out what kind of node it is. Is it a number node? Then, the evaluation of the number node is just the number. The evaluation of a negation node is the negative of the evaluation of the inner node. But the details don't matter here. How exactly I compute all of this doesn't really matter. What's interesting here is I'm switching over the type of node. And then, depending on which kind of node it is, I'm going to do the proper computation on the right-hand side. And all of this might raise some eyebrows. This seems not object-oriented. This seems fragile. This seems broken. Should we really do this? And if you have these questions, I get it. I had them too in the beginning, but there are good answers to all of those, and we're going to come to that in a few hours We're going to have a video on this that explains this from the ground up, explains all the language features that go in here. And they will end with a Q&A with Brian Goetz, the very person who created this. So you can ask your question there. Well, I mean, the very person. He's the head of a large team. So he's the very person who lets other people work on this. Maybe that's a good way to put it. And later, Brian will be here, and he'll be there to answer all your questions about this. I'm really excited about this because I think we don't do enough separation of operation from data. And I think this is going to make it easier and more common to do that in the future. So I'm really looking forward to that.
Somebody said that a case null is cool. Yes, it's cool. That is handled. Well, that was really cool. There are more changes in JDK 21, but we had only 30 minutes, and we need Billy, because he's the only one who could cover the changes in JDK 21 in less than, or more or less, 2 minutes.
Yeah, that's a good point. So if you want to learn about all these features in less than, like, if you think 30 minutes are still too long, go to inside youtube.com/Java and look for the Java 21 in about 2 minutes video. It's a good video, I hear.
Yeah. Well, my friends tell me that it's pretty easy to watch it and just get in touch with everything.
So we're both avoiding watching the video with Billy. Is that what I'm getting here?
No, I watched it.
Okay, you did. Okay, good.
It appeared in my feed in YouTube, so. Okay, well, this was fun. But now it's time for our first guest to join us. So we need some drum roll music or something.
No, it's too late now. Hi, David. You're on. No drum roll.
Oh,
hey.
Hello. Hi.
Hi, David.
Yeah, so you said you had something to show us when it comes to like experimenting with all these new features and how to get better used to them. What's going on there?
Yeah, so right now, if you want to play with those features, you basically need to have Java installed, especially when it comes to new features. I mean, you need sometimes to use the early access build to play with new Ember features and so on. So we have been working on features that basically helps you to explore those new features without having to go through to that. So let me share my screen.
Wait, are you saying I can experiment with these features without having Java on? I mean, for me, it's easy, right? I have like 20 different Java versions installed anyway. But so
Yeah.
those who don't can also experiment?
But you're a special case because it's basically your job to play with all the Java version. But so, and also, I mean, sometimes you just want to play with your feature and not having to deal with anything around. So we are trying to simplify that experience.
Yeah. Show us that screen, man.
Share my screen. So I guess that you know this website, right?
I've heard of it, yeah.
Yeah. So if you look at, we have a new tab, which is the playground. So if you click on that tab, we finally have the Java playground. So what is the Java playground? So the idea of the Java playground is basically an online tool that allows anyone to play and explore new Java feature without having to do any setups locally. So it's pretty simple. It has been designed that way. So we are providing a few examples. So you just pick one example. So this is the most basic snippets that you can get. You click, you run, and you get the result of the snippet execution. Obviously, there are two angles to that. Either you are a newcomer to Java and you want to basically understand how the Java language works, so basically how to do a println or how to do a switch and so on, or you are an experienced Java developer and you want to understand how the new Java language features works. So if you look at some of the examples that we're providing, obviously we're going to add more and more examples over time. So let's say, for example, we have a record, so text blocks, a simple text blocks. So you run the examples and you have the output. Now, if you look at the output, you might be puzzled why we have those space here. So that's how under the hood text blocks work. So we have added this checkbox that gives you the ability to get a little bit more details. So you see that, for example, here we are creating a message record. Basically, this block is creating a message record. So from line 1 to 3, we're creating this record. And then, so it's grayish, so it's not as visible. And then we have the output of the actual execution. So that's basically the idea of the playground. Obviously, well, it's a playground, so, well, you can get your hand dirty. So let's try to run that code, and obviously, it's not working. So let's try to fix that, and var name equals... example. So that's a pretty basic example, but I guess that you get the idea. And right now this is working with Java 21, and obviously as soon as we have JDK 22 builds that provide new relevant features, we're gonna switch to that. So again, you can keep working. You can keep using your existing JDK. If you want to play with the latest and greatest features, just go on the Java playground, and there you go.
Wow, that's really cool. So people already say in chat that they wish that one was around when they were learning Java. This would have made things a lot easier back in the days.
Yeah, but yeah, I agree. But there are a lot of challenges to basically do that. And I mean, it's the initial version, so there are some rough edges. So we're gonna improve it. Something to keep in mind. So this is not an IDE. So you're not gonna use the playground to develop your application. It's really meant to basically write snippets, run them, try to understand how things work, and so on and so on. So it's not an IDE, so that also means that we're not providing all the features that you might expect from an IDE, like, for example, code completion. There's nothing on the client side, so providing features such as code completion would be very difficult to achieve. Doesn't mean that we won't improve the user experience. That's something that we're looking at, but we just have to keep in mind that this is not an IDE. So this is in a nutshell what the playground is about. So this is the initial version, and it worked well with all the efforts that we're doing to try to make Java more approachable. So you know we have the on-ramp project. There are a lot of efforts related to that. And we can quickly discuss about what's under the hood. So you might remember that a few years back, we introduced JShell, right?
Yeah, it's actually, there's a comment. Look, let me read a comment from chat.
Yep.
Juan Moreno said,
Looks like JShell.
This looks like JShell, the cloud version. Do you want to say anything to that?
Well, let me share a secret. If you look at JShell, so JShell is first and foremost an API. And it happened that we have a tool that is using that API that is called JShell. And we all know the tool, but really JShell is first an API. And that's what we are using here for the playground.
Somebody asked, like, what website is this? So if somebody, yeah, that's great.
Yeah, so it's dev.java. If you don't know the website yet, you should check it out. Playground or not, it's a great site. So yeah, dev.java is a site that we run, which is targeted at developers, trying to help them get started with Java. And we're also going to have a little bit more on that later. We now have community contributions. Venkat Subramanian wrote an article on there, so we're going to go into that later. But for now, let's look at the playground. So yeah, so how you said JShell is also an API. So what did you do here?
But before we continue, that's a good segue to dev.java, because one of the ideas with the playground, if you look at dev.java, we have a bunch of tutorials. So what we would like to do from now on is basically embed directly the playground into the tutorial. So just imagine you have a tutorial on a specific API, like, for example, let's say switch expression, and you would have snippets in the tutorial page. And it happened that, well, if you click on run, that snippets would be executed. And obviously, you can change the snippet directly into the tutorial. So that's the idea that we're working on with the playground. So you had a question, Nikolai.
Yeah, right. So I was asking how JShell plays into this and how exactly this is strung together.
So, well, as someone mentioned, so this is JShell on the cloud. So basically, we are doing exactly the same thing as the JShell tool, but everything goes through the web. So we have these JavaScript clients that basically talks to a backend that is running on OCI, so Oracle Cloud, where we have JShell instance that gets requests, do all the heavy lifting of compiling the code, and sending back the results. And obviously, well, in the end, this is just Java bytecode. So obviously, we are doing a few tricks, I would say, to make sure that nobody abuses the systems.
Yeah, I can imagine that. So everybody can write code now and run this code in the cloud. That sounds like
Yes, that's correct. Now we have to keep in mind that the goal of the playground is basically to help developers to understand new Java language features. So basically, the playground is clearly focused around everything which is tied to Amber. So typically, we're not going to use the playground to to, I don't know, to do I/O, for example. It would be very difficult to, to provide a good experience with I/O on a website. So the only exception that the playground might play a role is everything which is tied to collections. So for example, sequence collection, we might have snippets that shows how sequence collection works. But typically, you won't use the playground, for example, for, I don't know, JavaFX application or those kind of stuff, which doesn't really make sense in that paradigm.
Yeah.
So yeah, it's really focused about the Java language and then some very specific API from core libraries, typically collections.
Yeah, I mean, like Java is getting easier to get started with in general, and I think this is also a great step in that direction. But I think, yeah, it's unrealistic to hope for this tool being able to, to create JavaFX applications, and then, while I'm at it, why can't I develop my Spring Boot app right in here? So I think,
yeah, and it's not an IDE, so it's not a development tool.
Yeah, exactly.
So it's something
it's there for exploration. And what would be amazing, like as you said earlier, like if the snippets that are on dev.java, if you could just if all those snippets just work, you can just like press a button, and then you can see the output of those snippets. We're not there yet. Like that will be a big chunk of work to get there, but would be really nice to have.
Yeah, and also, so you can see the result of the snippet, the default snippets, but you can also change the snippets to see how things will behave. So it will help you to understand the API from that given tutorial.
Yeah. So Geoffrey, who's, by the way, a guest later, asked, could the playground technology be used to build a Jupyter notebook for Java to mix documentation with executable code?
We have some ideas regarding that. It's a bit early to talk about that. But having said that, one of the features that we have in mind as well is, for example, having the ability to share snippets. We're not there yet because there are many implications. I mean, not really technical implications, but wouldn't it be cool if you just send to someone an URL, a playground URL, and when you open that link, you are presented with the right snippets that you can share. So we have this idea.
Yeah, that somebody asked about snippet sharing as well. You better make that GDPR compliant. Well, I mean, all of us are in Europe. Oracle sits elsewhere. It's going to be fun.
Yeah, but that's a good point. I mean, to use the playground, you don't have to log in.
Yeah, that's actually important, right? Like you can just use it. There's no
so that's
account. You don't get download emails later.
That's a plus, but I mean, it leads to other challenges.
Yeah. So people are asking where you can find the playground. Go to dev.java and then
dev.java. Yes, we have this playground tab or dev.java/playground.
Yeah, Billy's there in chat.
And so this is the initial version. We understand that it has some rough edges. So if you go in the About button, so there is a repo where you can fill issues related to the playground.
And a lot of people ask if there is a dark mode for the playground. It seems to be asked.
Add me to that list of people, please. Give us dark mode, David.
You should fill an issue, Nikolai.
That sounds like work, man. Yeah, so for all the people asking for dark mode, I'm 100% with you. I think we should get dark mode, ideally for the whole page. But look, we're Java developers at heart. We somehow ended up being a developer advocates. We're not like front-end developers, so cut us some slack. But we're gonna work on it.
No, but that's a good point. I mean, obviously we're open to suggestions, so we can't promise anything, but it's good to know what people would like to have.
Yeah. And somebody asked about rainbow mode.
Is that a thing?
I don't know. It would be scary a bit. We're developers, we just like darkness, not necessarily rainbows.
Yeah. Okay, good. Look, so David, is there any more you want to tell us about the playground, about these things? Because this is your last chance, so to speak, before we move on.
Well, the thing is that, so we have a good idea of what a playground should be, but there are some challenges. So, for example, what do we present in terms of output to the user, with keeping in mind that the user might not be an experienced developers. So it would be good if, people can provide us feedback and suggestions regarding the the experience that they think we should provide. But we should keep in mind that, well, we have developers that are going to use the playground, but we will also have less experienced developers. So we should basically try to find a model that fits the two type of population, because we want to make sure that the Java platform is more approachable. So the playground is just one way to simplify that onboarding experience. So we should not overlook that the newcomers, the people that are learning Java.
Yeah, that's a very widespread of, and that's also in general the challenge to talk about about Java's evolution. Like, there's a wide variety of people that you want to catch up on, right? Like, it's beginners, but it's also experienced Java developers. It's also like people like architects who maybe don't code Java every day anymore, but still want to keep up to speed with what's happening.
Yeah.
So yeah.
Yeah.
Good. Oh, Chris Wilson, you said, did he just say they are Java backend developers and they don't have front-end developers? I'm just saying that this team here personally, we're not big on the front-end development part. We're doing it, but we're not front-end developers at heart.
It's a side effect. It's a side effect.
Yeah, exactly. So not talking about the development in general, just about us on the team here. Yeah, cool. That's really nice. So we got a few minutes slack before we start with the next topic. So I saw earlier there were a lot of questions in chat, and I think now we may have some time to get to some of those. So if you're in chat and you're curious about one thing or other, oh wait, that's not looking like this, and you have some questions, feel free. Now's a good time to ask them. And in the meantime, while you gather your questions, Anna, you wanted to tell us a little bit about making it easier to get started with Java, right?
Yep. So also in JDK 21, there is a new cool feature to start with Java. So you can, of course, go on the playground and play around with Java, but there's also another way to do that. So let me share again my screen. A sec.
So in the meantime, I'm going to answer a question. When does Java add an AI library to the JDK? That's an interesting topic. Well, not in Java 21, I can tell you that much. And the work that OpenJDK does on Java on OpenJDK is less focused on finding one library out of many and pulling that in. The question is more, what is stopping other people to develop AI libraries on Java and to get those roadblocks out of the way? So I don't see an actual AI library personally. I'm not speaking for OpenJDK here, I'm not a member, but I don't personally see an AI library in Java anytime soon. What I see is more roadblocks being removed that make it possible for a variety of AI libraries, for all the powerful AI libraries that are out there to be potentially implemented on Java, or at least easy to execute from Java. So that's a much more likely thing to happen. So I would look out for that. And that things play in there like Panama, which makes it easier to run native code, value types, which make it easier to create custom types that still run with high performance. So those are the kinds of changes that we're looking at in the future. And it's not pulling a specific library onto Java.
Thank you. So now getting back to getting easier with Java, I think we all started, as experienced Java developers, we all started.
Anna, can you like increase the font size and maybe close the terminal at the bottom? People were asking about the terminal earlier. That was apparently a big sticking point. How dare you have a terminal?
I will need the terminal in a bit, that's why.
Okay.
So it probably all started with public static void main, and we have done the hello world like this. And a second. And yeah, but we're not using the args here, right? So we're using this just to print hello world and nothing else we're doing with the args. So starting with JDK 21, we don't need this to run our hello worlds. Moreover, we don't need this much ceremony to make it public static void main just to print hello world. And sometimes when we start with Java, yeah, we just want to print stuff. So we might not need this as well. Now, you can see the IDE has some issues with my code because it's still having some trouble interpreting this. This is a preview feature, so it's not final. To run this, I know you were upset about the terminal, but I need it. So sorry. I will run this like the classical way with Java -- enabled preview, source 21. And of course, I need the path to this. Copy path. going to go like this. And yeah, I get, of course, some notes, uses preview features from Java 21, but still prints hello world. Let me see if I can turn this
Where's
off.
the rest of the class? What did you do to it?
It's simplified. Do you need that? I don't. I was just
Wow.
wanting to print hello world, so why
Look,
do
when I talk to people who are new to Java, that's how I spend my time. I explain to them what public means and what class is and what static is. It makes me feel accomplished. What, now I just tell them write the code and it works?
Well, yes, but this is the case of just starting with Java. If you're like running complex applications, of course, you're going to still work with packages. Of course, you're still going to work with class names, but still, you're just going to replace this in the cases where you just want to test something very, very easily. And, speaking of, simplifying things, there's another change in JDK 21 with the name variables, because sometimes we're using variables just for the, testing that let's say a file can be opened, or you can write to that specific file, but maybe not use the variable further. Or maybe you're using variables in Lambda, but you're not doing anything further with that variable in Lambda. So the underscore is back, folks, in JDK 21. So you can try that one as well.
Yeah, that's a good one. So you're using underscore for variables that are not used. That you could do that on Java 8 where it was deprecated, and then Java 9 took that away. And that's when I first heard about it. I was like, why is the single underscore being taken away? And I heard already back then you could know that on the mailing list it said we're going to use the single underscore later in the future to symbolize that we don't need this variable. I was like, damn, I need this occasionally. So I just started using 2 underscores for that, but they don't get any special handling. So if you have 2 of them in scope, you go to 3 underscores. Fortunately, I never had to go to 4. But yeah, I'm really happy with the single underscore. It's a preview feature. But yeah.
But I've seen
earlier. Sorry, yeah.
I've seen somebody writing a comment, I think, somewhere, saying that they already used that in their code. Like, they coded their own singleton that does that with double underscores. So that would be interesting.
Oh yeah, yeah. That's an interesting point here by SciTech Explorer. Oracle should now push everyone in enterprise to move their version from 8 to 11 to 17 to 21. It would be grateful to Oracle. So this is. Look, I'm not talking for the company here, right? I'm just talking for myself and for our team. We just want everybody to be on the latest and greatest all the time. Please go to 21. And you know what? In 6 months, go to 22. Just do it. Like, the world is not going to start burning. It will be okay. And yeah, I totally want to. But the thing is, enterprises do have reasons, and as developers, it's not always easy to agree with those reasons. But they are what they are, and some companies want to stick around. And on old versions, you know what? It's not the worst thing in the world. Because that way they often have support contracts, and so in the end they end up paying for Java development one way or another. So I think it's kind of a win-win. Everybody used the new version, that's great. If lots of people stay on old versions, that's okay too. Also, although as developers, nobody wants to be invited to work on a Java 8 code base at this point, right? Well, not nobody. Some people do work on Java 6 or 7, so it might be a step forward for some. But yeah. And I think actually that could be a good argument. Like, if your management has trouble seeing why they should invest into upgrading their Java version, why don't you tell them, look, if you have trouble finding developers, who do you think is easier to hire? Somebody you have to tell that they will be working on Java 8, or somebody you can tell they will work on Java 21? Because all things being equal, I know which job I would pick. I mean, it's not the only concern, don't get me wrong, but it is a concern. I want to work with. I don't want to hear about text blocks and then not use them for another decade.
Hey, Nikolai, so there is a question, so I'd like to answer. So it's about the playground. So does the playground let us use a preview API? If they fit within the scope of Amber, yes. So you can use the preview features that are coming from Ambers in the playground. That's also the idea.
So no vector API and no foreign function memory API.
Foreign function, it's hard. Well, it would be hard to find a good use case to use foreign function and memory API with the playground. Vector API, TBD. I mean, it might help to understand a little bit the vector API. So if that's the case, we could do something related to that.
Right. So it's important to understand there's a difference, right, between preview language features, preview APIs, and incubating APIs. So preview language features, I think, will probably all work, and preview APIs. And incubating APIs as well, that depends on like where they land and whether they make sense to run. Like, again, like we're executing other people's code here. So, maybe you don't want to run their native code too. So those concerns are important here as well.
Yep.
Well,
okay, yeah. The question was about, what about long-term support? So should we only run long-term support versions? Which versions are long-term support and all that? So I made a video on that recently, and I got into some hot water. Not everybody agrees on the specific nomenclature, but let's just say, yes, Java 8, 11, 17, 21, you get lots of long-term support from lots of different vendors, and that's good. That's helpful if you don't want to update to 22. But what about updating to 22? Is anything worse with 22 than it was with 21? And the general answer is no. Within OpenJDK, which produces the binaries, not the binaries, but which produces the source code that we end up running as our JDK, all of that is on 22 just as good as it was on 21. The only theoretical difference, or the only theoretical risk that you're running into, if you update to 22, you will not find anybody giving you support for that after 23 came out. So you're forced to go from 22 to 23. And Java is making some changes. I forgot to mention earlier, for example, the removal of the security manager. It's not removed yet, but it will be removed at some point. So there are some features that get slowly phased out. And let's just say, and I'm making this up, it's very important, this is hypothetical numbers. Let's just say you are on Java 22 and you're using the security manager and 23 removes it. Then updating from 22 to 23 might be a problem for you. But you don't get support on 22, so you would have to go back to 21. And that's the theoretical risk why long-term support, why versions that have long-term support seem more interesting to many companies and many organizations. And you got to ask yourself, what are you in here? Like, are you in a situation where you worry that a future Java update will break all your code? And I think probably look what happened after 11, right? 6 months releases after 11. How many problems did you have going from 11 to 17 and from 17 to 21? And if those were fine, I think there's a good chance that you would just as fine going forward. And then there's no reason not to update to 22. It's very important to understand 22 is not an alpha or beta version of an upcoming LTS version. That's not a thing. 22 goes through exact same quality assurance, has the exact same the care taken of that any other Java version has. In fact, within OpenJDK, the concept of support doesn't even exist. Within the community that produces the source code that you're eventually running, long-term support doesn't exist. Long-term support is something that companies put outside of that. So OpenJDK doesn't care. They produce the same quality for 21, 22, 23, 24, and all of that. So that's my spiel on that.
Well, that's good. It was kind of fun, but maybe now it's time to watch a video.
So yeah, so there are questions actually pretty good. There are some questions about virtual threads there at the bottom right now. And so what we can do now is we can have Jose, who's at the moment running an event in Paris with the Java user group. We're going to see that later live. But for now, we're going to have Jose out of the box telling us about virtual threads. And once that's done, takes about 25 minutes, the video. Once that's done, we're going to have Ron Pressler here for a Q&A. I'm really looking forward to that. See you later.
This episode, you will learn everything you need to know about virtual threads, one of the major new features of the JDK 21. You will learn why they have been added.
That worked like a charm.
So that's not working well, huh?
Yeah, but also you're in the dark. So your camera probably decided to take a break. Along with the video. Yeah. Well, Jose will be with us soon in the video, and Ron Pressler as well in the live stream. Let's see. Okay. Hi, Billy. Good to see you. You're on mute.
There we go. So yeah, running live streams. We're doing it live. Can always be a bit fun.
Oh, no, I understand. You kicked out Nikolai to take his place.
Exactly. That is exactly what I did. And so it's actually a good time also we can tease Nikolai while he's not
What?
here.
I have a technical issue and immediately Billy swoops in to steal my thunder?
I
Hey,
mean,
this is what I do.
your camera was not working, so somebody had to save the day, and it was Billy.
Okay, should we try this again? I'm not confident. Should we try it again?
Okay.
One more time.
One more time. Okay, so let's try this again. You know what? Maybe in the meantime, somebody can post the video link in the chat, so people can just watch it on YouTube native. But I try it again.
No, we don't want people to leave us. We want them to stay here, watching us fail and succeed at some
That
point.
does not sound like a healthy relationship.
Hey, developers don't always succeed. We have to always try to make our best until we succeed, of course.
Okay, actually, but that's why I cannot hit the damn share button here. Excuse the swearing.
It's because you don't have a Mac, right?
I think we need a mute button, the censor button for Nikolai.
Yeah.
I'll get there eventually. I have there's so many options. It's just we have to find one that works. Yeah, that's actually an issue because I cannot share anything with sound at the moment. Can somebody of you try to share a Chrome tab with sound? Because I can't.
Give me.
That just doesn't let me. I'm sorry. I'm sorry, folks out there. It's my bad.
All right, give me one moment. I'm starting up it now.
It's my turn to kick Billy out of the show. I'm quoting.
One moment.
Then Vega says, let's just watch Billy's cats.
That's a good thing. Call them, Billy.
Well, if I could better move my camera, I would show you Lulu is over here sleeping in her bed.
Wake her up. She has to show some her knowledge of Java.
At least everybody's having fun.
All right. Almost ready. Almost there.
Yeah, we're getting there. God damn it.
Okay.
Sorry, I'm swearing on stream. I shouldn't. It's like,
Present. Share
is
screen.
this not working?
Somebody said, let's make the Java launch
Virtual
stream a
threads.
cat video.
Yeah. Okay. And we'll add that, and hopefully sound will work.
Well, how are you sharing this? As a tab share?
Yes.
Then it should technically work, but I didn't hear anything just now.
Do you hear anything?
Nope.
Oh boy.
So if you go to share screen and then you have the Chrome tab sharing, that at the bottom it says also share tab audio.
I don't see it. One moment. Let me try stopping. And
How many developers do you need to play a video?
Yeah.
Apparently more than 3.
if you like to share audio, yeah, I see it. It says use. Maybe one more try, and we'll see if this works.
I don't hear it.
I'm not sure. This is a Chrome tab, and
I just do the same thing again. I figured out how
Okay.
it technically could work. Let's see whether it does. Let me see.
About virtual threads, one of the major new features of the
Anybody hear anything?
21.
yes, yeah, we hear it.
The platform thread. This is exactly the role of a virtual thread. And instead of blocking the platform thread, it unmounts itself. You will learn why they have been added to the JDK, how you can create them, how you can use them, what performances you may expect from them, and how they are working under the hood. Let us start from the beginning. Why virtual threads have been added to the JDK. The effort to add them was huge. It took years. The pull request on the JDK was massive. so there must be a good reason. Virtual threads are there to solve a problem that has to do with asynchronous programming. So let us start from there. Suppose you have to query a remote database for a user object. You have the name of the user and you need to fetch the full user object from your database. You are probably going to write this kind of code. First, you need to create a request with all the information needed, probably in the form of a JSON object, and then you need to launch this request on the network. After a while, you get a response, probably in the form of another JSON object, and then you unmarshal this object to recreate your user object. This is the kind of code you end up with. Simple to write, simple to read, simple to debug, simple to test, and simple to maintain. How busy could your CPU be when it is performing this request? Well, the first step is pretty simple. It's just in-memory computations, so you can assume that it will run in the order of several tens of nanoseconds. The second step is a request over the network. This one takes much longer, probably in the order of the hundred of milliseconds. And your CPU is not doing anything during this time. It's just there, waiting for the response to come from the server. And then the third and last step is also in-memory computation, the unmarshalling of a JSON object. So that's another tens of nanoseconds. On the overall, this code executes in about 100 milliseconds. So to compute how busy your CPU is, you just need to divide the time it takes to prepare the request and unmarshal the JSON response, that is several tens of nanoseconds, and the time your CPU is waiting for a response from the server. And that gives you 0.0001%. That's the order of magnitude. In a nutshell, your CPU is idle during this request. The first solution you may be thinking about is to launch more than one request in parallel. And the classical model is to have one request per thread and launch as many threads as you can. This has been working for years ago. The real question is, can you keep your CPU busy 100% of the time with such an approach? So let us do the math. How many threads would you need to keep your CPU busy 100% of the time? Well, the math is actually pretty simple. With 10 threads, you have a CPU usage of 0.001%. 100 threads will give you 0.01%. With 1,000 threads, you can expect 0.1% CPU usage, and with 10,000 threads, 1%. To have a CPU busy 100% of the time, you actually need 1,000,000 threads with this model. It turns out that a thread in Java is actually a thin wrapper on an operating system thread, sometimes called a kernel thread or a platform thread. And these threads consume quite some resources. Typically, creating a thread takes 2 megabytes of memory upfront, so creating 1,000,000 of them would require 2 terabytes of memory, which is a lot. But there's worse. Creating a kernel thread also takes time, in the order of the millisecond. So creating 1,000,000 of them would actually require 1,000 seconds, which is a little more than 15 minutes. Actually, if you try to create threads in a loop, depending on your operating system, you'll probably hit a limit long before that, at about a few thousand threads. So if you use this approach, you will quickly reach that limit, and your CPU usage will still be very low, in the order of 1%. So unfortunately, the solution that consists in creating one thread for each request is not a viable solution to increase your number of requests per second. This has been known for years, and this is why other approaches have been explored with success. If you take a step back and examine the initial problem carefully, you can see that you have actually two solutions to improve this situation. On the one hand, you want to increase the number of requests per second. To achieve that, you need to launch your requests in parallel. Launching one request per kernel thread does not lead to viable solutions because kernel threads are way too expensive. So at this point, you have indeed two solutions. Either you create a new type of threads that are less expensive than the current kernel or platform threads, or you launch more than one request per platform thread. Launching several requests per thread means that you cannot write your code using the imperative approach anymore. What you need to do is to split this code into small atomic operations. Each operation gets inputs, is doing one thing, and produces a result. So what you need to do is to write all these operations as lambdas, and then you need to wire them together using an asynchronous framework. In a nutshell, the job of this framework is to call your lambdas with the right inputs, to get the outputs, and to transmit these outputs as inputs to the next lambda you defined. What you are creating are pipelines of operations that process your data and that are executed by the framework you are using. The responsibility of this framework is to correctly execute your operations in the right order and distribute them among the threads it has to keep your CPU busy and your number of requests per second optimal. At some point, one of your lambda will launch a request on the network. It should then immediately return to make sure that it does not block the thread that is running it. Avoid writing blocking lambdas. If your lambda is done, then the thread has nothing more to execute. It is free to do something else. Your request has been launched, and there is a handler somewhere that will trigger a signal when the response is there. Your framework knows this handler. It knows when the data from the response is available. Then it is its job to run your next lambda, the one you define that will react on this data. This lambda is invoked once again by your framework with this data as an input. Because these two operations are two different lambdas, the framework thread can do something else in the meantime, like launching more requests or running other lambdas. There is obviously an overhead in doing that. Nothing is ever free, but it is still much cheaper and much more efficient than blocking a thread. This second solution has been thoroughly explored and optimized over the last 10 years, and this is what asynchronous frameworks are doing with great success. Using this technique, you can dramatically increase your number of requests per second, and you have many frameworks to choose from to do that. What does it require from you as a developer? Well, you need to change the way you write your code. Remember, you need to create these atomic, non-blocking lambda operations. Now, I would like to take you through an example that I borrowed from Tomas Langer, a famous author and speaker, and a renowned expert in asynchronous programming. The problem you need to solve is the following, and it's a very classical problem. A user is doing some online shopping, and what you want to do is make sure that everything is saved in a database and that you send this user an email with a receipt at the end of this transaction. The first step consists in making sure that the user is saved in your database. Then you fetch the shopping cart, and then you loop over the items that person chose to compute the total price. Pretty simple. And then you invoke the payment service and record the transaction ID. And with all these elements, you send the email with all the details of the transaction. All this is pretty easy, pretty straightforward, and the code is simple enough to understand. Actually, anybody can easily check it to make sure that the business process has been correctly implemented, because it's just a simple piece of code. If you need to debug this code for some reason, executing it step by step is easy. Writing unit tests, because you write unit tests, don't you, is also super easy. More than that, if there is a business requirement that tells you, oh, if a person spends more than 100 on our site, we would like to give that person a coupon. You know exactly what to do and where you need to add your code. And this code is going to be very simple. So in a nutshell, everything you need to do with this code is easy, because it's just a piece of simple, imperative, step-by-step code that exactly maps the business process that was specified. It's almost boring. The only problem is that, as you saw, it will not scale. And what you need to do is to adapt this code to the asynchronous framework your application is using. What would it look like to adapt this code to the Completable Future API? The Completable Future API is part of the JDK, so it's pretty easy to set that up. Well, it looks like this, and that's a problem. Do I really need to go through all the problems that this code has? The imperative version of this code was easy to follow, and thus it was easy to spot in the code if a mistake was made in implementing the business process. In this mess, how can you check that? Let me just highlight the portions of your business code in it. What you see is that they are drowned in a mess of technical code, making it super hard to understand how these pieces of code actually work together. Even the types written by these elements of business code are hard to spot because they are not there. See, what is the return type of this call to payment service.pay? How can you check that you are returning the right thing? And now suppose that you need to implement the new business requirement we just talked about a minute ago. If a person spends more than 100 on our site, we need to give that person a coupon. Where are you going to add this code? And how can you add it in this mess? But that's not the only issue, unfortunately. Debugging such a code, for instance, running it step by step, is next to impossible. Writing unit tests is also super hard. All you can test is the process as a whole, which is not really a unit test anymore. These are the most obvious caveats, but unfortunately they are not the only ones. If something goes wrong in the imperative version of the code, the stack trace will give you the exact context in which your code is running. You know exactly where you are and what element of your application actually called you, because it's there, written in a stack trace. All the lambdas you wrote in the asynchronous version are executed by your framework, and they are executed asynchronously, which means out of the context of your business process. The element of your application that triggered this processing was just there to declare your processing pipeline, and it's now gone, doing something else. It is not waiting for any response anymore, meaning that it is not in a stack trace anymore. The real element that is running all these lambdas, getting the results and forwarding the results to the other lambdas, is your framework. So if you examine the stack trace, you do not see your application context. All you see is your framework calling your lambda. It also makes exception handling super hard. If you're lucky and an exception is thrown within your lambda code, then the stack trace will take you there and you can do something. But if one of your lambda returns a null value, for instance, that triggers a null pointer exceptions in the framework code, then you're in trouble because the stack trace does not tell you where this null value came from. Suppose one of your lambda does not return because it's waiting for a response that is not coming. If you're lucky, you have a timeout somewhere that was set up in your code. But then again, the stack trace tells you that a timeout exception was thrown with no information about what lambda actually triggered the timeout. And if no timeout handling was set up, then you have a stranded lambdas that is preventing a process from producing a result. This lambda is lost somewhere in some event queue, never to be activated again, and next to impossible to spot. Not having a meaningful stack trace has a cost. It makes your code hard to debug, and for the same reasons, impossible to profile. Asynchronous programming can give you great performances, but the cost of maintenance is actually super high. It's not an ideal solution. So if we step back to our initial problem, you know that the asynchronous approach can dramatically improve your request per second performances, which is what you need, but you also understand that it comes with a cost, which is mostly the maintenance cost. So now you are left with the first solution, which was making threads less expensive. Before we move on, we need to answer a question. Less expensive by what factor? What do we need to make it so that you could solve your CPU usage problem just with less expensive threads and not having to rely on asynchronous programming anymore? Well, the answer is in this little table we did previously. We need to be able to launch in the order of 1 million threads. What we can do currently is launch in the order of 1,000 of them. So we need a new type of thread that is 1,000 times less expensive than the current model to be able to launch 1 million of them. If this can be achieved, then writing your code in an imperative blocking way becomes compatible with the number of requests per second that you need. And you will not need to write asynchronous code anymore. Would it work if the gain is only 100 times less expensive instead of 1,000? Well, no, because in that case, your CPU usage would be only 10%. And if the gain is 500, then the CPU usage would be 50%. So to reach max throughput, you would still need to rely on asynchronous code. And this new type of thread would actually be useless. So gaining a factor of 1,000 is actually the minimal gain you want to achieve. And this is what virtual threads are giving you. Virtual threads from the JDK 21 are much lighter than platform threads by a factor of more than 1,000. You can easily launch 1 million of them, even on a small machine. Virtual threads are so lightweight that you do not need to pull them anymore. When you need one, just create it and let it die when you do not need it anymore. What is the magic trick that makes this possible? Well, when it comes to computing, there is no magic trick, just engineering, and in that case, very smart engineering. Underneath, you still have platform threads, because this is the tool operating systems are using to execute several tasks in parallel, and you cannot avoid using them. So the trick is still about running several tasks per platform thread. A virtual thread has to run on top of a platform thread because there is no other solution. And if you want to have 1 million of them, it means that they need to share these platform threads. Let us first create a first virtual thread and run it. For that, let us go back to our previous example and let us make the imperative code we wrote a runnable so that we can run it in the thread we create. And then you need to create a virtual thread, which is very easy too. You now have 2 factory methods added to the thread class, of virtual to create virtual threads, and of platform to create, well, platform threads. Of course, you can still use the old pattern that is calling new thread directly. You can then use one of the methods available on the builder you get to create exactly what you need. You can set the name, you can allow or disallow the use of thread local variables. And by the way, there is also a factory method that has been added to the executors factory class called new virtual thread per task executor. The executor service you get actually creates a virtual thread on demand every time you submit a task to it. It does not pull anything. This executor service may be very useful if you have a concurrent application, for instance, built on such an executor service, and you want to check what kind of gain virtual thread can give you. And then, because a virtual thread is a thread, you can do with it everything you can do with a regular thread. You can start it, you cannot stop it or suspend it, or you can join it, for instance. There is one thing that you cannot do with a virtual thread, which is you cannot make it a non-daemon thread. A virtual thread is always a daemon thread, so having live virtual thread in your application will not prevent it from exiting. It also means that all the problems you may come across with platform threads are still there. Race conditions, deadlocks, visibility, tierability, all this good concurrent programming stuff is still there with virtual threads. So be aware of that. But the good news is that it also means that all the solutions that you know to ensure the correctness and the safety of your code are also the same. Now, let us take a closer look at how things are working when you are executing the code from our example. What is happening when a virtual thread is executing a runnable? Internally, there is a special pool of platform threads, which is, by the way, a modified fork join pool, that is there to run your virtual threads. So your virtual thread is mounted on a platform thread from this pool, and your task is executed by this platform thread through your virtual thread. If you print a virtual thread, you will get this result. It shows you that your virtual thread is mounted on the worker one of the fork join pool 1. How many such platform threads do you have? Not that many, actually, one for each core of your CPU. At some point in our task, the code is making a request on your database. It is calling repo.contains_user. This is a blocking code, and you know that you want to avoid blocking a platform thread. This is exactly the role of a virtual thread. Your virtual thread detects that it is actually executing a blocking I/O operation. And instead of blocking the platform thread it is running on, it unmounts itself from this platform thread, moving its own context, that is its stack, to somewhere else in a memory, namely in a heap memory. What is happening under the hood is the following. A virtual thread is actually executed by a special object called the continuation. This continuation object is in the non-public part of the API, so you should not use it in production. This continuation has a run method that executes your virtual threads, and that in turn executes your task. When a blocking call is issued in the Java NIO API, for instance, a call to continuation.yield is made, and this is the call that unmounts your virtual threads from the platform thread and copies the stack of your virtual thread to the heap memory. Of course, continuation.yield is only invoked if this blocking call is being executed in the context of a virtual thread. It works like your virtual thread was saying, hey, I won't be needing the CPU for a while because I'm waiting for a network response. So please remove me from this platform thread. And by the way, blocking calls are not found only in Java NIO. Actually, all the blocking calls you can think of in the JDK have been refactored to call this continuation.yield. And that also includes the synchronization objects from Java util concurrent. And then at some point, the data from the response is there. The operating system handler that monitors this data then triggers a signal that calls continuation.run. And this call to run takes the stack of your virtual thread from the heap memory where it has been saved previously and puts it in a waitlist of the platform thread it was mounted on in this fork pool. Because this is the way the fork pool is working, if this thread is busy and another thread is available, then this other thread will steal this task from the first thread. So you may observe that your task actually jumped from one platform thread to the other while it was blocked. This is how virtual threads are working under the hood. As you can see, no magic, just very smart code actually doing wonders. What is the cost of all this, and are there any caveats? Well, there is indeed a cost, and there are indeed caveats, so let us go through them. The cost of running a task in a virtual thread is the cost of running in a platform thread plus an overhead. So it is more expensive to run a task in a virtual thread than running it in a platform thread. Let me say that again. It is more expensive to run a task in a virtual thread than running it in a platform thread. So why would you do that? Because the cost of blocking a virtual thread is tremendously lower than blocking a platform thread. What is the cost of blocking a virtual thread? Well, it's the cost of moving the stack of your virtual thread, that is several tens of kilobytes, from the stack to the heap memory and back. It's not free, nothing is ever free, but it is certainly much, much, much less expensive to block a virtual thread than to block a platform thread. That would include the probable context switching that you will have to pay. So running a task in a virtual thread is interesting only if it is a blocking task, because there you will have this gain. Running a task that is doing only in-memory computations in a virtual thread is useless. Don't do it. This is not why virtual threads have been made. Don't run your parallel streams in virtual threads. You'll actually degrade your performances. You are not doing I/O in your parallel streams, right? If you check how the JVM is working, you will see that the just-in-time compiler is still running in a platform thread, and the same goes for the garbage collectors, for instance. These are in-memory computations. They do not run in virtual threads. The caveat you need to know has to do with native code calls and synchronization. Moving this stack around is okay as long as your code is not playing with addresses on this stack. You cannot get an address on a stack in Java, but you can in C or C++. And your Java code may call some C code or some C++ code. So if the JVM detects that you have native calls in the stack of your virtual thread, it will pin this virtual thread to its platform thread to prevent it from being moved to somewhere else. And a problem you may have heard before is that the synchronized block behaves in that way too. If you have a synchronized block in your stack, then your virtual thread is pinned on your platform thread. What can you do if you are in this situation? Well, your first reflex should be to do nothing and assess your code precisely. A performance problem may occur if you pin a virtual thread on a platform thread for a long time. If your native code or your synchronized block is only doing some in-memory computations that will take in the order of the hundreds of nanoseconds to execute, then odds are that you will not see any performance loss. It's the case if your synchronized block is guarding some in-memory data structure to ensure its correctness, safety, and visibility. On the other hand, if you have some I/O operations in this synchronized block that can pin your thread for hundreds of milliseconds, then maybe it will be a good idea to do something about it. The good news is that you can replace your synchronized block with a reentrant lock that will do the same without pinning your virtual thread. But remember, you don't have to do that. There are still many situations where pinning a virtual thread on its platform thread will not affect your performances. As usual, when it comes to performances, measure, don't guess. All right, let us wrap up all this. Virtual threads are a new kind of threads in the Java space. They are cheap to create, you can have a million of them. Cheap to block, you do not need to rely on non-blocking asynchronous code anymore. Running some blocking code in a virtual thread is just fine. Please do it. You do not need to pull them, create them on demand, and let them die at the end. This is what the JDK is doing. You should only run blocking, typically I/O code in a virtual thread. Running in-memory computations is useless. Don't do that. And remember that when you run some native code or when you do some synchronization, your virtual thread is pinned on its platform thread. That may be an issue if you are doing some I/O operations in your synchronized block. One last word, odds are that you will not work directly with virtual threads in your application, but don't worry, most of the great frameworks you know are already supporting, or at least working on supporting, virtual threads, and that includes Jetty, Vertex, Tomcat, Spring, Quarkus, Spring Boot, or Helidon. So yes, that's a lot. If you want to learn more about virtual threads, don't forget to check the descriptions. I just added link to other resources that you may find interesting. If you're interested to learn more about the other new features of the JDK 21, you can also check the other episodes of this series. Again, see the links in the description.
Good to see you again.
Hey, welcome back, everybody. So, I hope you all spent some good time with Jose and learned a lot about how virtual threads work.
Yep, there were a lot of questions before, I think, the video, like what is the difference between virtual threads and platform threads? And a lot of people probably were not knowing that. So I hope that the video clarified that now. And if it didn't clarify, we have a guest that knows everything about virtual threads. Welcome, Ron.
Hi Anna.
Hey, Ron.
Hi Nikolai.
So prepare for the questions. So now, people, it's time to ask all your burning questions about virtual threads, about Project Loom in the chat so that we can address them to Ron directly. Let's start with an easy one. Some use cases for the virtual threads now that they are, available without any enable preview needed to work with them.
Okay, but before that, I want to address something that Jose said in his video. He said that you don't need to pull virtual threads. I would say something much stronger than that. You must never, ever pull virtual threads. If you're pulling virtual threads, you're doing something wrong. Now, as for your question, Anna, use cases, I think the canonical use case that would benefit the most from virtual threads, and the primary one we had in mind, is servers. So if you have any kind of server that serves concurrent requests from many users, many other services, virtual threads aren't for you.
Thank you for the answer. And another question that was earlier in the chat, I mean, not question, but somebody said that, well, this is, and the new virtual threads are going to put more work on troubleshooting, debugging, and well, that's not actually the case. Do you want to tell us more about how virtual threads have great observability as well?
Yeah, so one of the most important requirements that we had, and one of the biggest challenges for the implementation was to provide the same kind of observability and debugging experience that people have with platform threads, a virtual thread. And perhaps the most basic thing to remember is that virtual threads are real Java threads. They are threads. So everything you have for platform threads, you also have for virtual threads, and that includes a debugger experience, profiling and observability with JFR. As for stack dumps or thread dumps, you do have the same capability almost, but it is a bit different. And the reason is that I would say the only difference between platform threads and virtual threads is that you can have a great many virtual threads. And in fact, sort of our assumption is that if you have one virtual thread, then you have at least 10,000, or at least 1,000. Because the reason to use virtual threads is to have lots of threads. Now, if you were to get an ordinary thread dump with 1,000 or 10,000 or 100,000 or a million virtual threads, it would be quite inconvenient, number one. And number two, the way that the thread dump for platform threads works is that it stops the VM in order to obtain, it gets a snapshot of the threads. And stopping the VM to get a snapshot of a million virtual threads would be not the right thing to do. So we have a new kind of thread dump that you can obtain through the jcmd command or with the thread mbean, and that gives you the stack traces for all virtual threads. Currently, the one thing that's missing is lock information. We hope to have that added in 22. Another difference is that it's not a snapshot. So the virtual threads are obtained concurrently with the application. So it's possible that you won't get, the application isn't paused, so you won't get necessarily a consistent view, but in most cases, that's good enough for what you want. Oh, another thing I forgot to add, because you have so many threads, the best experience is not by reading the thread dump, on the screen. You might want to analyze the thread dump with some tool, and that is why the new thread dump for virtual thread offers JSON output to make it easier for tools to parse and process.
That sounds very cool. So, question that we had in the chat, there's a lot going on in the chat, is Satellite was like, what is the actual native mechanism used to implement virtual threads? Fiber's user mode scheduling?
I'm not sure I entirely understand the question, but in the VM, so virtual threads are implemented in the Java core libraries in Java, but we've added a mechanism to the JVM called continuations, and I think Jose mentioned those. And that is a mechanism that allows us to suspend a computation, like in a runnable, capture its state, and later on resume it. And that is sort of the basic, let's call it, native mechanism that the implementation of virtual threads uses.
And now another question about how virtual threads compare to asynchronous programming.
The goal is similar. If you have, in order to understand what the problem is, so first you have to go back to the problem, and the problem is, so imagine you have a server, and you have some number of requests that are being processed concurrently, and every request on average takes a certain amount of time. There is this law from, it's a mathematical theorem from queuing theory called Little's theorem or Little's law, that says that if you have a certain number requests arriving at a certain average rate, each of them taking up a certain amount of time on average, then you need some number of them to be making progress concurrently. That's a number of requests or transactions inside the system, and quite often that number can be very high. So if you have normal blocking Java code that hangs on to a thread from the time that at least one thread, could be more, but at least one thread from the time the request has started until the time it's dispatched and completed, then if you have a large number of concurrent operations, then you will need a very large number of threads. And there are two ways of addressing that. One is to say we will not capture a thread for the entire duration of the operation, and that is asynchronous programming. But that requires completely changing how you write your code. That requires a completely different set of APIs. It's a completely different programming paradigm. And the other way is to say, let's allow you to have lots of threads, and that's virtual threads. So they solve the same problem, but in a very different way. You could say that the choice between the programming styles is a matter of personal preference, and that is true in theory, but it's not entirely true when it comes to the Java platform. And that is because the Java platform itself has been designed specifically to address the synchronous programming style. And we talked about observability before. So Java debuggers assume that code progresses sequentially on a thread. Thread dumps and profilers assume that operations are grouped by threads. Exceptions assume that the context of an operation is a thread stack trace. And that paradigm of synchronous programming is built very deep into the Java platform from the VM through the libraries to the language. So even though you could imagine a different language, say Haskell, that it's a great fit for asynchronous programming, if you use asynchronous programming, regardless of whether you like it or not, the Java platform can offer you much less than it could offer regular synchronous code. So to circle back to the beginning of the question, virtual threads address the same problem. They allow higher scales or higher throughputs for a server that's under heavy concurrency, while maintaining the same synchronous programming style that allows the Java platform to give all the observability, debugging, and tooling benefits. You can use all the regular language mechanisms like loops and exceptions, things that don't quite work in the asynchronous style.
Thank you, Ron. That sounds like a very, very thorough explanation. We have another question in the chat. Can you please shed some light on whether virtual threads use preemptive scheduling or cooperative multi-threading?
That's use preemptive scheduling. They do not use cooperative multi-threading, but it requires a bit of an explanation what that means, and people sometimes misunderstand it. Cooperative multi-threading, cooperative multitasking is the idea that user code, and that's the important thing, user code needs some explicit operation, or rather I should say, in the code itself, there are specific points that are statically known where execution can switch from one task to another. Sometimes that requires an explicit keyword or annotation or some kind of operation. This is what we have in C# with the keyword await. This is what we have in Rust with keyword, not keywords, but with the await operation. In Kotlin, you don't need to use a special keywords, but the compiler statically knows where that could happen. So that is cooperative multitasking. That was the model in Windows, I think 3.0, 3.0. And virtual threads are not like that. Virtual threads can context switch at any point in time. The compiler cannot know at which point they will switch. It is entirely up to the JDK. Having said that, the JDK currently decides to context switch when it does blocking operations. It is allowed to context switch when you call a mathematical operation. I know, math.sign. It doesn't do it currently. Another thing it doesn't do, it doesn't employ time sharing. So time sharing is when if the task is consuming some CPU for some extended duration, let's say 10 milliseconds or 100 milliseconds, then the runtime or the OS will preempt the task and schedule another. We can do it. It's just that we decided not to do it in the default scheduler for the simple reason that it doesn't. We haven't yet seen a real-world case of a server when this would help. And sometimes people think, wait, but the OS does it, so we must be using it. And to give people a sense why that is not the case, I will say that non-real-time OSs, which is the OSs we all use, Windows, Mac, and the vast majority of Linux installations, they only turn on time sharing when the machine is running at 100% CPU. Servers don't usually run at 100% CPU for any extended duration, and when they do, the time sharing that the OS provides doesn't usually make the server run well. So I haven't heard people saying, oh yes, we're running our server constantly at 100% CPU and everyone's happy. So servers don't rely on it. When the OS does it, it doesn't do it well enough to actually work. It's very important for OSs, for non-real-time OSs, so that if something goes wrong, the operator can come in and use the shell, I don't know, stop a program. But of course, virtual threads can still enjoy that. So we will consider adding time sharing if and when we see some real-world use case where it could actually help.
So, Ron, there have been a few questions about how many threads can we have, and what's the limit here. And I think that speaks to a certain understanding of still thinking of virtual threads as threads, as concurrency unit. But I saw you saying in the past that we should think of it much less than that. Just like we usually don't think about how many strings we create. We should think similarly to threads, I think. Can you go to that a little bit to give people a better understanding of how many can I have?
Yes. So, I'm saying, how many should I have? And that is a question I love. So it's I compare it as essentially the question: if I want to store a map of all my usernames and user IDs in memory, how many strings should I have for that? And the answer is as many as there are users. It can't be any less, or you won't be doing the job you need to do, and it can't be any more unless you're making up users. The number of virtual threads is not determined by you. It's not a resource. So when we had platform threads, and we still do, but when platform threads were all we had to think about how many of them we want, because they're sort of a resource that we had to manage. So we said, oh, we need 200 or so. We'll have a thread pool of 200 threads. Virtual threads are like strings, a domain object. A virtual thread is a task. It is not a resource that executes tasks. It is a task. So the number of virtual threads, no matter what you do, will be equal to the number of tasks that your server needs to do. So as Jose said, and that is by far the preferable way of starting virtual threads, unless you're using structured concurrency, and I hope there's going to be a question about structured concurrency. The right way to start virtual threads is to use the new executors, new virtual thread per task executor service. And every task you submit to it will have its own virtual thread. And so the number of virtual threads that you have will be equal to the number of tasks, no more and no less.
Yeah.
So
right. So it's right. I think
you'll have as many as you need until, of course, just as in the case of strings. So if you have 4 billion users, all the strings might not fit in memory. But in that case, the solution is to somehow shard your application and have more servers. And in this situation, it's exactly the same. So a virtual thread is like a string. A virtual thread is a task. It's possible that a single machine cannot handle all the tasks that your service needs, and in that case, you will need to have more machines.
Yeah. So there have been some questions about the underlying mechanism here. Some readers know that it's the fork join pool handling the virtual threads. That's a little bit of a under the hood kind of conversation that just like when you talk about, when you, as I said it earlier in the beginning, when you have virtual memory, you don't really care about how the operating system pulls its tricks. It does it somehow. It's still sometimes interesting just to learn and just to talk about that, though. And I got to remind you, though, we got just a couple more minutes only. So if you want to talk about structure concurrency, this is your chance. Other than that,
I thought we had another half an hour. Okay.
No, then we're going to have Tomas Langer and Sid Joshi here,
okay.
And they're going to talk about how virtual threads work in their systems in NEMA and in Weblogic. So I'm afraid we have to boot you, which is a shame. But that's the look. Come back. We do a 2-hour live stream session on this. But I would be interesting to know. I think the audience as well. What's like the underlying mechanism? Not so much how exactly does it work, but do I have to be concerned with that? Do I have to configure that? Do I have to measure and maybe optimize the underlying fork join pool? What's going on there?
The answer is that there could be situations where you would need to be, just as there could be situations where you need to configure, the OS to allow a large number of file descriptors or sockets. I would say don't start out like that. It is an advanced configuration option that in some situations to get the best performance, you might need to tweak a bit. That's not the first thing I would reach for, but it could happen. There is a way to configure how many worker threads are employed by the scheduler. It's called the parallelism of the scheduler, and you can set it with a command line, but that is a very advanced topic. So I would say it's not for now.
Okay.
Not for beginners.
Yeah. I think that's a good point, though, right? I think we've seen that also with garbage collection recently. We've moved to more kind of like a batteries included configuration style, where like most things work really well out of the box, and you should only start.
To be honest, so we're still one of the things we've discovered is that we still have some ways to go with automatic configuration. So it's possible it's not yet as optimal as it can be. So we will also learn from people's experiences. All the knobs are there. It's just that the ergonomics of picking the right configuration is not necessarily perfect out of the box. So like the GC people, they learnt from years of experience. So we will also improve that automatic configuration over time.
Yeah, I think that's good. I think it's unfortunate for all the consultants out there, but other than that, I think it's good if it works, if it gets you longer without having to fiddle with all these details, because as I said, like it's interesting to know all of them, but it's also going under the hood of the JVM or the runtime is in general quite a complex endeavor for most people, and I think that time is usually better spent developing and providing their users with value, if they don't have to look under that kind of hood. Good.
So if we're out of time, I will say this. I'll ask people to go read JEP 453, Structure Concurrency Preview, which has been delivered in JDK 21. And I would very much encourage people to give it a try.
Yeah, let me put that in chat. That's a good point. Right, because, so there are preview features building on this. And maybe I can give I give you a minute for each. Talk to us about structure concurrency and scope values.
Structure concurrency, I think, is the right way to write concurrent applications. The canonical example is that if you're writing a server handling an incoming request and you want to do fan outs, multiple outgoing port calls in parallel, and you might need to track them or cancel them, give them timeouts, etc. That's the way to do it. That is JEP 453, and we have another JEP, which is, I think, 446, scoped values, which is a nicer, more performance, more correct way of passing information between various levels of the application, similar to thread locals, but better in many respects. Like I said, both correctness and performance. So I would encourage people to give both of those a try.
Yeah. And there's so much more that we didn't get around to. Like, there's a whole big topic of virtual threads work correctly with everything, but there's some things that you can do to make it scale better. So there's lots of details to explore in this space. So there are the JAPs, there are the videos. There's so much more information out there, and I encourage everybody to take a look at that.
And I think Tomas might have some more things to say about that, about his experience.
Yeah, let's do that now. Let's because like so we talked about Ron Pressler because he's been leading the development of this, but of course that's only the one side, right? The other side is people using it, and we have the good fortune to have users basically in the same organization. So we have two people here from Oracle. That would be Tomas Langer and Sid Joshi, who are both working with virtual threads on the consumer side, as many of the programmers maybe would. And Ron, I invite you to hang around. But if you want to enjoy your afternoon.
Thank you. I'll stick around for a bit.
Yeah. So hi, Sid. Hi, Tomas.
Hiya. How are you?
We're fine, thank you. You too?
Yeah, good, thank you.
Yeah. So Tomas, I think we talked about that. Maybe you're gonna give us an insight into how the Helidon project is interacting. Maybe first of all, what it is, in case people don't know it, and then how it interacts with virtual threads.
All right. So I have a very short introduction for Helidon. It is a framework for writing Java services or microservices. It's your choice. And we focus on being just a Java SE application. So if you want to run your service, it will be just Java -jar, or you will use JLink and start your JLink image. And it's like a general purpose microservices framework. I start with that because it's really important for the path to virtual threads. When we looked at the feature for the first time, I was like, okay, microservices are by their nature mostly highly concurrently used. That's your main and foremost use case. You have a lot of concurrent users trying to access a service. And the services themselves do mostly blocking operations. They do HTTP calls to other services. They do database calls using some sockets. They may do messaging writes, but all of them are like the good blocking operations, the operations that virtual threads are designed for. And we thought, in our implementation, we were using reactive programming. And then you have like this limitation. You either go with a blocking programming model, and you are limited by the number of threads that you have in our environment. And now I'm talking about platform threads. And the other option was you just forget about blocking paradigm, ease of programming, and you go to reactive. And we did it, and you can achieve a very good performance using reactive. But unfortunately, you pay quite a high price for that. And the price is, it's a huge, steep learning curve. If you want to do reactive programming right, you really need to spend a lot of time understanding what it is to write a publisher and to correctly do operations on reactive streams. Troubleshooting is a pain, and obviously maintenance as a result is quite costly, because if you have a problem that happens at the beginning of your processing and somehow it manifests at the very end when you do the terminal operation on your stream, it is tough to find out what happened. On the other hand, blocking paradigm, that's what we learned. That's cool, right? That's what you want to do. You want to do your 4 cycles and try-catch blocks. I mean, Ron talked about it quite clearly. But unfortunately, we couldn't do the performance stuff with that because when you hit the number of threads, a certain number for each environment, it just stops working. So when I saw virtual threads, I said, okay, this is what we want. That's, that's like the feature designed for us. So we decided to work on something in Helidon. We called it Project Nima, which was a web server that is designed for virtual threads. And we wanted to make sure that it's fast and does what it needs to do. And we actually proved that it can be done. And right now, we decided that we don't want to have reactive at all. We will actually replace our reactive core in Helidon with a blocking core based on virtual threads and just throw away our reactive web server. And there is a good reason for that, because it's just way easier to use, way easier to maintain on our side and on the user side. So what, like under the hoods, what are we doing with virtual threads? For HTTP 1.1, it's fairly simple. When you have a connection incoming from a user, we start a virtual thread for it. When that connection terminates, the virtual thread ends. Considering HTTP 1.1, you usually have reasonably long-running connections, so it's not such a huge advantage. But where it really shows is with HTTP 2. Because in HTTP 2 there is a connection, and on that connection you have multiple, possibly parallel streams, and each stream is basically a request-response operation. And what we did there is that the HTTP 2 connection is a virtual thread as well, but for each stream that is created on that connection, we also create a virtual thread. And this means that if you run your server with HTTP 2 and you load it, you will really create a huge number of virtual threads. And on my machine, I was able to do around 1 million per second. I have heard that we have like a very big testing environment where we did get to tens of millions per second, and it just works. Like, we didn't get into trouble with memory, latency, anything. It just works. I mean, you need to be aware, as Ron said before, that there are some restrictions on your environment. If you create hundreds of thousands requests per second, and each of them takes a reasonable amount of time, you may overload some other resources. You may even run out of memory if you store a JSON for every single request in memory. And we can limit that. We can say that there is a maximum number of concurrency. Like, you can just say there's a semaphore, you just, you set a number. And one of the great things about this is that when I was implementing this feature to limit the number of concurrent requests, it is a proper try catch finally block where you create you acquire a semaphore and you just release it in the finally block. You don't need to do some strange checks, futures, making sure that you cover all the exceptional cases. It's just try catch finally. So really helpful when it comes to that. And as a result of this HTTP 1 and HTTP 2 approach, all things that are happening within the server, meaning all routes that we execute, are executed in a virtual thread, which gives you the freedom to do your HTTP calls blocking and your database operations blocking without impacting the performance of the server. With a grain of salt, if you overload your data source, you overload your data source. We can do nothing about it. Virtual threads will not help you, but they will definitely help you when you have a few blocking operations that take 10 seconds, and then you have million operations that take 20 milliseconds. You will just see no impact. And in the old world, if you did this, you would just block your server. For us, for the low-level programming model, this is a big change. We are going from reactive to blocking. Obviously, that's quite a big impact. We also have a part of Helidon that allows you to program using microprofile specification, which is based on CDI. And in old Helidon, in version 3, this was built on top of our reactive web server. And obviously, we were limited again by the platform threads because it's a blocking paradigm. If you have a request on JUGs, you need to just do it blocking. And just by replacing the underlying web server with a virtual thread based, we could get like 10 times more load out of that server. Not for it being faster, but for it being capable of loading multiple concurrent requests. And I prepared a few lessons learned from this. One of them, some of them are good ones. There are some, things that are not so good. So the best one is that you have to unlearn asynchronous programming.
Thomas, do you have any slides or anything to share with us?
I have slides. I can share them if you want me to share right now, or I can share them later on if it's whatever.
Okay. Okay, just asking if you want to share with the people, like them to see any of the things that you're describing.
I mean, I thought that it's better if I just talk and we can share the slides for back reference. I'm skipping over stuff, so no problem.
Okay. Okay.
Okay, so as I said, unlearning asynchronous programming, that's it's tough. I was surprised how tough it is to, for example, to switch to blocking sockets. Because initially I just used, non-blocking channels for the HTTP communication, and you realize that it's complicated, and you are using, again, futures and trying to care about threads, and then you find out that you don't need to do it because with virtual threads it just works. So this was a very big impact on everything we do. As a result, everything is easier to write. One thing that we have to learn about a bit more when you use virtual threads is thread locals. In general, they work fine as long as you need to create a security context that is valid for your request. You create a thread local, it just works. It's okay. The problem comes when you use thread locals to cache some expensive resources for the duration of the threads, and you are expecting the thread to be reused. And obviously, this kind of thread locals don't work well with virtual threads. We learned that the hard way. Netty is using that for storing byte buffers. That's one of the reasons we actually replaced it with our own server to write it for virtual threads. One of the lessons learned for me, I have it with bold letters here. Imagine bold letters. Virtual threads is the best improvement in Java ever. And I'm using it since Java version 1.1. So honestly, this is the best thing that ever happened. Now for the, some hiccups that we have encountered. First, as I said, switching to blocking channels, blocking sockets is much easier to write. There was one thing that was slightly more complicated for us, which is, for example, reloading your keys and certificates for the server. Because you need to play a bit with the underlying structure of the SSL context. It was solvable, so that's great. There was, we had a few problems with performance, and we found out that the performance of the socket layer, when combined with virtual threads, is quite, aware of what's happening on the operating system. So sometimes, asynchronous writes, meaning that we write to sockets in another virtual thread, were faster. Sometimes they were slower. TCP no delay, the enable algorithm, sometimes it was faster, sometimes it was slower. And it was okay when it was once on Mac OS and the other one on Linux, you can, plan for it. Unfortunately, it happened to us twice that there was a new release of kernel in Linux, and suddenly we had to refactor our configuration to achieve the same performance as before. So I think that this is one area that probably requires some hardening in the future. What we did in the end, we just allow all the configuration options that are possible on sockets. We allow them through configuration. So if there is a change, usually you can find out the right solution for that and fix it.
So since you talked about performance, Thomas, I have a question. So Stefan Bulzan asked that in chat. Do you have some benchmarks comparing imperative Helidon with virtual threads versus only platform threads? Or also did you make any benchmarks, I guess, regarding a virtual thread-based Helidon with one that uses a reactive?
Yes, there is Tech Empower Benchmarks. That's a server that you can access online. And we do have currently a version of Helidon running on 3 with reactive, and we have a new version running on 4 using virtual threads. We cannot really compare virtual threads against platform threads when using the new approach because it doesn't work with platform threads. It requires virtual. We are doing thread per task executor. If you replace that with platform, you will probably kill the server. So the new approach is just not backward compatible with platform threads. And you cannot really run reactive on virtual threads because it doesn't make sense. So, we can compare across versions, and we do compare that. We also have our own benchmarks. Again, as I said before, we do achieve quite a lot of improvements depending on what kind of benchmark you use. So if you use database, then the improvement is not so big because you are, blocked by the database performance. When we talk about HTTP 1.1 with pipelining, we have like 10 times bigger performance than we used to have before. again, it's a case by case and also benchmark by benchmark. Obviously, it depends what you do.
Yeah, clearly. Okay, thank you, Thomas. Yeah, let's. I think it's really great to hear that what Jose and Ron both described in theory, to see that work out in practice, to see that it's not just that somebody just made up in some admittedly very nice but otherwise just an office work from home office, but that actually works. That if put in practice, you will see that these benefits are real, and if if a web server can be built on that, then clearly it must fulfill the performance criteria and also must be sufficiently simpler to make it worth to throw away a lot of code that you apparently already wrote and they were confident that you can replace with much simpler and at least as performant code. So Sid, I think you had like at least similar or parallel maybe observations to those.
Yeah, I would like to share some of the things. So when we were looking at Helidon team achieving such great performance when they moved from reactive code to adoption of virtual threads with Project Loom, we thought, hey, that's amazing performance benefits that they're achieving. What could we get if we move Weblogic to adopt virtual threads for the underlying thread pool management side of things? And how could that benefit for the customers who are leveraging Weblogic as a Jakarta Java EE application server to benefit for their application stack? So firstly, when you're moving from building your own Java applications or microservices to when you're adopting leveraging Java EE or Jakarta EE application servers, the difference is that application servers are managing threads for the applications that are deployed on top of it. So the complexity of thread management from the applications for the developer side is taken away. So it's made it much easier because the application server associates the security and the transaction context for the thread that's being used for the application. So making it much more easier for developers to use the benefits that they would get with virtual threads. And also, traditional platform threads, if you have a huge amount of concurrent resources or concurrent requests going on an application, and you are, having a couple of seconds block for that particular request, maybe you're talking to a backend databases or having different RMI calls or a long-running action, it might be quite, you might look at a lot more performance platform threads, and which might hinder your performance and create concurrency bottlenecks. But this, by adoption of virtual threads, by making it easier for you to hold that particular transaction in memory or that particular action in memory and scale dynamically, you can have much higher concurrent applications running on top of the same hardware, maybe even reducing the amount of memory and disk space, as well as the CPU cycle that your applications might need, giving you a higher parallel throughput. And this will not only help the customers who are running their existing custom applications and leveraging the underlying threading model and thread performance model of a Java EE or Jakarta EE application server, but also helps with any ISV-based application, any custom application, or OpenStack solution that are built on top of Weblogic. So with this in mind, we work very closely with the Java 21 development team and trying to adopt and give a very much like enterprise push on top of the Java 21 to ensure that, hey, when we are running our application server, when we are doing our testing, how could we make the most out of this application server? How could we get most out of this virtual thread? And what kind of performance improvement and performance gain not only we observe for ourselves, but we can help the Java EE or Jakarta EE application users get it just by adoption of virtual threads with underlying platform like Weblogic. And we did some micro benchmarking for this. So the couple of macro and very fine-grained benchmarking gave us very potentially exciting results. One was we created a benchmark where we had a servlet-based application that receives a request and is doing a block. Maybe you're going to a backend database, or you're doing some action over JMS or some kind of RMI call, and it's taking up to 1 second before the response is returned to the requester. And over here, when we ran WebLogic 14.1.2 without any platform threads and with a platform thread, we saw a performance gain of around close to 380%, which is quite significant if we think about in a larger cycle used for a high concurrent, high throughput enterprise workload. Then the second test we tried to do was similar servlet-based application that is requesting about 2 second block because of the backend services that they're interacting with the RMI or database or some kind of JMS or multitude of the services. We saw performance gain of around 483%, which was quite significant, given the just by changing an adoption of virtual threads, customers could get a huge amount more performance boost. But last but not least, the third one was stateless EJBs based application that is receiving a request and again having a 2 seconds of wait time before the actual response going back to the requester. We saw a performance gain of around 1200%, which is way, way higher and significant in my view. So if you're just running Java EE applications and you're using a standard threading model as part of the application server, without having to do any code change, your application could get significant performance boost with the concurrency. If you are, lacked by the concurrency side, or if you're doing high throughput workload, then you could get some significant performance gains. And we are very excited to see how the upper application stack, but also upper Oracle solution stack like Fusion Middleware and Oracle Packaged Application would gain performance with this, virtual thread adoption under WebLogic. And we have been working very closely with Java team to not only productionize the virtual thread mechanism by highlighting some of the bugs and some enhancements, requests, and so on to ensure that our end users and our customers are going to get the most of the benefits and really using it in real life, basically.
Cool.
And
go on.
Sorry.
I was going to say thank you.
I was going to ask something from the chat.
Sure.
So there was a question in the chat that we interpreted it also with Tomas' help about the support for virtual threads in WebLogic server. Do you have anything to tell us about this?
So the next release of WebLogic, which is going to be 14.1.2, that's going to be released in calendar year 2024, will have Java 21 support in it. We will be certifying WebLogic 14.1.2 with Java 17 as well as 21. And we are looking to adopt virtual threads as a part of the core solution. So we're going to make it hopefully easier for enterprises to gain most out of the performance with this incredible technology of virtual threads.
And one last question, if there's time. If there's time, Nikolai?
Yeah, no, we have a little bit. We have a few more minutes, I think. So we're gonna after this, we're gonna switch over to the panel at CloudWorld, and we might need a minute setup time or something. But other than that, we have like 5 more minutes to go. Sure.
So the another question is will the transaction context be linked to virtual threads? If yes, will there be any impact on JDBC database to handle a high number of virtual threads?
So this is again. It's in early days. We are doing intensive testing and validation and ensuring that it's done in a proper way. I do believe that the transactional context will be retained with the thread and look at this space. When we know more, we will share it with you. But we just wanted to share with you the existing testing that we have done and the performance gains we are seeing. It's very exciting for us.
Like for us, we actually support JPA as well in our microprofile version, and obviously it works. You get your transaction context. You just need to correctly, make your database sizing. So eventually, you do have a maximal connection pool size. When you reach that maximal connection pool size, then other threads that are waiting for database will be just waiting in the queue, or depending on your configuration of the data source. So yeah, it is a scarce resource that needs to be managed. And even though for example, the Oracle data source supports virtual threads and doesn't fail with them, it still is a limiting resource that will be definitely scarce.
Yeah.
Thank you.
Yeah, thank you all very much. As we said, we have to go to the CloudWorld panel, but I think we have maybe one quick question that we came up in the past. What about reactive programming? What happens to reactive programming now? Is there anybody who wants to take that question?
My favorite answer to that, like for me, reactive programming doesn't have a purpose except for some stream handling. Like if you have some stream handling across network which requires back pressure, then that's probably your use case. But for me, it has moved from the main use cases to a totally niche use case. I think it's that for us. Like we decided that way in Helidon, and we kind of think that's the right choice. So bye reactive programming.
Okay, so somebody in chat did point out that reactive programming is more than just the performance part, and that stuff like back pressure and various patterns still play a role. And it would be interesting to see how those patterns would work with virtual threads. The need is still there, but some of them just become normal code, right? Normal language use of the language.
Like back pressure, for example, is a very good case where people always say, like, what about back pressure? The thing is that with blocking programming, you get natural back pressure. If you cannot process it, your virtual thread doesn't move forward and doesn't read the next bytes from your request. So you block your socket, and that blocks the client, and the client is blocking on what it can do. So there is back pressure. It's just not done through request next chunks and pushing next events. It's just done over blocking input and output streams, and it still works. You don't push everything into memory. Like it would be a bad design if we just took everything that we get over the network and pushed it into memory and just failed, right? So yeah, it's still there. It's just done differently.
Okay. Yeah, I'm going to leave Ron. Any closing words, since you're the mastermind behind all this?
No. Well, then please use structure, concurrency, and scope values, and let us know how you do.
Okay. Cool. Yeah, thank you all very much, Sid and Tomas and Ron, for being here, for sharing your immense knowledge and experience. And I think we're ready to switch over to the panel. Bye, folks.
Bye-bye. Thank you.
Thank you. Bye.
And now, the big moment.
Okay, so let's see how that works. Do we have sound from the panel? I think we do. I hear some white noise and some roomy noise. Also, everybody read that slide, please. It's a very important slide.
Maybe we should...
Yeah, we're joining, I think we were up to 1,500 people at one point.
There we are. Okay. Should I read it out?
Okay, well,
outline or
it's 2 minutes early. I think we're part of the live stream room. I can see it now. Thank you all for your patience as we go through some of these technical issues here. We are streaming to about 1,000 people on the YouTube Java channel. And so the camera basically is framing the speakers here. This has to be on the screen. Everybody who's streaming on the live stream, hello? Can I get a little celebration from everybody in the room? Yeah! All right, 8:30 here, everybody. All right, I think we can probably take this off now. That way the panelists, oh no, you're good, yeah. Can you unplug it?
Whoa, look at that.
Perfect, okay. That'll be better. All right, so the stream has started, and I'll hand it over to you, Shar.
Oh, appreciate that. So first off, good morning and welcome to day one of CloudWorld. I'll move that down a little bit. There you go. We're pretty excited to be here. Let me just do a quick round of introductions. First off, this session is Java first, Java always. So if you're here for a Java session, you're in the right room. If you're here for the casinos, they're downstairs. But we're glad you joined us this morning. My name is Sharat Chander, a longtime member of the Java team, and we're very lucky to have 3 distinguished guests with us today for this morning panel. Georges Saab, Senior Vice President, Java Platform Development, Chair, OpenJDK Governing Board. Chad Aramura, Vice President, Java Developer Relations. Welcome, Chad. And Donald Smith, Vice President, Java Product Management. Now, we have some important announcements to get to today, but before we do that, just wanted to take a pause and just see from the sea of attendees in this room, and if you're online, feel free to raise your hand too. How many people are active Java developers? Just want to get an understanding. So I always like to follow up that question with, how many of you have been programming in Java for at least 5 years? Raise your hand. Oh, that's pretty healthy. Next question. How many of you have been active Java developers for at least 10 years? Oh my goodness. All right, this is where it gets interesting. How many of you have been active Java developers for 15 years? Oh, still stable, right? Just like Java, it's pretty stable, right? Okay.
Most of the room raised their hands for 15 years.
And this is going to be an interesting one. How many have been active Java developers for 20 or more years? All right. Wait, they should be doing this panel, not us. Well, what we're trying to do today is, first off, celebrating 28 amazing years of Java. And it's kind of humbling to know that this technology, this language, this platform has been around for that duration. And that's a testament to the fact that almost every enterprise on every corner of the earth is perhaps using Java internally somewhere, in the tens of thousands of customers and businesses. And it's because we continue to have a rich and thriving pipeline of innovation, dating all the way back, and I know some of you have probably been there at the beginning. I'm not saying who. But it's a matter of ensuring that the platform and the language continues to deliver innovation for the next 28 years. And today is a pretty special day, because today, Java 21 is available. So,
So, Shar, a quick panel question. How many people in the room have Java 21 in production? Oh, interesting. Interesting. All right.
or I guess the follow-up is, how many people will have Java 21 in production soon?
Everybody in this room and their children.
That's right.
Everybody raised their hands.
And so we don't get to 28 years of innovation, and we can't prepare for the next 28 without fundamentally understanding the landscape. And this is part of the conversation we're going to have today. And George, I know you lead the Java team, you lead the product team, you lead perhaps all of Java. And so it's fundamentally a balancing act in terms of how quickly do we innovate versus how stable we are with conservatism. How do we balance the two so they're not in conflict, so enterprises and developers can take advantage of Java?
Thanks, Shar. You know, it's kind of interesting because there definitely can be a tension between trying to bring new innovation to developers more quickly, but still, you know, giving enterprises that want to rely upon Java for mission critical types of workloads what they need. And I think this is something that we found has worked really well as we move to this faster release cadence. How long ago was it? 6 years?
Almost
5.5 years
Almost
ago?
6.
Yeah, that's right. 12 releases ago, we can say now, today. And, you know, the feature releases that come every 6 months are really about innovation and getting that innovation in the hands of developers more quickly. And the long-term support that we offer, where, you know, every couple of years we designate one of those feature releases as the release for which Oracle intends to offer long-term support. Those are about stability. And what we found is that, you know, we thought it was going to be a lot harder to sort of balance these things, but with those two avenues of getting things out in the hands of people who use Java, it's actually been simpler than we thought, because we don't sort of have to make the choice. We're not sort of foisting new features on people who just want something that's going to be rock solid and stable. And because of the many, many years that we offer that long-term support for, it gives people sort of a choice of when they want to migrate forward, and they can kind of do it at their own pace. So I think that, you know, our feeling is we were apprehensive beforehand, but now after having done it for a number of years, it feels really good.
It sort of puts a target on our back, but it's one that we welcome, which is a good thing.
But, you know, speaking of targets on backs.
Oh, did we just announce Java 21? Should we do the reveal? We should.
You want to explain this?
So, I'd like to explain this. So, Java 11 wasn't that long ago, and so we had some interesting T-shirts made for Java 11. But in agile fashion, we decided to upgrade the T-shirt. We upgraded the T-shirt to Java 21.
Better in our head.
Yeah. We shouldn't quit our day job, should we? All right. So, Java continues to be the #1 programming language used by enterprises around the world. And it's, fundamentally, we've stayed true to some principles that's kept us on a stable and focused track: transparency, predictability, and innovation. Can you touch upon how those three elements are going to move Java to the next 28 years and beyond?
Yeah, I think that having a balance of those is important. I think predictability is super important for anyone who is running Java for real in production, because you want to know what to expect and when things are coming. And here again, the 6-month cadence has really helped a lot with that. The approach that we used to take was feature based rather than time based. What do they say? You can have it's basically features. A particular time or high quality, choose two, right? And of course, high quality we have to have. That's never in doubt. The approach we used to take was thinking through features, and it often meant that the times were less predictable. But with this approach that we have now, it is based on time. We haven't missed a single one of the feature release dates that we predicted. And what that means is if you're an enterprise, you know how to plan, when things are coming, when change is going to be in your hands. The sort of openness there and transparency, I think this is super important as well, because developers want to know what is coming and be able to plan for it. And I think if you look at the Java ecosystem and the way that Oracle kind of stewards this work through our work in the OpenJDK community, we basically make it possible for you to look at and understand every single feature we're working on long before they actually see the light of day. So you can witness the design discussions, you can witness every single putback as it's happening, you can see the code reviews that people are doing. And the nice thing about this is you really sort of understand, what was this feature meant to do? What was it not meant to do? What are the problems it's trying to solve, or ones it has decided not to try to solve, and why? And I think that's really important. So yeah.
If I could just add one thing, the 6-month release cadence has been amazing for the innovation pipeline and everything going in, but it's also like my team and our team is responsible for going out and talking about this stuff and promoting it and doing live streams like we're doing right now. Every 6 months, it gives us a reason to go out and talk about all of the great things that are coming, talk about the roadmap, talk about the new JEPs, talk about preview JEPs coming in Project Amber. It's really, really an exciting time to be a Java developer. So thank you for continuing to be on this journey after some of you for 15, 20 years.
A lot of times we'll get the question, what's the secret sauce? And the reality is there is no secret sauce because of that level of transparency. How many of you are familiar with the OpenJDK project? Just a quick show of hands. See, we fundamentally have something we need to improve on, which is we know you have day jobs. Oh, there you go. I'm a bit too loud this morning, apparently. That's a first. You sound too soft. The gain is hot. So if you have not visited the OpenJDK project, this is your chance, as George said, to actually see the live discussions and code check-ins and understand fundamentally the decisions that we are making or decisions we've passed over. And that should help you as developers make better choices as you move and migrate from release to release. So we really would encourage you to come to OpenJDK, take a look, pick the projects that most interest you, and follow along. Part of Java isn't just what we do, what we engineer, and what we deliver. It's the feedback that you give us. And that's the feedback that helps us engineer Java for that next 28 years and beyond. So one of the things that you also mentioned was predictability. Chad, you touched upon it. George, you touched upon it. there used to be a time where we went with big bang releases. Can we just talk a little bit about how latency and throughput are being addressed through the 6-month release cadence?
Yeah, great question. So like everybody in this is a great setup with your survey, because everybody in this room has been doing this for, it seems like, at least 15 years. But do y'all remember back when Java 5 came out and then Java 6 came out? And at your companies, I'm betting it was an all hands on deck for about a year to migrate from Java 4 to Java 5, and then from Java 5 to Java 6. It took a year for the tool chains to catch up. It took a year and a half for any third-party libraries and dependencies you had to catch up. And so anytime there was a major release, which was every 3-ish or 4-ish years, it was just everybody in software development in the company had to drop everything, and that's pretty much all you did was move up to the next major version of Java. The 6-month release cadence, it's 5 years old. When it first came out, everybody was looking at that 6-month cadence from the context of, oh great, every 6 months we're going to have an all hands on deck effort for how is that going to work? An all hands on deck for a year and a half every 6 months? Like, what? This isn't going to work. But we believed strongly that if we were able to, to put predictability in there and keep the quality high and just show everyone, no, this is the better way. This is modern app dev. This is making Java ready for cloud development especially, but basically modern app dev, making that transition. If we can prove it, then in all of these organizations that have an all hands on deck, every developer you have working for a year or so on a major migration, instead what you can do is have a smaller group that is doing continuous integration, continuous deployment. And we obviously didn't invent that concept, but we sure as heck saw it taking over the software industry and said, we need to align Java to that. And sure enough, a year or two after we proved ourselves, the ecosystem saw that, and a lot of enterprises adapted. And so we now see a lot of organizations getting the latest releases and even more frequent releases into the CI/CD testing pipeline early. We're able to catch issues earlier. We have preview features. We have incubation modules, which helps us get things into hands even earlier with an API that we don't have to worry about changing or adapting. But what really made this work was in the very early days, a lot of the tool vendors, so the major IDEs of the day, so Eclipse, IntelliJ, NetBeans, all made sure that when we released Java 10 and 11 and 12, they were there on day 0 with support. And we now just take that for granted. Like we don't even think about it. Like we used to really worry, like, okay, are all the tool vendors going to be able to keep up in those early few months? And sure enough, there was a bit of pushback and a bit of screaming. The Spring team in particular was a little annoyed about those first couple of 6-month releases, but they got there, right? And so now the whole ecosystem is benefiting from that, and we are set for the next decade. So if we could just stop changing how application development happens for the next 10 years or so, then we're set. We don't have to do any more work out of product management, and I can just come to Vegas. All right, sorry, I may be off script.
Are you saying you want to go faster? No. Okay.
No. It's like 5-minute abs versus 6-minute abs. At some point, you just have enough minutes.
I hear you. Well, you talked about a couple of things. You said cloud. You said modern app dev. That touches upon how we create projects and advance projects in OpenJDK. And we see some of those elements bearing fruit in Java 21, touching on things like AI and ML. What are some of those projects, and specifically in 21, what are some features that developers should really know about? You want to take a chat?
Well, if I'm going to start, I'm sure somebody will mention virtual threads in Project Loom. I think there was that's now standard feature. So we're really excited about that. And I'll let somebody talk about that. But I'm really excited about the language features that have been going in over each release. Generally, those fall under Project Amber. Things like pattern matching and record destructuring, record patterns, text blocks, local variable type inference. It makes the language so much more precise and expressive, and just the things that are in your head when you're thinking about solving or modeling a problem, it's much easier to express that in code now with all of the innovation going in. And they're not just pulled out of thin air, or we take votes on what feature is the most interesting one and we do those. We actually think about those, or the language team thinks very hard about how they work together. And the 6-month release cadence, again, not to drive this one too strongly, has been amazing, because before this, it would have been like, okay, how are we going to release pattern matching across the entire Java language? And then it's like, we work on it for 3 years and okay, here it is. But now we gradually started with something like pattern matching for instance of. And we got that out into a release. In fact, we got it out as an early as a preview feature for a couple of releases, and then it went standard. And then we saw how that worked. We made some changes, and then we did pattern matching for switch. Couple releases, saw how that worked, got some feedback, make some changes, and then pattern matching or record patterns. And all of these things work very nicely together just to make the language so much more beautiful to write and to read and to hand off to the next generation that it has to maintain your application. So that's what I'm really excited about.
What about you, George?
Can I say virtual threads?
You can.
I was trying to give it to you. Yeah.
Oh, okay, thanks.
Was that a layup?
It was. Yeah, I mean, I think virtual threads are super exciting. I'm just so pleased and amazed at what a great job the folks working on that in my team and kind of across the industry have been able to do, because basically what they've done is, this is sort of the programming equivalent of, jacking up the house, replacing the foundation and putting the house back down. And you look at it and it's like, wow, what's happened here? It's all just like it was, except it's much, 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 much better. And in the case of virtual threads, much, much, much more scalable. I do expect that it's the kind of feature that not every developer is going to directly come in contact with, but they're going to indirectly feel the benefits of it. Not everyone is necessarily writing low-level threading code, but maybe they're using a framework that's actually doing some of the heavy lifting for them. And what we've seen from a lot of the people that tried virtual threads in its preview form and gave us feedback was they found that they didn't have to make a bunch of changes. In fact, often the changes that they made were taking out things that were complex that they were maintaining in order to sort of work around some of the limitations of the one Java thread, one platform thread model. And so I think that's pretty neat. What it sort of promises to people is the ability to write simple, synchronous, understandable, debuggable code, but have it scale much, much, much better than what they were used to. And of course, Java has always had a good story for scalability. This really just takes it to the next level. So I'm very excited about that.
Yeah, I'm going to pile on there a little bit, but I'd like to take advantage of having an audience and do a quick survey if I can. So does anybody remember Java before generics? Right? Generics only came in Java 5, right? Or can you imagine trying to write Java code today without lambdas that came in Java 8, right? So, okay, so here's the question. So imagine it's 5 years from now or 10 years from now, and you have a survey and you have to say, which of these was the most impactful to the Java platform? And your options are generics, lambdas, or Loom, all right? So how many people would pick generics as the most impactful? Wow. Okay, sorry, people who have 2 PhDs and made generics amazing, but nobody put their hand up. All right. It is stiff competition. All right, what about lambdas? Yeah, okay, there we go. I'd say about a third. And what about Loom? All right. Okay. And what about it's 8:30 on a Tuesday morning, and I'm not gonna vote in a survey. So I think for people like me, the beauty of Loom is you don't really have to think about it. It's just going to be there. But I know, especially library maintainers are just going to have a field day optimizing the heck out of their libraries for Loom, and I think, in just a few months, we're going to see some incredible stuff coming out of that, which we have already. But all right, so
yeah,
my vote's Loom.
And so part of it isn't just the 15 new features in Java 21. I think sometimes we just take for granted the performance stability and other improvements that are just inherent by migrating to a more recent version of the JDK to get that performance boost. And so we should never just look at what is that list of net new features. It's just the innovation that we continue to get from release to release, which is important.
Sure. Yeah. So as Shar was saying, when he mentions the 15 features, that's the number of JEPs, so JDK enhancement proposals. Here again, back to transparency. If you're unsure what a JEP is, go to the openjdk.org site and look at the page for 22, and you'll see the list of JEPs. So JEP is a very, very detailed description of a feature that we feel is large enough to call out and give a bunch of information on. So here they're really just amazing documentation of these features, not only talking about how they work and showing examples, but also again talking about what was not a part of the problem trying to be solved.
What's the goal?
What might be things sometimes coming in the future as follow-on work, because this approach has really, as Chad was saying, been about breaking up larger problems that we're trying to solve into smaller increments of delivery, so that the 6-month releases are approachable and can be picked up more quickly.
Or the associated features that are complementary to that JEP. So that's very important.
Yeah. And then finally, again, as Shar was saying, literally thousands of bug fixes and smaller features that just don't rise to the level of a JEP are going into these. So there's really it's not just 15 things. It's a lot of good work.
So beyond the innovation that happens in projects in OpenJDK, we know there are enterprises running Java in production, and there's a variety of use cases over tens of thousands of companies. Beyond delivering Java as a value-add language and platform, there are enterprise features that we're also working on that companies and developers can take advantage of. Donald, you want to talk a bit about some of those?
Yeah. So as a vendor of JDK, the Oracle JDK, we have a subscription product. And the subscription has enterprise features and value add that come along with that. One of those is one of the things we provide is access to support security stability updates for all the very old versions of Java that organizations may have in production and just not want to swap out and not want to jump into Loom too quickly for whatever reason. And so, yeah, we still have customers using very old versions of Java, so that's one of the benefits our support organization. But in terms of like commercial features, things that are more enterprise management, monitoring type things, we have the Java Management Service, JMS, which is it's a cloud service where you have an agent that can track and monitor and manage the lifecycle of your Java distributions. So it can help you with lifecycle management, track what's running what, where. And it can do that across cloud, third-party cloud. It can do it on OCI, on-premise, on desktop. So real helpful tool for IT administrators. And then we have some other things like a enterprise performance pack. So this specifically, if you look at the performance benefits between Java 8 and Java 17, there was a lot of incremental performance benefits put in along the way. And so basically we provided, we brought back those performance benefits into a Java 8 runtime. And you can download all this and try it out easily on our download site, oracle.com/Java download. Look for the Enterprise Performance Pack. It's a drop-in replacement for Java 8 workloads, brings all that Java 17 performance. And then we have GraalVM. I'm used to saying GraalVM Enterprise, but it's now being rebranded as just GraalVM, which has a JIT, which is especially good for microservice-based workloads. So if you're doing microservice-based workloads, and again, you can just easily download that and try it out. So you can try the different performance packs. I feel like I'm missing some things, but
there's one pretty important one that was just recently added.
There's one more.
Yeah.
So.
What about third-party support for tools and frameworks?
That that thing.
Yeah.
Triage support. So I should have mentioned this at the very beginning, which is, we have thousands of customers, and a lot of our customers will, when they engage with the support organization, will have a random third-party library with a random issue, and they'll say, we have this issue with this library. We can't find the vendor, or it's a bit old, or whatever. Is there any chance you can help us with that? Like, is there anything, like, do you guys have a solution to, or a workaround, or an idea? And it turns out we often do. Right. And we often do because we have thousands of customers that the support org is engaging with. But we also have a very large number of Java developers at Oracle writing our cloud services and other applications. So we often find these things ourselves. Right. And as part of that support offering, we're able to help customers with their third-party library usage. That's something that we only started back in January, but the interest in that has been really strong, and so we're looking at what we can do to bulk that up and out.
And so the Java SE universal subscription, beyond just commercial features that can help drive your business forward, beyond those tools and solutions, we are also offering technical education. So recently we've taken our Java Day series. We've started working with individual companies to bring our technical expertise into your company. So if you are interested in getting that understanding of what are the new features in Java, or I just want to explore some of the more unknown dimensions of our language and platform, talk to your company, talk to us. We want to come in and help accelerate your adoption of Java. That is an additional value add we're happy to explore. So this is how we partner together, because as we said in the beginning, this isn't just about us. This is a circular relationship we have with you. And so we want to maintain that connection with you, which, by the way, we forgot to mention one thing. One of the best ways to accelerate to the next version of Java are our early access builds. Java 22 is just around the corner. You can already get builds now. Start putting them into your testing environment and understand that's going to do when March comes around. So take advantage of that. So we've talked about technology innovation. We've talked about enterprise innovation. Near and dear to my heart is a third pillar that's made Java successful, which is the Java ecosystem. It is, to me, perhaps the heartbeat of what's kept Java going. I know many of you might be familiar with the baseball analogy, build it and they will come, from Hollywood. I don't subscribe into that. Building something does not attract an audience. You have to build out a user base and an ecosystem, especially for a language like Java. And so, Chad, you lead the Java developer relations team. What are some of the foundational programs that's kept Java so vibrant?
Well, let's see. Are there any Java champions in the room? Yes.
One.
Yes.
Two. Congratulations.
Congratulations. Thank you, Java Champions. So Java Champions is a program that we've continued to invest in. It's a really important program that highlights luminaries from the industry who are experts in Java, who are great at promoting Java and continue to promote Java. It's a lifetime achievement. They're voted in by their peers, and it's an esteemed group where we really appreciate all of your service. And you'll probably be raising your hands again pretty soon, but we'll get back to that. Any JUG leaders or JUG members, Java user groups in here?
Who belongs to a Java user group?
To a Java user group. There's probably lots on the stream. Thank you. Yeah, so Java user group program. I think there are almost 400 Java user groups around the world, locally organized, oftentimes local languages, where people just get together and talk about their passion, which is usually Java. It's called a Java user group after all. So it's another program that has been really foundational to everything that we've been able to accomplish with Java for the past 28 years. Any certified Java developers? Certified Java developers, there we go. So we just hit our 1 millionth certified Java developer, a developer in Japan. That was maybe, 6 months ago or so. So definitely there's many developers out there, in fact, 1 million developers out there who are certified to be developing in Java and also promoting Java as well.
That's a good collection, but we know with some estimates are there's 10 million plus Java developers on the planet. I believe that number is somewhere of a magnitude higher than that, but that's still a lot of developers. And so we know all of you have your own way of wanting to be reached. And the collection of modalities that we have to keep track of is sometimes uncanny in terms of just how many connection points there are to you. And so we need to also evolve our program in terms of outreach. And so, Chad, your team has introduced several new digital channels for that learn, share, collaborate mechanism. Can you talk about some of those new programs?
Yeah, so we've launched a couple of new websites. One of them is called inside.java. .java is the TLD. In fact, am I wearing the shirt? Yeah. Dev.java is the other website. So Inside Java is a website that aggregates content that's built and developed by the team that works on Java. So if they're talking at a conference or giving a podcast or writing a blog post, they could put that blog post anywhere, writing an article. We aggregate those all at Inside Java, make it really easy to discover. There's an RSS feed. You can look for everything from Brian Goetz, or you can look for everything from Project Loom that we've talked about today. It's a really great way to find content. Dev.java is the place to go if you're a Java developer to get, there's hundreds of tutorials and also a couple of announcements that we'll make in a little bit. And it's a website where we launched a little over a year and a half ago to basically be the place to go to get anything Java. So you can download Java, you can get information on our community programs, and a bunch of other stuff. And then the last one I'll mention is our YouTube page. So we're streaming right now, maybe 800 to 1,000 people on the stream. That's happening through our YouTube channel, youtube.com/Java. And there's a ton of great content that's been created. Jose, one of the stars, is up here in the front row. He draws lots of attention to the channel. And it's really, so what we're really trying to do is engage both experienced developers, sounds like there's a lot in this room, as well as new developers as well. And that's a transition that we're starting to make with some of our content, because it's really important that we reach that next generation of Java developers. 28 years, a lot of really experienced developers in here. We want to make sure that we're going for the next 30 years as well. So we're working really hard to make sure that we're creating the right channels to reach the next generation of developers.
So you're talking about a bit of a reveal. I think that goes hand in hand with one of the JEPs in Java 21. You want to talk about what we're doing for students in Java 21?
Sure, I'll just keep the mic, thanks. There is a JEP called Unnamed Classes and Instance Main Methods. I forget what the JEP number is. Anybody know? Anybody know? Anybody know? No, okay, who cares? And basically, part of what we're doing is trying to move the language to a way, it's called part of paving the on-ramp, moving the language to a place where new developers can get to Hello World much quicker without learning a lot of the overhead and complexity of having to do a bunch of the boilerplate in there. Because as Brian likes to say, you have to push a bunch of concepts onto the stack before you understand what it even mean until you get to system.out.println Hello World. And then you have to start to unwind that stack to figure out what just happened. Now you can actually get rid of the class Hello World because you can automatically have the unnamed class, a lot like we have unnamed packages and unnamed modules. And then you can also do instance main methods, starting to get rid of the public static and also the input array into main. So you're literally down to void main, curly brace, system.out.println. And it's a way where developers can get really easily to Hello World without having to learn new concepts and without having to unlearn concepts later. That's a big part of the on-ramp. So we could go further, and we are thinking about going further, but we got to be very careful that we're not introducing things that make it so that developers then have to unlearn things to get to actual, larger development processes.
Well, that goes hand in hand with one of your new programs, but I think George has a bit.
Yeah, I was just going to say something quickly. So Chad referred to paving the on-ramp, but what he didn't say is you can go to inside.java and you can look for paving the on-ramp, and you will see a white paper talking about the vision for this, of which these two JEPs are just kind of a down payment.
So what's the new program getting announced today that goes hand in hand with that?
All right, so we have two announcements. I think, is it two now? First, we announced the Java Playground. So if you go to dev.java/playground, or if you just go to dev.java, you'll see the new word at the top that says playground. It's a place to run snippets of code inside a browser without having to download the JDK, without having to do pretty much anything, get an IDE. It's a lightweight IDE where you can just run some of the new features that we're talking about today. There's a little drop down that you can choose features. And we really want to make it so that developers of all skill levels can just jump in there and try stuff out really quickly. It's built off the JShell API, so it's got a familiar JShell sort of experience. If you click detailed output, you'll get all the output that would have gone to the JShell console, which is a bunch of really cool stuff. If you haven't used JShell, definitely try that out and try out the playground. And the second announcement is we are now accepting community contributions to dev.java. So we're extremely excited about that. Until now, all of the content's been developed at folks from Oracle, but I think there are some featured authors in this room. Can I see a show of hands who have contributed content to
stand
Java?
up? Can we have them stand up?
Okay.
No? They're going to stand up, yes?
No, it's in. Yeah, no, your content's in. Yeah, go take a look at it. Thank you. So Gail and Paul Anderson. Yeah. Thank you. And I think maybe Venkat Subramaniam, Gene Boyarsky, and Kai Horstman are probably on the stream. I think I saw Heinz this morning.
Heinz Kibbutz,
yeah. Thank you very much. Also contributors. So if you go to dev.java and you go /authors, or you can click on the banner in the first page, you can see the featured content from our luminaries. And also we announced a new GitHub organization, github.com/Java, where you can find the repos and also the content repo where you can also learn how to contribute to dev.java. So we're extremely excited to make those announcements this morning as well as right now.
So we talked about 3 important dimensions that keep Java vibrant. One is the technology, innovation, one is the enterprise value, and of course the ecosystem. And if you look at all 3 of those dimensions, the binding thread, again, is you. The binding thread is you. Technology innovation doesn't happen without your feedback, without your input, without you downloading early access builds, without you playing with the preview features and giving us input. Enterprise innovation doesn't happen without us partnering with you, understanding your business challenges so we can come to you and help you solve your challenges, help you drive your business forward. And obviously the ecosystem. Ecosystem is about learning, it's about sharing, it's about collaborating. The ultimate thread here is people. We've taken a mentality of people first, technology second, and that's what's kept Java so vibrant. So we're looking forward to continuing to partner with all of you, and I mean all of you in this room, all of you on camera. That's how we keep the next 28 years and beyond vibrant for Java. I think we have time for questions. We actually have time for questions. And so here's your chance to participate, because again, this is all about participation. So if you do have a question, we can just raise your hand and we'll pass the microphone on to you.
Thank you. Please clarify, is Java 21 an LTS or not?
Sorry, I didn't hear.
Is Java 21 LTS?
Yeah, so thank you for that question. I want to make something kind of really clear, because I know there's sometimes some confusion about this. So LTS is not a property of a release, right? Every feature release is just a feature release. They're all the same. LTS is an offering that vendors can choose, or others who make a distribution can choose to offer for the people who use their distribution, where they'll offer the ability for you to report a bug and get some kind of fix in their distribution over time. Oracle is intending to offer LTS for JDK 21, just as we did for 17, 11, and 8. And we're going to do that for at least 8 years, which is sort of the standard that we start with. Do you want to say anything about? Okay, all right.
Other than my grandkids are going to be supporting Java 21.
Donald's grandkids are going to be supporting Java 21, which is amazing because he doesn't have grandkids yet.
We're going to start with an 8-year. We'll start with 8 years and see where we go. And actually, coincidentally, we announced today that Java 11 we're supporting now until 2032. Right. So, at least 2032, right? So every year, basically every September, we look at adoption rates, what our customers are asking for, what the ecosystem is doing, what third-party libraries have made a transition to a particular version of Java. And then we update our support roadmap. And so Java 11, we've moved to 2032, but we always start with 8. So Java 21, we'll start with 8 years, and we'll see where we're at.
And just one thing to add on to that. So the way that Oracle is currently thinking about our support offering is that based on feedback that we've gotten from, probably some of you in this room, that's something that we're intending to offer on releases every 2 years. And when we actually started with the 6-month cadence, our intent and what we said was that we were going to do it every 3 years. But we basically heard from people that adoption of these has been smooth. We really like it. We'd like to just have those happen more often so that we have more choice.
And if we like your question, please stick around. We have a t-shirt or a hoodie for you. If we have limited sizes, but hopefully we can get you one. Sorry, on the stream, we don't have 800 of them.
Raise your hand again if you have a question. We'll come around to you.
The hoodies are really nice.
Oh, here we go.
Any built-in AI code generators?
Yeah, thank you for that question. I actually want to. All right, I'm going to flip that around a little bit because I wanted to sort of mention how we think about what kinds of things we put in the JDK. And in general, one of the things that goes into our thought process is we want to put things into the JDK that really can only go there. We don't want to put in things that could be libraries where there could be hundreds of them that you could choose from. We've kind of learned that the hard way. I don't know how much XML parsing is needed in the JDK. We certainly have reduced the amount over the years. But basically, when we look at a problem like that, right, the temptation is to say, why don't you guys just put the best AI library into the JDK? And our view is, no, we want to think about what is it in the JDK or in Java as it is today that prevents it or doesn't encourage it to be the best platform that everyone wants to choose and automatically thinks of when they're going to try to solve that problem and write a library for AI. And so, we actually, that particular problem is one we've been thinking about for probably 8 years or more. We got together with a bunch of people who were architects on Hadoop and some of the other big data solutions back then, and asked them exactly this question. We were like, well, we see you're doing all this stuff in Java. How's it going? How do you like it? And we're like, well, we really love it, but, right? And then they told us the things that they felt were limitations that we needed to, address. And we were like, wow, those things are important. We need to figure out how to deal with that. How do we, make it easier to wrap native libraries that are doing cool things like tensors? How do we, or other things, right? How do we make it so that the representation of complex data in Java is not making the assumptions and taking up as much space in the heap as it does today. And if you look at the projects that we talked about and the others that you see going on in the OpenJDK community that we're stewarding, it's really about solving those problems. And this is kind of funny, right? The sort of first thing I was saying, why don't you just put the library in the JDK, is an example of someone coming to us with the solution they think is the right one. And we try to listen to those and understand, but figure out what are the underlying problems that really need to be solved. And then, how can we solve them in a way that can only be done in the JDK so that we open up and, unleash the possibility for an ecosystem. So Panama, it's about wrapping native code, right? In a way that's easier, faster, more secure than you had with JNI. Valhalla, just stay tuned. We're going to see great things coming from that project, I predict, and that is basically about this, better representation of complex data with value types. Same thing with, Loom, with things like ZGC. There's going to be a great talk on garbage collection today and low latency garbage collection for massively large heaps. And so all of these things tend to work together. And, when we were sort of originally thinking about it and creating those projects and initiating them, it wasn't necessarily AI and ML that we were trying to solve. It's actually sort of the same sort of problems that you need to solve for that and a bunch of other use cases. Now, I think you may have had a little bit of a different question, which was, okay, but what do you think about generative AI for creating Java code and helping developers? So interestingly, I have a similar answer there. Because basically this thing you heard about JShell and the playground, Well, when we delivered JShell, it wasn't about the all singing, all dancing tool that's the only thing that could do what JShell does as a REPL for Java. It was basically, here's a tool that's an example of using the underlying APIs that we've created so that that tool and IDEs and generative AI could use this in order to interact with the Java compiler, try things out, find things out, and move on from there. So again, it's the same sort of philosophy of thinking about trying to add the value that can only be done in the JDK so that you've got a tremendous ecosystem. Hope that helps. Thank you.
Well, I think with that, we are at the end of time. But before we go, number one, thank you again for spending your morning with us. So thank you to all of you, especially those online as well. And remember, many of the topics that we've talked about today, we have further sessions on. So we have a full exploration on Java 21. That's one session. We have a virtual threads just focusing on Project Loom. George mentioned some of the other content, especially some of our commercial features. We have a session on Enterprise Performance Pack, and we have a Java for Business session. So take a look at the content catalog. We'd welcome all of you to come to all of our sessions. But more importantly, stop by our Java booth. All of us will be here, the panelists, as well as other members of the Java team. We want to keep this conversation going. And more importantly, stay true to the community. You're here as an important part to keep Java vibrant. So thank you very much.
And say bye to the live stream. Bye. Bye. All right, thank you.
Okay, hey, we're back. So how's everybody doing?
Hey, yeah.
You good?
I'm good. Are you good?
Yeah, that was an interesting panel. I mean, in some parts there, we treaded some of the ground we talked about earlier, but there were also quite a few very nice aspects in there that I pointed out. I'm not sure whether everybody saw, but I did the kind of like...
I saw you pop in during the LTS portion.
Yes, exactly. But I told you so dance for... Thank you, George. At least somebody out there shares my understanding. Or rather, actually, honestly, I share his understanding, but be that as it may.
And to summarize that understanding is that 21 is not an LTS release, but it's a release with LTS offerings.
Yeah, exactly. Long-term support and 21 belong together, but that doesn't make Java 21 LTS version. It just means that lots of companies offer that. Yeah, exactly. And then somebody else asked that in chat earlier, and we answered it back then, but it has popped up since. So the question of machine learning and AI keeps popping up. And note that George also replied to that, right? He said, instead of having the one machine learning library and pick a winner and implement that on Java with some magic so it's fast enough, Java wants to evolve to the point where everybody can implement a machine learning library on Java, and then there can be many winners. And that's the way to go, right? Java has many IDEs, many web frameworks, many testing frameworks, many mocking frameworks. In some of those areas, there was a winner eventually, but OpenJDK didn't pick them. The community picked one because it was the best at some point, right? So let's say, for example, I'm a big fan of JUnit 5. I think it's fair to say that JUnit is like the dominant unit testing framework at this point. It's similar for mocking or assertions, for example. And that's the way to go. And that should also happen with machine learning. But Java, the platform, needs to get ready for that.
Yeah. On the subject, to segue to community and not picking winners to a certain extent, let's talk about our community contributions to dev.java, which is something that Chad talked about during the panel. Of course, we have our dev.java, and we have our section on learning Java, where, of course, you'll see many different subjects. And if you look at this really closely, if you're often following it, you'll notice there is a few new sections, like here on virtual threads, Java FX fundamentals, and getting started with Java certification. And all of these were contributed by our community members. The virtual threads by Kai Hortzman, Java FX fundamental by Gail C. Anderson and Paul Anderson from APRESS, getting started with Java certification by Gene Boyarsky, reflection by Dr. Heinz Kabutz, and also refactoring from imperative to functional style by Venkat Subramaniam. That what you were just talking about is also kind of related to the community of Java, because we have such an incredible community of luminaries, just really smart people. We've been able now to kind of ask them to help contribute to dev.java, to share their knowledge and help improve the learning process of dev.java. But yeah, as we said, we're opening the process up to do it farther. So like we kind of did this initial process where we reached out to these contributors just because of all the great work they've done in the community. And I think and then as Chad mentioned during the panel, we're going to be continuing kind of to work to open up this process to be able to take in more contributions from the community as well. Of course, as we all know, open source and open source governance is hard, and that also applies to community contributions. So we will continue to kind of work on opening up this process. But yeah, that's your work. Did you have any thoughts here, Nikolai?
Yeah, I think the last thing you said is actually kind of important. So this is not a Java blog. It's not a Java news site. It's not like a random collection of everything Java. We're not going to have Spring Boot tutorials here. So, I mean, not because anything is wrong with Spring Boot, by the way, just that they have their own really good website.
Yeah.
There's no need to duplicate that here. So, so the scope is, very much focused, of course, on Java core itself and on tutorial like explanations, like you see there, like a really from the ground up explanation of why virtual threads are important. And so I think, we'll be going down that vein, probably looking for with specific ideas in mind, then looking for community members to contribute those. I'm just saying this, to manage expectations. So if you have like a great idea for a Java blog post, like dev.java might not be the place where it goes live. Even my ideas don't go there.
Yeah, exactly.
My ideas go on my blog to die.
Yeah, we're very much looking for a tutorial format that kind of really explains concepts, not just necessarily like to say like your example of like JUnit 5. We're not gonna probably really have something from like JUnit 5 in here because they have their own side for describing that, but like also just to use maybe like a JUnit 5 example, it's like, oh, here is how to write a integration test or a unit test, or what's the difference between like an integration and unit test. Like that's a blog post, and that's not kind of what we're looking for here. So like I said, if that is helping, if you want to be interested in contributing, it's very much of important key concepts to OpenJDK on Java itself that we're looking to share, for that's the kind of contributions we're looking for.
Yeah, that makes sense. Okay, you got more to share there, or should we pick something else?
Yeah. Did you have any ideas? I think.
I got something.
Okay.
So the AI topic has been bobbing around in chat. So there is C, C++, and Python come up a lot, of course. And I think that's a good conversation how it's going right now, right? The understanding is that Python doesn't do all the machine learning. I mean, it does most of it. Just like, let's simplify to all machine learning is in Python. Well, not the machine learning itself, right? The machine learning itself is written in C, C++. Usually Python is doing great in that space because it makes it easier to bind. It has really good data visualization. It's a language that is easier to get started with. And if you've been here throughout the stream, you can connect the threads. You can see how some of those things popped up before, right? We talked about how Java can become easier to just get started with. We talked about how did we talk about the foreign function memory API? I don't think we talked about it too much because it's still in preview. It's probably, maybe, hopefully going to be final in 22. It just so didn't make it in 21 because there were still some changes that they, the Panama leads and the Panama team wanted to get a round of input on, which makes sense. So,
and that's like by design. It's much better for us to wait to get these APIs finalized and in really good state than to try to make a release and get them out earlier, because, I mean, certainly there's been history where serialization is a go-to, where it's like, oh man, there's a lot of things we wish we could have changed about that, but you're stuck with it. Once it becomes fine, once it becomes truly public, you have to support it. So, it's JUG 454, I believe, that is currently in candidate status, but that should be pushing the foreign function memory API to final.
Right. So like that JAP, like it's, I mean, everything can happen, but most of the times the predictable thing happens. And so I'm pretty confident, in my personal opinion, once again, that foreign function memory API will be final into Java 22. And from then on, that's a big step forward, right? But on the horizon, there looms, even better stuff. Like ideally, you would be able to implement machine learning and AI stuff in Java without having to switch to a different coding environment. So at the moment, that's out of reach, because for that kind of stuff to work, what you need is like really hardcore, just number crunching performance on all kinds of custom numeric types, or at least like small types that Java doesn't have, like half floats or something. And that's where Valhalla is on the horizon. That's something that Valhalla might be able to provide. Like, it's not entirely clear how exactly that would pan out. I don't think that, I don't know. Hardcore number crunching might never be like quite the same as C. I'm not enough in that space to know that, how achievable that is. But you don't have to be all the way there, right? If you get like 80, 90% of the performance, but you get all the IDEs, all the safety of Java and all of that, that would still be great. And so Project Valhalla has something in an offer there with their value types and the flattening and everything. But also, again, from Project Panama, we have the vector API. And the vector API is also really big when you do number crunching. That one is in incubation. It waits for some Valhalla features, but it is extremely stable. Like, the API will change when Valhalla comes. That's why it's still incubating. But other than that, like, it is very stable. It has not changed at all, like I think in 21. And it's doing a good job using vector instructions on the CPU. You might know that as SIMD, single instruction, multiple data. So all of that is on the horizon, and I'm hoping that that will enable Java to be more attractive to machine learning and AI applications, either native in Java or otherwise. See, yes, you're smiling. You have some witty
I was
comment?
just going to say I wasn't paying attention. I was too busy tweeting, and I was tweeting because I just wanted to mention that this relatively unknown figure in the Java community, Brian Goetz, I believe is the name, will be joining us on this live stream in about half an hour to be talking about pattern matching and Project Amber. Yeah, that's going to be great. So if you need to take a break, there's a video upcoming where I talk about pattern matching. It's boring. Don't watch it. After that, that's when Brian Goetz comes. And he will be able to answer all the questions about that. And I saw some other questions that were like, why don't we have dollar curly brace in string templates? That's also Project Amber, which Brian leads. So, if you run out of pattern matching conversation, maybe people can ask him that. But that was very much a hot topic of conversation earlier in the stream, and certainly, I guess we'll wait for Brian to also weigh in on that. But yeah, I think you and I, a bunch of people, are trying to explain some of the reasoning behind that. And one of the important things to always remember, also just to that previous conversation when it comes to preview features and all that, is that there's a huge existing code base to Java. And so just adding changes that could potentially break a lot of people, we have to be very conscious about that.
Yeah, definitely. So big backwards compatibility is one big argument why the dollar curly brace doesn't work. But beyond that, and that's maybe just my thing, but on a German keyboard, it's actually super easy to type. I have to hold down the Alt key that's next to the space, and then it's just like two buttons up there. It's the one next to the 0 and 7. So for me, it's actually easier to type /curly brace than $curly brace. So I'm happy. Everybody's staring at the keyboard now. Wait, how am I?
I know exactly.
Okay, that's that. Should we try to go into the next video? Should we see how well that works this time?
I think so.
I think somebody more competent than me prepared it this time, so we have good chances that it works. So let's try this. Imagine we're writing an employee management tool. For our core domain types, we start with an interface employee, and for now, salaried and freelancer are all the implementations we need. The next step is to add operations, to request and confirm signage of legal documents, to manage access to various platforms, to track completion of compliance trainings. Can you tell I'm working for a large corporation? To issue payments, to plan project work, to schedule holidays, etc. We quickly realized that it's probably a bad idea to place all those very disparate operations that interact with mostly separate subsystems on the same type. Imagine employee gobbling up all that functionality and in turn, depending on most of our system. I shudder at the thought. So we need to separate the operations from the type. We leaf through our copy of design patterns and land on the visitor pattern. Immediately, the shudder returns, and we wonder, Isn't there a simpler way? And the answer is, in Java 21, there absolutely is. Just like Lambda expressions turned the strategy pattern into language features, so we hardly think of it as a design pattern anymore, does pattern matching turn the separation of types and operations into a simple application of a few language features, namely patterns, switch, and CS types. And that's what this last episode on the road to Java 21 is all about. So let's get started. So it should come as no surprise that this is what's called pattern matching.
Pattern matching lets you construct your own data-driven dispatch in your implementation code rather than an API code.
We'll take things slowly and start with a feature that you, if you're on Java 17, might already have used, the extended instance of. The old clunky way to type check with instance of consists of 3 steps. The type check, the declaration of a new variable, and a cast of the general variable into the new one. The extended instance of combines all 3 steps into just one operation. With a simple if employee instance of freelancer, we get the type check, a new variable of the desired type and name, and the old variable cast into it. We can use the new variable freelancer everywhere where the condition is true, in this case in the if branch. Now, if we want to implement an operation that accepts an employee instance but needs to handle each type differently, we could create a series of instance of checks that runs through all known subtypes. I know you're feeling that shudder again, but stick with me. It's only a hypothetical step on the path to a good solution. Let's analyze it though. If the method doesn't return anything, the if-else-if chain doesn't need to cover all cases. And if we add an additional class, contractor implements employee, for example, we suddenly get no behavior at all for its instances, and that's not good. So it's probably a good idea to at least add an else branch that throws an exception, but then we still only find out at runtime that a branch is missing. That's a serious maintainability problem, and the reason for the shudder you felt earlier when I started going down this road. We need to improve over this. But let's put a pin in it for now and turn to another feature that's already available in 17, one you've probably used way more often. The good old switch statement has seen 2 important improvements. One is that we can use it as an expression, meaning it computes a value that we, for example, assign to a variable on the left-hand side or return from a method. Where to use this depends on context. Do we need to compute a value? Then we'll use switch as an expression. Or do we just execute some code? Then a statement is fine. The other improvement is that instead of following up the case label with a colon, we can now use the lambda arrow, which eliminates fall through and thus the need for all those breaks. This should definitely be your default choice, unless you intentionally want to fall through. Now, imagine for a moment that instead of an employee interface with 2 implementations, we had created an employee type enum with 2 values, salaried and freelancer. Then one way to implement an operation that differentiates by type would be to switch over employee.type and to write a case for each enum value. We can use the fancy new array syntax, but there doesn't seem to be a need for a switch expression, and so it's a statement. Unfortunately, a switch over enum statement doesn't need to cover all cases either, and so we get the same behavior as with the if-else-if chain, where a new enum value is silently ignored. We can add a default branch that at least throws an exception, but we would still rely on tests to find errors before they occur in production. Still the same maintainability problem, still needs improvement. On the way there, let's combine the 2 approaches. We're back to an interface with 2 implementations, but now we're using the type check from the extended instance of in switch. This is only possible without additional command line flags since Java 21. As you can probably tell by now, a line like case freelancer arrow something checks whether employee is an instance of freelancer, and if so, executes the code on the right where a variable of name freelancer and of type freelancer is available. At first, the only advantage of this is that we have the expressiveness of the switch that clearly communicates that we have 1 action per branch, while not needing an additional enum to differentiate by type. The class information suffices. The game changer is hidden in between the last case and the end of the switch. See what happens when I remove the default branch. We get a compile error. That's because the compiler requires that a switch over complex type covers all possible implementations. As is, that only forces us to include a default branch, but now we'll fold in another Java feature that you might already be using on JDK 17, although that would surprise me a bit because it didn't really get you anything. And that's sealed types. Regular types can be implemented by anybody who can get a hold of them, and in the case of a class, can reach the superconstructor. For simplicity's sake, let's stick to interfaces though. The only way to limit an interface's extensibility is via its visibility. Otherwise, everybody can implement it. And that's fine for things like collection or list, but with core domain types that have a lot of logic attached to them, it's not really feasible to expect that simply adding an implementation like a contractor for employee just works and doesn't require any other changes in the system. No, your code probably depends on you knowing every implementation of that interface. And that's what sealed interfaces are for. You can declare an interface like employee sealed and then permit all possible implementations. In our case, that's salaried and freelancer. There are some requirements for the types that implement a sealed interface or extend a sealed class, but I gloss over that here. There's a link to a detailed explanation of sealed types in the description. What's important for us here, and really 80% of what sealed types are about, is that the compiler understands the limited extensibility. For a sealed interface employee permits salaried and freelancer, it knows that when you have an instance of employee, it must be either an instance of salaried or of freelancer. And with this final ingredient, we get our compile time verification of operations that need to differentiate by type. Because look what happens to our switch when we make employee sealed. The compile error is gone. The compiler understands that we covered all possible subtypes of employee. That's called exhaustiveness or being exhaustive, and it stops bothering us. But at the same time, it's still watching us closely. Because when we add a third implementation, we also need to add it to the permits clause, and bam! The compile error is back. This is huge. This is what the entire complexity of the visitor pattern was there for, to separate types from operations while making sure that adding a new type forces us to update all operations to handle it. This way, we get the same safety. All we have to do is make the type sealed and avoid default branches. That's important. Let's talk about that for a minute. When switching over complex types, the compiler requires exhaustiveness. The trivial way to achieve that is to add a default branch, but the critical disadvantage of that is that if we add another implementation of the sealed type, the switch is still exhaustive, and we don't get a compile error, and so we don't have to update our operation for the new type, and it silently falls into the default branch. That may be the correct way to handle it, but it also might not be, and it's really only the developer, us, who can make that decision. So it's important to avoid an outright default branch and instead list all types explicitly. We cannot combine multiple types into one branch, and so in the worst case, we may have to repeat the same behavior for a few different types. If only there was a better way to handle this. And that, my friends, is called foreshadowing. I'm alluding to something that happens later in the video to build anticipation and add tension, so you stick around for the important things that are coming instead of switching to cat videos. Are those still a thing? Or am I dating myself? Anyway, before we resolve this tension, let's talk about the term in the title of this video that I didn't even explain yet: pattern matching. Remember the instance of triad, a check, a declaration, a cast? If we generalize this to a check, declarations, extractions, we get something much more powerful. For example, if the employee is of type freelancer, declare variable freelancer free and assign the employee to it. Or if the freelancer is composed of a name and an hourly rate larger than 250 euros, create a variable string name and assign the freelancer's name to it because we probably want to fire them. Or if the list of string is not empty, declare variables string first and list of string tail and assign the first element of the list to first and the rest of the list to tail. Or if the map from ID to user contains an entry for specific ID, declare a variable user u and assign the user associated with that variable. Checking a variable for some property and then declaring new variables to capture that property is extremely common. What you're doing here is matching a variable to a pattern, and if it fits, extracting information according to that pattern. So it should come as no surprise that this is what's called pattern matching. The extended instance of and its counterpart in switches are called type patterns, but that's not the only pattern Java has on offer. But before we get to the other one, let's zoom out a bit. There's a bigger picture of what pattern matching means for Java. And who better to explain it than Java language architect and player of long games, Brian Goetz.
So pattern matching is related to dynamic dispatch. And historically, Java's approach to dynamic dispatch is tied strictly to the class hierarchy. So we define a virtual method through an interface or a base class, and then subclasses provide their own implementations, and the method invocation mechanics handles the dynamic dispatch. And this is really powerful, but it's rigid, because in order to harness the power of this dynamic dispatch, we have to reflect the dispatch points as public API points and reflect each dispatch option as a separate implementation of the type declaring the dispatch point. This works great when the dynamic behavior is something that we really want as a first-class public API point. But sometimes we want to make dynamic, data-driven decisions without having to expose all of this on our APIs. So historically, the way we had to do this was with the visitor pattern. And this works, but it really just moves the problem somewhere else. So visitor lets you take polymorphic operations out of the public API for your domain model. But the flip side is that visitors are pretty intrusive and rigid in their own way. So pattern matching lets you construct your own data-driven dispatch in your implementation code rather than an API code. And this is more flexible, more concise, less intrusive, and can be used to yield benefits in several different ways. Now, pattern matching wouldn't and shouldn't replace API-based polymorphism. It complements it. Some polymorphic operations are essential to the domain, and they make total sense to be part of your API, and we'll continue to use public API points for these. Others don't really make sense to be part of your domain model, and pattern matching lets us more easily move these to where we belong. So pattern matching gives API designers a richer toolbox for exposing the right shape API. Now, if we were to decide that a particular polymorphic operation belongs in the API, pattern matching still offers us some extra flexibility. You can continue to use method overriding to implement the operation, but if you know all your subtypes, which is going to happen more frequently now that we have the ability to declare sealed class hierarchies, you can also write a single data-driven implementation using pattern matching. The clients won't be able to tell the difference, so if you have pattern matching in the language, even if you're not going to use it to change the structure of your APIs, it still offers implementation flexibility for API developers. And finally, pattern matching gives more flexibility to API clients because they can more easily and safely create new polymorphic behavior, even if the underlying domain model hasn't exposed it directly. So we should think of pattern matching as offering us another path to polymorphic dispatch that can be used in different situations from ordinary virtual dispatch. And if the data-oriented polymorphism of pattern matching is a better fit for your problem, you can use that. And otherwise, we can continue to use the tried and true object-oriented techniques.
As Brian just explained, pattern matching can be used to implement polymorphism. In an object-oriented approach, that can occasionally complement polymorphism by inheritance. We can take it much further and forgo OOP for most of our domain and pick a much more functional approach. But where functional programming places functions at the center, with data representation a close second, what I'm talking about switches that around, no pun intended, and focuses on data first. It's called data-oriented programming. Data-oriented programming proposes the representation of outside data in your program, not as objects that combine mutable state and operations and that data needs to be contorted to align with, but instead represented as closely as possible with simple immutable types. We'll see in a second how to do that. You'd apply data-oriented programming in situations where a system or subsystem is mostly focused on ferrying data back and forth between a few connectors to outside systems. And that doesn't require the kind of modularization object-oriented design affords us. That is more likely if the system or subsystem is somewhat small. But how do you represent data as closely as possible? We'll see. The ingredients are relatively simple. The main one, and if you're on JDK 17, I'm sure you've already used it, are records. Designed as transparent carriers of immutable data, they're perfect for this task, and that's no coincidence, by the way. You'll use them to create types that represent specific data as closely as possible, so you get the most out of Java's type system. So if your data contains salaried employees with a name and a pay grade, as well as freelancers with a name and an hourly rate, don't try to find a smart way to combine that in one class. Just create two records that fit the data exactly and put in the work to make them airtight. You want to enforce all requirements for the data in the constructor or factor method to make sure that only legal states are represented. And by default, these types should be deeply mutable. Record fields cannot be reassigned, but if they reference a mutable type, say an array list, the collection could still be changed by calling add or clear, you probably want to assign a list.copyof to the field instead. Still, some data might have non-required fields. We can argue whether to model them with null or give their components an optional type. I'm clearly in the latter camp, by the way. But don't let this seduce you into modeling an A or B scenario as a single type with tons of non-required fields. Instead, add the other ingredient, sealed types. You'll use them whenever there are alternatives between different kinds of data. So if your data contains contracts, and each contract links to an employee that is either salaried or freelancer, you'd create a sealed interface employee that permits two implementations, salaried and freelancer. That nails our types down. Now let's talk about operations. Unless they just combine data on the same type, like a first name and a last name to a full name, they should not be defined on these types. Beyond that, you already know most of what you need to know about operations over these types from the first part of the video. But since we're now dealing with records a lot, let's add the other kind of pattern that I alluded to earlier. That would be record patterns. Remember this example? If the freelancer is composed of a name and an hourly rate larger than 250 euros, create a variable string name and assign the freelancer's name to it. That's exactly what record patterns do. The check is whether we indeed have an instance of the record. The declarations are one per component, and the extractions are assigning the component values to these variables. With record patterns, the implementation of extracting the freelancer's hourly rate is a simple case freelancer, string name double hourly rate, or var name var hourly rate if you prefer. And if we want to add a condition, we use a so-called guarded pattern. After any pattern, we can write when, and then some Boolean condition, and of course the branch is only executed if the condition is true. The astute among you may wonder how this interacts with exhaustiveness. Clearly, a case freelancer when hourly rate larger than 250 does not cover all freelancers. Can you add a case freelancer when hourly rate is smaller than or equal to 250? Yes, absolutely. But it won't do what you hoped. The compile error would still be there. The reason is, well, that computer science is very mean. If you allow arbitrary checks after a when, it is categorically impossible that the compiler can figure out for all conditions whether all possibilities are covered. You could limit the kind of conditions and then implement a checker for that, and then make all that part of the Java specification set in stone for eternity. Or you just don't. Treat any guarded pattern as inherently incomplete and require an unguarded pattern for each type to achieve exhaustiveness. So in this case, just add a case freelancer without any when after all the case freelancer when, and the compiler is happy. Yes, you don't get to express the symmetry of larger than versus smaller than or equal to, but unless you're like me, you're probably not going to lose sleep over that.
Hello, darkness, my old friend.
If you want to learn more about data-oriented programming, watch Inside Java Newscast number 29 or read Brian's seminal article on the topic, both linked in the description. For now, I want to leave you with the 4 principles he defined. First, model the data, the whole data, and nothing but the data. That's the part about creating types that match the shape and alternatives of the data closely, as well as the part where you do not add operations as methods to the data, but as functions operating on them. Second, data is immutable. That were the records and the immutable copies in the constructor. Third, validate at the boundary. And fourth, make illegal states unrepresentable, both of which are covered by designing types correctly and rejecting illegal combinations of data in the constructor. And that's it for data-oriented programming. Right. Phew, that was close. You don't want to know what happens to YouTubers who foreshadow something and then don't follow up on it. Whew. I let you hanging on how to combine multiple types into one branch with defaulty behavior.
Hello, my name is Angelos Biboudis, and I work for the Java Platform Group at Oracle. There are numerous cases where we want to describe some functionality in code while clearly expressing that some elements can be ignored. Java 21 reintroduces the underscore character as a preview feature to be used for ignoring pattern variables, whole patterns, or other kinds of variables outside pattern matching. Let's continue the employee management example and add an intern record. Imagine that we would like to write code that processes the first case but does not care about the other cases, as our abstract data type is today. We can express this with default. That would indeed make the switch exhaustive, however, there is a hidden caveat. While this switch is now exhaustive, it is not future-proof. If someone adds a new variant in the future, the snippet will never fail to compile or execute. The compiler can do a better job of checking exhaustiveness without a default case. If we want this switch to signal us back a missing case upon recompilation, there is indeed a better option. We include the variants of freelancer and intern. Notice that both f and I in this case are now unused pattern variables in our code. We can replace both with underscore and make our intention that we do not care about variable names clearer. Since those last two cases do not introduce any variables in the scope on the right-hand side of the cases, we can remove the duplication and write this more succinctly in one line. A case with multiple patterns that none of them introduces pattern variables. This version of the switch is decluttered and offers error reporting upon extension of the data type. Unnamed pattern variables can be used in nested positions as well. For example, when we deconstruct a salaried employee in this example. But also for whole nested patterns. Here, underscore in the first case is an unnamed pattern. There are other valid cases of unnamed variables, for example, in try with resources, when the resource name is not needed.
Thanks, Angelos. He's the owner of JDK Enhanced Proposal 443, which introduced unnamed patterns and variables as a preview feature in JDK 21. I'll tell you more about that in our Road to Java 25 video series in 2 years. Because we're done, not only with pattern matching and data-oriented programming, but with the Road to Java 21. From upgrade hurdles to virtual threads, from better tools and security to improve performance in APIs, and now pattern matching, we've covered everything new between Java 17 and 21. We really enjoyed creating this series, and everybody invested a lot of time and energy to make the best videos we could. If you like them and have the chance, leave a few nice words for Anna, Billy, and Jose in the comments here or under their videos. I'm sure they'll love to read them. Another person who deserves praise is David Delabassi, who created the intro, the thumbnails, and is generally the good spirit behind our YouTube channel. Thank you, David. All that said, I hope to see you again in the next weeks and months for regular programming, Jab Cafes, Stack Walkers, Inside Java newscasts and podcasts, conference talks, and more. This is the best place on YouTube to learn deeply about Java. Subscribe, and I'll see you around. So long.
Hey, Billy. Billy, are you mute?
Okay, there we go. I forgot to unmute. There we go. My bad.
I was going to say, like, that doesn't sound like you.
Yeah. Oops, sorry. All right, and I'll go, without further ado, I'll go ahead and add Brian to the
Writing
stage.
an employee.
Oh, no, that's not what I wanted. There we go.
Howdy.
Whew. All right.
Yeah, we don't
First
want
time
to see
I guess I've done
Nikolai
a live
again.
stream. I know, that too much of Nikolai. All right, so glad to have Brian Goetz with us. Nikolai in that video just covered a lot about pattern matching, but I'm guessing you have a few more things to share about pattern matching as well. Is there anything you wanted to touch on that maybe wasn't in the video, or?
Well, so I'm pretty happy to see that people are catching on with what pattern matching can do, for them and their code. When we started talking about adding pattern matching to Java, and this was probably 4 or 5 years ago that we started, having these conversations, there was an awful lot of, oh, what do we need that for? Oh, that's just a cute syntactic trick. And I think people are starting to recognize that there's a bigger picture here. In fact, there's sort of two bigger pictures here that I want to highlight. One is, the move towards better modeling of data as data. And this is, you take records and you take seal types together and you get algebraic data types, and then you have pattern matching for, that allows you to easily traverse, data described by algebraic data types. And that's a really powerful modeling technique. And I'm glad people are starting to see that. But there's sort of another big thing that is only starting to peek out of the shadows now with the features that are coming next with pattern matching, which is historically, when you model some entity with a class in Java, the way you put it together and the way you take it apart are completely different. So if you have typical object in Java, you put it together with a constructor call or a factory call, and you pass a bunch of parameters in to describe what you want to do, and then maybe you call some mutative methods to make some changes. And then if you want to query its state, you call some ad hoc API with getters or something like that. And when the techniques you use for putting things together and the techniques you use for taking things apart don't line up, not only is that confusing, but it also means that you can't compose these two operations. You can't say, take something apart and put it back together slightly differently without having to deeply understand the accidental details of the API. And one of the things that pattern matching is aiming towards helping us do with our Java code is to make taking things apart sort of an operation at the same level as putting things together. So, if you put things together with a constructor, you can take them apart with a deconstruction pattern. If you put things together with a static factory, you'll be able to take them apart with a static pattern. In some future version of the library, if you can put things together using collection literals, you'll be able to take them apart with collection patterns. And we want this taking apart and putting together to be two sides of the same coin. And right now, they're like two sides of different elephants.
Yeah, no, that's definitely going to be very nice. I remember it's been a number of years now where at an old job, I was having to do like a lot of work with data, like we were doing a lot of ETL, which is obviously something very common. And it was such a pain. Like I was having to use, it was from XML, and I was like having to use this library called Caster. And every time I see all these changes now with Project Amber and all the data, it's just like, oh God, it would have made that process so much easier. Cause like it was like 2 or 3 months or something like working on that, and then constantly running into little data issues, and then having to create all these little intermediary classes. Yeah, I just wish this was here about 10 years ago for that.
No, absolutely. And, and we're, as Nikolai kind of hinted at, we're entering an age where the boundary of our object model is different from what it was, 15, 20 years ago. So, 20 years ago, you had these big monolithic applications that were Java end-to-end, and even when you left the machine and sent data to another machine, it would be in the form of serialized Java objects. So it was like everything was Java objects, and that was great. But that's not the world we're programming in anymore. We're programming in a world where services are smaller. That means any code is closer to the boundary, and the boundary is defined not by a Java API, but by something much weaker, like JSON without a schema. And since we don't want to be doing our data manipulations on substrings of JSON documents, we want to model things with Java types. It means that we're going to have to navigate that boundary of data comes in the form of some JSON blob or SQL result set, and I want to very quickly turn that into data in the form that I want, that's validated, that's correct, that's immutable, work with it. And then in the other direction, when I'm going to send a response back, I want to be able to convert that data easily to whatever wire schema that my data is serialized to. And so, we're living in a different world, and we need different tools.
Yeah. One question also I know I've been asked a few times at conferences and presentations is also if withers are going to be coming to records, or I guess weigh in on what your thoughts are on that.
Yeah. So this is so quickly to give you the good news. Yes, coming soon, actively being worked on. You should be seeing a draft JEP of that in the next month or two, for discussion. Probably not going to be able to get it into, the next release, but possibly the release following, because it's not a huge feature once we, once we spec it out. But withers, connect very much to the comment I was making earlier about taking things apart and putting things together. Because if you have a with expression, You know, and a lot of people probably haven't seen this. Do you have like a code example you could pop up on the screen, like point with x equal 3 or something like that, just so people can see the the kind of code that we're talking about?
Do you, and are you able to maybe quick that pull up? I had to close up a bunch of stuff because my battery was being drained because of running all this stuff.
Okay, so what code? What should contain?
Yeah, just an example of a with expression, so that everyone knows what Billy's talking about. You know, like point with x equal
I don't have.
Yeah. All right, I'll type the code into the chat for you guys, and then you can figure out.
Yeah. Okay. Here we go. Yeah. Give me one. I know what you're talking about.
Yeah.
Give me 1 moment. I'll get that popped up on the screen.
Yeah. So while you're doing the AV stuff, I'll keep talking. So it's great that records are immutable, and everyone likes that you don't have the boilerplate of getters and setters, because you don't need setters because the thing's immutable and the getters get automated for you. But you kind of do need something like setters, because we often want to derive one record from another, where we say, I want a record that's the same as that thing, except with this component having this value. And we could do that with a coding pattern like we do for setters, except no one wants to do that. We just got rid of all the boilerplate of our getters and setters. Why would we bring back new boilerplate for withers? Records are immutable objects. We're going to be getting, that's exactly what a with expression would look like. And we're going to be getting value types soon. Value types are also immutable objects. So the question of how do I transform an immutable object in a straightforward, non-ad hoc way is one that we have to contend with. And so one of the features that's coming first for records and then later for classes as a whole is what we call a reconstruction expression. That's the new name for it. I don't know if that name will stick, but that's what we're calling it this week. And the example that Billy typed up was you have an expression that evaluates to a record. So point, that's an XY point. That's the only example I know how to write. And then a bunch of statements inside the curly braces. And the way to interpret that is take point, explode it into its components, X and Y, and then evaluate the block on the right side in a context with fresh variables for X and Y populated with the value of point.x and point.y. And you can see this will modify one of those variables, X, and it will leave the other one, Y, alone. And then at the end of that, it says, okay, now take that X and Y, feed it back to the canonical constructor for point. And this is a generalized, non-ad hoc way to transform an immutable object, into a modified copy. And the way it works is you decompose it with a deconstruction pattern, do some operation on it, and then reconstruct it with a constructor. And so, the comment I was making earlier about bringing, taking things apart and putting them back together sort of to the same level is, once we can do that in the language, then we can derive language features like this almost for free. Now, I have to put almost for free in quotes because nothing is almost for free. But, it's something that we can derive mechanically and reliably. And we can do that with records out of the gate because records are already constrained enough that we know how to take them apart. We know how to put them together. We know how to name their components. For ordinary classes, we'll have to do some more work. We'll have to write a deconstruction pattern. We'll have to give permission to treat the binding names or the constructor parameter names as being part of the API, because historically, parameter names have not been parts of APIs. So there's a little more work to get there for classes, but we'll get there, and it'll be really cool.
I think actually also one thing that's interesting. Oh, sorry. Yeah.
Your sound is very, very bad, like stereotype. Stereo with.
Is it better? It's good. No.
In the meantime, while you're muted, somebody asked, is this point with a destructive operation?
No, it's not. You know, the thing on the left side of the with operation is just a value, and it's going to extract some values from that. It's not going to modify it. It's going to leave it alone, and it's going to create a new value that, you know, whose state is like the original point, except with the modification x = 3. And the thing in the braces is just arbitrary Java statements. It's not a special syntax for what goes in the braces. You can do assignments, you can do loops, you can do conditionals, you can call methods. It's just Java code that executes in an environment that's augmented with these variables corresponding to the state of the point.
Thank you.
All right. Is my audio better this time?
Yes. It's
Okay.
better.
Yeah, I don't know why that just decided to go weird on me. Literally made no changes this time. So
It sounded like a battery was running out.
yeah, maybe. So actually, one thing that I think is also really interesting with withers, that I think also just to one of the last mover advantages you like to talk about, is that so a lot of people like to say like withers, or there's so many things just like, oh, we're just taking this from Kotlin or some other Python or some other language. But with withers, it's a really good example of how we're learning from other languages as well. Because I remember in your write-up is that like we kind of are following a bit from C#, but there's a couple of ways we're enhancing beyond what C# could do from lessons learned. I don't know if you want to kind of maybe talk to that point.
Yeah, so you know, so C#, you know, has you know walked this road a little bit as well, and they're actually on their second version of something like withers. So the first version, they added a number of features to the language to make it easier for you to write methods that behave like withers. So you could have you can have methods that you can invoke by parameter name, not just positionally, and you can have default values for parameters if you don't specify them. And they enhanced it so that the default values could depend on the receiver. And so someone could write a big with method with, you know, one parameter for every you know for every component, but have them all be optional, and then you could call it like a method. And that turned out to not, you know, not be that popular as an approach. And then they went and did a more linguistic mechanism, you know, for doing it like we have. So, you know, it was good that they, you know, they explored the space. You know, their solution is based much more on properties. You know, they have their language is very much based on properties, and they've been extending the semantics of properties, you know, quite continuously. And so they have a solution that's property based now, where the syntax for it is very pleasant, but then you can't put arbitrary C# code in the braces. You can only say something with and then make property modifications. You can't do computation in the block. And so what I like about this is, you know, we're inventing only a very small amount of new syntax, but everything else builds on things that are already in the language.
Nice. Yeah, I want to get to a couple of questions from the chat. So a recent one was asked, and multiple Java source classes with third-party dependencies. What kind of timeline is there on that? I believe I saw that as a discussion or in a job.
Oh yes, the multi-file source launcher, right? So that one is in active development. So, you know, a while back, you know, we added the ability to just compile and run a single file program just by saying Java foo.java instead of having to compile it and then run it. But that was limited to a single source, which was fine for, you know, for scripts and for small hello world kind of applications. And so more recently, you know, there's a JEP for extending that, where you can specify, you know, a script that spans multiple class files. And that's, you know, I don't have an exact date, but I know it's under active development. And again, it's not a huge engineering activity, so that's not going to take years. It's, you know, probably, you know, in the next version or two.
All right.
And this fits into sort of a broader trend of, you know, historically we focused on, you know, making Java, you know, the best thing for writing large systems. And Java has been extremely successful for writing large systems. But writing small things has always been a little bit painful. And so we've recently, turned our attention towards making it easier to write small things. So, the single file source launcher was part of that. Extending it to the, take multiple files is part of that. We've also, have what we call the paving the on-ramp, JEP, which is aimed at making simple programs like the kinds that students write in their first, semester of class, simpler and not put all of the object-oriented stuff in their face while they're still learning to write their first program. So, these are individual features that are part of a bigger feature arc, which is about making smaller programs more friendly as well.
Yeah, no, I'm very excited with all the paving the on-ramp changes. That's one of the first things I kind of was thinking about, is that is really building on Java's scripting / small utility program story, which, for a long time wasn't good. No one would really go to Java for doing that. But now, here within the next few releases, it's actually going to be quite strong.
Yeah, and it just goes to show, you can teach an old dog new tricks, right? That a lot of people make assumptions that, well, Java is what it is. It's always going to be that way. In reality, we look at what are the pain points that our, customers and people who we would like to be our customers, are actually experiencing. And, what can we do to make those things better? And, obviously we can't do everything at once. But, when we focus on something, we can usually do something about it.
Yeah. So we just got another question. String interpolation in Amber.
Yes, so that one is already in preview, in Java 21, right? So this is one of the most common questions of can I have this feature that I like from other languages? It used to be local variable type inference, but then we did that one and then they stopped asking. And so then the next one that everyone started asking for was string interpolation. And, our answer to that has been, a little bit like, there was one in between, which was multi-line string literals, and then we did text blocks in Java 12. So that people stopped asking for that one too. But the thing that was about text blocks is the thing people were asking for wasn't actually the thing they wanted. People said, I want multi-line string literals, but if you just did multi-line string literals in kind of the obvious way, then they would interact very poorly with your code. Because you go and you indent, you re-indent your code, and then either your string literals are out of line with your code, or you've just added extra spaces into your code, both of which are bad. And what text blocks was we call them two-dimensional string literals because they preserve their relevant indentation. And the reason I go back and tell that little story is, the thing people ask for and the thing people really need are not always the same thing. And so people ask for string interpolation, but we looked at string interpolation in a bunch of other languages, and every one of them had problems that we didn't want to port forward into Java. So some of them have a combinatorial explosion of string literal forms for interpolated or not. Some of them would have been incompatible with our existing string literal form. But the big one that we care about that most other languages haven't approached is, how do you deal with injection attacks? Because the easier it is, the easier you make it to compose something out of a literal data and dynamic data, the more likely you are at risk for SQL injection, cross-site scripting injection attacks, etc. And so we look at string interpolation as a sort of special case of what we call template processing, where a template is a combination of some literal text and some embedded expressions. And then there is an object whose job it is to combine these in a well-defined way. So for interpolation, that well-defined way is really simple. But if you if you want to, for example, construct a SQL query, you want to validate the string to make sure the quotes are balanced. You want to escape any quotes inside the embedded expressions so that you're not at risk for Bobby Tables kind of attacks. And so we built a mechanism that gives you string interpolation and a lot more. And we're deep in the complaining phase of that, right? So people are seeing it. They see their first reaction to it is they see, oh, 4 extra characters, that's terrible, we're all gonna die. And so the comments are full of what an ugly syntax. And we can have this conversation again in a few years, and a lot of those people are going to be saying, wow, this is a really powerful tool. It can do so much more than string interpolation. And it, so we're in the first reactions to the syntax phase, but we'll get past those soon.
Yeah, one of those is, I just put it on screen, that's been brought up a few times, is the / curly brace. Why was that decided instead of the more common $ curly brace?
Yeah, so that's one of the immediate reactions people have of, I've seen something different in another language, and different is bad, so this must be bad, right? So the reason we picked / was the same reason, by the way, Swift did the exact same thing, is that it is a sequence that is not legal in string literals now. So / curly brace is illegal to use in string literals and text blocks. And so we wanted a feature that would work with the string literals we have now. If we use $, then all of the string literals out there that have $, in them now would have to be escaped. And and so that certainly would not be acceptable. And like the escaping rules that other languages use for $ interpolation are even more ad hoc than the escaping rules that we have for for escape sequences. And so we wanted something that fits within the string mechanisms we have, because otherwise, if you take all of the different flavors of string that people have asked for, strings, multi-line strings, single-line strings, strings with raw content, strings with escape content, strings with interpolated content, you get this combinatorial explosion, and some languages have like 8 separate string literal, features. We wanted to have one concept of a string that you could use single line or text block, interpolated or not, and it's one feature. And so, it's a little bit weird. And when people say this is ugly, what they really mean is this is unfamiliar, and unfamiliar things are ugly. And the good news about that is unfamiliar things quickly become familiar things. And so if they're only reacting to the unfamiliarity, they'll have a different opinion in 6 months.
Yeah, no, it's one of those, if we had no backwards compatibility, no existing code base, we could do whatever we want. We could do the $ curly brace, no problem. But, we already have billions, trillions of lines of existing Java code out there. And a lot of them are going to have that $ curly brace in there at some point. And that is going to cause just a bunch of weird errors when people upgrade. And that's not good.
Absolutely, and it's not just it's not just the code out there, although the code out there is important. It's also compatibility with what people have already learned about Java, right? So they've already learned some things about Java that we don't want to invalidate, right? Right now they know that a $ inside a string literal is just a character like ABC, but if we change that, now we're kind of pulling the carpet out from under people. And frankly, even if I was designing this feature from a clean sheet of paper, I still wouldn't use $, because I don't want to have 2 escape mechanisms in my string template, my string literal feature. We already have the / escape mechanism for new lines and such. Why would we have 2 different escape mechanisms with subtly different rules about how do I escape the escape?
Somebody else has also asked something about templates, string templates, or actually more about the template processor. What's your opinion on making JavaSQL connection or similar a template processor?
Yeah, so that's a great question, and this is something that we anticipated in the design of the feature, that we knew that defending against SQL injection was the kind of thing we wanted this feature to support. The question that the that the person is asking here is really an API design question, which is, if you have this language feature, what's the best way to expose it in some sort of kind of SQL API? Do you make the connection a template processor, or maybe the connection gives you a way to get a template processor? And we've been prototyping it both ways, and trying to understand the pros and cons before we settle on a on an API design, but it'll be one of those things. It'll either be that the connection is a processor, or the connection has a processor, or you can wrap a processor around a connection, or something like that.
Thank you. And another one on string templates. We cannot evaluate expressions inside interpolated strings, can we?
Oh, totally. Expressions all the way down. You can have a string template expression where one of the embedded expressions is a string template expression. Now, I'm not saying that that's a good idea or that you should code that way, or the people who have to review your code will like you for it, but go crazy, knock yourself out.
So actually, when I was reading the JEP, there's an example on this one on evaluating expressions, and I was looking at that and I was like, I don't think people will do this, but it's possible.
I hope they don't do it too often, right? And in fact, like one of the things that we discussed when we were designing the feature is, should we limit the kind of expressions that you can put in an embedded context? And, we tried a couple of possibilities, and there was not really a good boundary for where to draw the line. It always felt arbitrary. And so we kind of came to the realization, okay, it's an expression. You can put any expression there. If you, make it really hard to read, then your code's going to be hard to read, and people aren't going to want to look at your code. And, there's a lot of other things in the language like that as well.
True. Okay, let's see if we have any more questions.
Sorry, I was busy responding to some questions in the text. Yeah, someone was mentioning that was hoping to have a single line text blocks, and that's actually already possible. To answer that question, so yeah, if you just have your triple quotes, and then you have to do a return, but then you have your one line and then keep the triple quotes on that same line, that would just be a single line text block.
So currently, text blocks do require you to have a line break, and I remember there was a reason for that, and I'd have to go back to my notes for why we did it that way.
I think it's to differentiate from, or make it so it's clear difference from a single line text block or something like that for the compiler. Maybe
it is possible that there was an ambiguity, but I think the reason was more subtle. But I'd have to go back to my notes for that, because that was 2 or 3 years ago. No, 3 or 4 years ago that we did that.
But while that would be a line break in the code, when it's rendered, there wouldn't be a line break in the
there's no line break. In the rendered text block.
Yeah. So.
And we have another question. This is about data-oriented programming. What's the next name in Ember for data-oriented programming?
Yeah, so the next big feature in that feature arc is the ability to declare a deconstruction pattern for a class that isn't a record. So what we call record patterns are a special case of what we will call deconstruction patterns. And because records, their API can be derived from their state description, we can derive a record pattern automatically from the declaration of a record. But there are plenty of classes out there that would want to be decomposable in the same way, that just can't be records or aren't records, and would want to be able to play that game. And so one of the things that's coming is the ability to declare a deconstruction pattern in a class. And that looks like a new kind of member of the class. It kind of looks like a constructor flipped around in the mirror. So in the body of a constructor, you say things like this.x equals x, this.y equal y, where you're taking the arguments and you're copying it into the state of your object. A deconstruction pattern does that in reverse. It's going to look like x equals this.x, where you're taking state from the object and putting them into the bindings. So once you can explicitly declare a deconstruction pattern for a class, you'll be able to do pattern matching on class instances in switch statements, an instance of expressions and such, and then sort of step after that is once you have a matching constructor and deconstructor, we can do with expressions, we can do we can automate a safer form of serialization, etc. So there's a bunch more coming there.
I think we've gotten a bunch more questions. So I guess this gets it back to the paving the on-ramp with the addition of unnamed classes. Excuse me. But
yeah, it's really. Oh, go ahead. Go ahead, Anna.
It's okay.
Oh, okay. All right, cool. So it's really funny how different people have different ideas of what object-oriented programming is, right? Object-oriented programming shouldn't be a religion. It's a tool. It's a tool for getting things done. It's really good for modeling complex entities. It's like pretty bad for fixing your car. And like for other programming tasks, it can be sort of in the middle, right? And so it's not something you do because someone brought the object-oriented tablets down from the mountain. It's a tool that we use because it helps us manage complexity. And as programmers, we're swimming in complexity, and we need all the tools we can get for managing complexity. But in some domains, it doesn't add a lot of value, and in some cases, it may actually bring its own complexity. So what we want to tell programmers is, use these techniques where they make sense. Don't feel like you have to be a slave to them when they don't make sense. And so, unnamed classes, were they necessary? Were they not necessary? You could argue either way, but, what we looked at was the experience of people writing their first or even just a small Java program. And all of the concepts they were asked to understand before those concepts were giving you any value. Right? If you only have one class in your program, do you need a class declaration? You probably don't. Do you need access control like public and private? No. If there isn't other code that from another maintenance domain that is calling your code, you don't need to think about access control. And asking students to think about access control before they know what a variable is just a recipe for their heads exploding. So we think it makes sense to introduce these concepts when they add value to your program. And if you're in a situation where they add value to your program, then you use them. And if you're not in a situation where they add value to your program, then you shouldn't have to use them.
Yeah, I remember like a couple of years ago kind of thinking through like how I would explain a Hello World program to like a new programmer. And yeah, just kind of what you were saying about having to go explain like, public, class, static. Well, like it's so much. Sorry,
yeah.
I just kind of cut you off there.
No, totally. But like I don't know if you remember the Java 1 keynote probably 4 or 5 years ago, where Amy Lucido, came to talk about her experience like learning to program, and she said like her teacher like had to make up this rap to get people to remember the public static void main, incantation. And like, okay, that's one cool teacher, but really, that's what they have to do?
We have time for one more question. Let me show this one. Is there anything more planned to further improve the dev on-ramp? Perhaps simplifying common I/O patterns like writing, reading from the console, the scanners.
Yeah, there is, but I don't know what the answer is yet. We certainly know that Scanner is an old tool and has a lot of quirks, and the programs that students writing in their early classes do a lot of reading and writing to the console, and they don't want to have to think about Unix file handles like standard in, standard out, and we don't necessarily want them to have to learn the quirks of something like Scanner. So we know something better is needed. There is some, library design activity going on, exploring like what would be a simpler way to do simple console I/O. Maybe we'll have an answer in a few months.
Thank you.
Great. So yeah, we have a couple of minutes left. Is there any last messages you have for the Java community?
So, what we really want to hear from people when we put these features out is people's experience reports of, I tried using this feature in a real program, and here was my experience, good, bad, indifferent, whatever. We're not, we don't want to just hear the good, but, we want to hear feedback that corresponds to real experience writing actual code rather than the sort of more superficial, well, I looked at it on a whiteboard and here's what I thought might happen. It's like, well, we can do that experiment in our heads too, right? But like what we really need to know is, how does this work, with your real code in the real world? Did it solve the problems it was supposed to solve? If it did, great, share that. If it didn't, share that. We can make it better.
Thank you.
Great. Yeah. So yeah, we're always happy for feedback, particularly live fire feedback, I guess you could say. That's what's really helpful.
Thank you for
Thank you,
joining us.
Yeah,
And
thank you. This was fun.
we hope that you come more often.
Yes.
And we do more live streams.
Yeah.
Anytime.
Enjoy your
Awesome.
week. And
All right.
now we have another surprise for you.
Okay, so I don't know a whole lot about car engines, but I do know a bit more about the JVM. And on this episode of Road to JDK 21, we're going to be looking at the changes between JDK 17 and 21, including a big change to the Z garbage collector. With that, let's jump right in. Far too long to cover in this video. It receives considerable attention from the GC team. Generational GDC is arriving with JDK 21. With every release, the engineers that work on the JDK use the opportunity to tweak, refactor, or even rewrite portions of the code base to improve performance. The story from JDK 17 to 21 is no different, with a list of resolved issues in the Java bug system far too long to cover in this video. What does the sum impact of all these changes look like in practice? Well, in this case, it's actually a bit of a mixed bag, particularly if you're coming from JDK 17 and are keeping it up to date, which of course you are doing, right? So to start with the bad news first, it does look like there might be small regressions in footprint and startup. Though, on the other hand, throughput does look a bit better as measured by the Spec JBB 2015 benchmark, with gains between 5 and 15%. For my own testing that I did on my own personal machine, a 2019 MacBook Pro using a simple Spring Boot application, the performance comparisons I mentioned earlier between 17 and 21 track, with a slightly larger footprint and slightly slower startup, though I didn't have a great way to measuring throughput. Hold on, before we go any further, we need to have a discussion about performance. All right, so performance is a somewhat difficult topic to cover, and even more so to do it honestly. To start with, there is no singular concept of performance. When talking about performance, there's three major metrics we're usually concerned with: throughput, latency, and memory footprint. Though there are some other metrics, for example, startup. Further, Java quite famously works across multiple operating systems, write once, run anywhere. While Java will run just fine on Linux, Mac, and Windows, the underlying operating system and even CPU architecture can impact performance. And on top of all of this, how a performance test is designed and executed can dramatically impact results. Providing a large heap probably means less memory pressure and thus less GC activity. How long a test is run would impact how much it benefits from code optimizations provided by the JIT. All this to say, there is no single easy way of describing performance improvements between JDK 17 and 21, so that's often why I provide ranges. All right, so let's get back to the video. Part of the reason the performance improvements are a bit mixed is that a decent amount of the performance fixes have been backported to JDK 17. While the performance improvements might be modest for JDK 21, keep in mind these benefits come for free when upgrading to JDK 21. You don't have to refactor or rewrite your applications to get these performance improvements. And of course, these changes compound, so if you're moving from JDK 11, 8, or before, you will see an even more significant performance improvement. On the subject of upgrading to JDK 21, Nikolai did an episode of Road to JDK 21 on upgrade hurdles. Be sure to check it out. While general performance improvements might be only modest, there are some specific use cases that did see more substantial gains. Crypto, no, not cryptocurrency, but crypto algorithms for encrypting and decrypting data did see some significant performance gains between JDK 17 and 21. Cha-Cha 20 Poly 1305 seeing the biggest benefit with high double-digit to even well into triple-digit improvements depending upon platform and architecture.
There is also significant refactoring done to the Java core libraries classes. Per Meinborg actually published an article about this all the way back in January of 2023, detailing these changes. Primarily, the refactor improved how Java handled primitive value conversions to external representations. The classes most directly benefiting from this would be Object Input Stream, Object Output Stream, Object Stream Class, and Random Access File, which ultimately means serialization has gotten significantly faster. Be sure to check out Per's article if you're interested, link in the description. Unlike some other Java developer advocates, I actually collect my garbage, fix the problem. Which reminds me, we need to talk about garbage collectors. Before we cover changes to the individual garbage collectors, let's first cover a change that impacts all garbage collectors, string deduplication. String deduplication was first introduced with the G1 garbage collector back in JDK 9 with JEP 192. String deduplication was added because about a quarter of the typical Java heap are strings, and about half of those strings are duplicates. In simplest terms, while doing its work, the GC could check if its string is a duplicate value and reassign it towards a single memory address. With JDK 18, this behavior has been ported over to the GGC, parallel, and serial garbage collectors. String deduplication can be enabled with plus use string deduplication. The G1 garbage first garbage collector has been the default garbage collector on Hotspot since JDK 9. As a result, it receives considerable attention from the GC team and has seen several key updates. G1 region size can now be set up to 512 megabytes. Previously, it was 32. This can be helpful for reducing memory fragmentation on applications that work with a lot of large objects. G1 now uses a single mark bitmap instead of two, which can save about 1.5% of heap space. How G1 calculates concurrent refinement has been updated, which should result in improved throughput. As a result of these changes and others over the past 4 releases, there has been a few changes to how to tune G1 GC and JDK 21. For example, the concurrent refinement change means that these VM arguments have been deprecated and are now no-ops, which will produce a warning message and that will likely be removed in the future. Be sure to check out the GC tuning guide for more details on these tuning changes, and also Tomas Langer blog for more details on some of these changes covered in this section, links in the description. So compared to G1 GC and GTC, which we'll cover later, relatively little has changed with the parallel and serial GCs. This is expected as these GCs are, along with being very mature, are also in maintenance mode. The most noteworthy change to the serial and parallel GCs outside of string deduplication is improved CDS support, which should help improve startup performance. Don't know what CDS is? I have a Stack Worker episode on that topic. Last, but definitely not least, is the GGC garbage collector, Java's newest garbage collector. GGC focuses on scalability and low latency, able to support up to 16 terabyte heaps while maintaining sub-millisecond pause times. If you're not yet familiar with GGC but want to learn more, you know what? I have a Stack Worker episode on that topic. GGC actually saw the biggest change we'll be covering in this video, as it's now a generational garbage collector, which is covered in JEP 439. To help cover this topic, I reached out to my colleague, Erik Osterlund.
My name is Erik Osterlund, and I work in the GC team in the Java platform group here at Oracle.
You might be wondering, what is a generational garbage collector? Here, Erik can provide a much better explanation than I can provide.
A generational collector is a collector that's logically splitting the heap into 2 different parts called generations, the young generation and the old generation. The generational hypothesis is basically a commonly observed pattern in Java applications that objects tend to have a short lifetime, and the implication of that is that they tend to die young. The idea is that if you start allocating objects in a young generation and only if they survive long enough for a number of young collections, they move over, we call it promotion, to the old generation. This way, you end up having a lot of garbage in the young generation and a lot less garbage, more live stuff in the old generation. This way, you get a more profitable garbage collection in the young generation, which helps saving memory and CPU due to garbage collection.
Why did GDC make the switch? Why not just stay a single generational garbage collector?
We know from experience that for some workloads, when you have a lot of long-lived objects and high allocation rates, you need generations to keep up. We always knew that from the start, so it was more of a priority question that we try to solve the latency problems first and do that really well, and then think about shipping a generational version that can compete with other collectors in memory and CPU utilization as well in these type of workloads.
Generational GDC is arriving with JDK 21. If you're interested in using it, you will need to set plus use GDC and plus G generational. If you don't set the second JVM arg, then the JVM will default to using single gen GDC. Eventually, the plan is to make generational GDC the default, but exactly when that happens isn't certain yet. We already have received some feedback from customers on generational GDC as well.
We have received some feedback from people using generational GDC that have been very successful doing that in workloads where you do indeed have long-lived objects and high allocation rate. And an example of such a workload is when you have an LRU cache, but still a high allocation rate in the young generation. And it has paid off exceptionally well.
Still, despite the many positives of switching to Gen GDC, I would still recommend setting GC logging and using JFR in profile mode when initially making the switch to Gen GDC to both capture quality data if you do run into any unexpected issues, as well as help to compare performance between other garbage collectors. If you do run into any issues, we'd love to hear from you. So that's it for this episode of Road to JDK 21. JDK 21 is an exciting release, and if you're interested in learning about all the tool changes coming with JDK 21, check back in on Wednesday when Anna will be covering those changes. If you like this video, share it with your friends. If you don't like this video, share it with your enemies. If you have any questions, leave a comment. But until next time, happy coding.
Hey.
Hi. How's my audio?
Great.
Great. Okay. I was a bit nervous there, so.
No worries. Now it's time for our guest that will speak about performance and garbage collectors, Geoffrey de Smet. Welcome, Geoffrey.
Thank you, Anna. Thank you, Billy. So happy to be here.
Yep.
Shall I?
Yes. We'd like to introduce you a little bit. So Geoffrey is the co-founder of Timefold, which is using Java under the hood. And that's why he's invited today. And we want to talk to him about JDK 21 performance and if it's better for what he's working on, and talk about garbage collection as well, and as many things as possible. So Geoffrey, please tell us more about how you're using Java and JDK 21 at Timefold.
So it was very interesting to hear earlier today about virtual threads and how they can really make a big difference for people, for programs that use a lot of blocking. That's when they go to the database or the network is waiting from on the server. Now we have a very different case. We mostly do in-memory computations, and as Jose said in this video, this won't help much for memory, mostly in-memory computation. So for us, virtual threads is not interesting. We're like a little bit the odd duck here in that case. Now we are actually quite excited for Java 21 Because what we always do is every time a new Java version comes out, we test it out and we look at the performance and we compare it with the older versions, and we do a comparison on that. And so we actually did this. So let me just quickly show you. We did a blog post, and we tried how fast is Java 21 on our use cases. Now, maybe just a quick note on exactly what do we do is we solve planning problems. So for example, a vehicle routing problem or an employee shift scheduling problem, we solve that with Java, and it's a lot of calculations. It's only calculations. I'll get back to that in a minute. And what we tried is on multiple use cases, we tried, okay, what is the comparisons of Java 17 versus Java 21? And like I said, we don't do any blocking. So the whole virtual threads, that doesn't make a difference for us. And we did a number of tests with JMH, of course, and we saw that basically on most use cases, we got a significant improvement, sometimes 7%, sometimes 6%, and this is purely from switching from JDK 17 to JDK 21. And in the past, we've seen similar improvements from going from JDK 11 to 17 or from 8 to 11. You can also see there's one use case here in this JMH benchmark where it's actually less performant. This is for conference scheduling. But in fact, these are micro benchmarks where they just test one particular thing in that use case and not the general common use of that use case. So we did some non-micro benchmarks, some macro benchmarks too. And in this, we see actually conference scheduling is in here. And in the general picture, it actually became faster. But your mileage may vary, of course, because there were some changes made by how by default the JDK operates. But in general, we basically see that in pretty much every use case, we get a significant we get a performance benefit. And just to compare the numbers there, so I've just written them down. These are from previous blogs. When we were still called Planner. And if you switch from 8 to 11 and you're doing just CPU computation, you'll see that we noticed in our benchmarks with our use cases across many different use cases that on average we get an improvement of 4.5%. From 11 to 17, that was actually bigger, it was 6.5%. And from 17 to 21, that was actually 20%. Now, I'd just like to stress out that, this is also interesting. This is with Parallel GC because that's our favorite garbage collector. And I'll get back to that in a minute, why we prefer this one over the normal one and why I fully agree that most people will actually prefer G1 for good reasons. But we like the other one. We're a little bit special again, right? But we actually saw from 8 till 11, the jump for G1 was like 20%, if I recall correctly. And that was quite simple because G1 was quite new in 8. And so by 11, it had matured and had made this big jump. You can also see that you can't always keep improving, right? There's apparently you can, but the numbers, there's this law of diminishing returns playing a little bit. But we're happy with every performance we get. And just to give you an idea, this is what we do. We get a planning problem. This is how our hardware, our consumption of the hardware, the I/O, the memory, and the CPU looks like. From an I/O level, we read the problem that is delivered us in like a JSON file or an XML file, or what the case may be, or whatever data store it comes from, or bus or whatever, and then we solve it. Now, reading the problem is a few milliseconds, sometimes almost a second, but solving the problem, actually, we typically solve for 5 minutes, sometimes for 40 minutes. So solving the problem is a very long operation. And we are typically time-bound. That means that we're not solving until we get the best result, because we're solving planning problems, and to solve a planning problem to the optimal result, once you start scaling out, that actually takes millions of years. And we don't want to wait millions of years to send the result back. So we need to do the opposite. We need to say, okay, how much time do you have? Give me whatever time you have. If that's 5 minutes, I'll take 5 minutes. If that's 30 seconds, I'll take that. If that's an hour, I'll take that. And in most cases, we solve during the night, but sometimes a human is actually waiting for the result, and then we're solving during the day. So during the solving, there is no I/O whatsoever. the memory changes a lot, but our usage of memory is actually quite limited. In most use cases, we can, for bigger data, if the data set itself is half a gigabyte, then our solving will also be quite limited. So we put a lot of stress on the garbage collector, but we don't have very long living objects. But then there's CPU usage, and that's where we are like the cookie monster. Right, CPU is cookies for us, and we ate it all up. And literally, like if you have 8 cores and you solve 8 data sets with us, the mouse will start not moving well anymore. We really eat it up. We don't block, and unless the JVM forces us to give another thread some room to play, we will not. We will not give it up with our solver, right? So we have systems, of course, to make sure that we leave some of the CPUs to the other programs to share fairly. We take half, everybody else gets the other half. Sounds fair to us. But anyway, so solver calculations are really time bound for us. And so what does that mean for us? This extra through percentages we saw here. Well, it means that when one of our users, it's an open source library, one of our users, when they run on 8, they get a certain result. But what happens if they switch from 8 to 11, from 11 to 17, from 17 to 21? What if we switch all the way forward to 21? They actually get the sum of all of these numbers. So, and most of the time, they can just switch the JDK and it just runs, right? From 11, we had some problems with one of our dependencies we had to upgrade, but now when we wrote this blog and went to 21, for our core part, for our core solver, we didn't have to change anything whatsoever. So that means most of our users can just switch 17 out for 21, and it doesn't take months to do that, and they can try it out, right? And for us, this is an example of what we get as how much time it takes to get to a certain quality of solution. And this quality of solution is solving planning problems like the vehicle routing problem or employee scheduling, and it directly delivers how well the quality is for the end user. So for example, for employee scheduling, that would mean how happy are the nurses in the hospital. Right? By doing this 5% better, they are, whatever you call this, 5% more happy. 5% more happy might be, you can tell 5% more of the day off requests. You can say, yes, you get them. Day off requests are when a nurse says, I don't want to work on a certain day. We can do that 5% more. So everybody's, whatever you call 5% more happy. So it does matter, this left axis for us. And what we see is if we have a time budget of 2 minutes, then we would get, with the blue algorithm here, we would get this score. But if we then we switch from the JDK, let's say 11 all the way to 21, right? We actually get this for doing nothing on our end, and we love this when we just get free performance, right? We get actually 10% faster, and 10% faster for us means for our end users, it's actually a return on investment for them. It's actually better in the real world. And it's not just about cloud costs here, it's really about delivering better results to the end user. So for us, this is why we're so excited about always jumping up onto the next version, and why we're so excited about Java being so performant. It is, the fastest or one of the fastest programming language in the world, and the JVM, the magic in the JVM is just wonderful there, right? So that's the part about performance.
Thank you, Geoffrey.
Shall I jump a little bit into the garbage collectors?
Yes. So many of the folks that I've talked to are still wondering, like, which is the best garbage collector. And most of the time I get also the option, like, for us, it works good by default. Yeah, we have some problems, but, tuning garbage collectors is something that is considered tough, scary. So why don't you tell us about your experience and how did you get to use Parallel GC?
Yeah. So We are a little bit in the middle, so we don't tune garbage collectors completely. We don't go that far. I understand the feeling like it works, and I don't know all of the settings, and you have a lot of parameters, right? Last time I heard about 50 or so. I could be wrong, right? Yeah, and that's good that you have those configuration by exception, right? That means that you can play with those, and they can change defaults better, and they can give us better defaults, so we don't have to care about them to begin with, right? That's good.
Yeah.
But there's one big setting that does make a big difference for us, and that's the garbage collector. So when going from Java 8 till 11, the default was switched from parallel GC through to G1, and that was actually the best decision, because for most people out there, most cases are web applications going to databases and so forth, where latency is a very big concern. And the parallel GC garbage collector doesn't do well on latency. So here's a very simplified version of it, as what we're seeing, right? Is that this is the default. This is garbage one collector. So if you don't touch anything, you basically get what the baseline in this case.
Mm-hmm.
And if you say, I actually want to get more throughput, then you want to switch to parallel CC, because your throughput will increase, but your latency will decrease. So what will get worse. So what does that mean? Not decrease, but actually increase. But what does that mean? That means with throughput, you can do more calculations per second, right? And for us, like I said before, we are solving for 5 minutes, hogging a CPU, embracing it, and then we want to squeeze everything out of that, right? So throughput is for us king. That's why we love parallel GC. Latency is when you send a request to the server and you want that to be always respond quickly. So you might say, okay, throughput and latency, that's the same. If throughput is better, then latency will be better. That's not really the case. Latency is not about what it does on average. It's what it does in the worst case, right? Or in the worst percentage, right? 0.1% or worst 1% of the cases. And so we don't really care about that if all of a sudden there's a 2 second stop the world garbage collect in the middle of our 5 minute solving. As long as we get more within that 5 minute solving, that's fine for us. But if you send a request to the server and it takes 2 seconds for it to reply, then you have a problem in your UI, right? And when there are people waiting in the UI, right? So
sorry, we do only have about 4 minutes left with you before our next guest. But yeah, I think you bring up a really great point in this, though, that there is no best garbage collector, that there is different garbage collectors for different needs. And yeah, for a lot of Java developers, I think a lot of Java developers are working on web applications. Often the G1 or maybe the ZGC garbage collector makes more sense because there's going to be less latency. And then there's also things you have to consider, like the heap size, because up to about 2 gigabytes, which can work for a lot of people, parallel GC can work really well. But then you start to get much bigger than that. Yeah, you wouldn't want to work on like a 16 gigabyte or a 32 gigabyte heap on parallel. Like even if you're going for throughput, you still probably wouldn't want to use it with parallel, just because you would have like a 2 minute long pause or something in there.
Yeah, definitely. We've seen there. It depends also how much of your data changes, right? So sometimes we pull in a very big data set, like a distance matrix. These can be 2-3 gigabytes, but they don't move for 5 minutes, and that's a very big difference than if you pull in something. If you really use 5 gigabytes of memory, but it constantly changes, right? So, but yeah, definitely. The only problem is, the only way to test this is just to switch GC and try it out.
Yeah,
it's quite easy to do this. It's a single command, and so I would argue for people, you might not want to tune a garbage collector much, but if you care about throughput versus latency, you might want to just try switching it the other one.
This might be something that you can maybe answer. So when it comes to I guess you probably did some testing and tuning for this. So here's a question: what's the best software for reading a heap dump or analyzing the root cause of a memory production and error? So if you have any.
Yeah, there's a few answers for that. So with Visual VM, you can just see how much memory you're using, but that won't help you much with this case. So one thing we really love is Java Flight Recorder, GFR. And you can run this from your ID, for example, IntelliJ, but you have to tell it not to use the default profile, but actually say, okay, you need to collect allocations. And then if you go into Java memory mission control, if you can show that another time, then you can actually see how many allocations something is using. It's maybe not the best answer to track down a memory leak. There's some other interesting tools around that. But we've used this a lot to figure out. Well, we've actually used it for memory leaks too, because you can actually then trace for any allocations where 90% of the allocations come from, and then 10% come down. You can see the branches in there, but it's amazing once you can work with the allocate. It's really hidden in Java memory control. You have like 20 options there. I know just 2 of them, and one of them is allocations, and that one single thing for us has done amazing things to get our solver faster, because we could just see. What's the difference between 2 runs and which is taking so much memory, right?
Yeah, that's great. And unfortunately, I think we have to end it there. But yeah, hopefully we can do a live stream longer on this topic sometime, because I think it's a really interesting topic, and it's also something that we could spend a whole several hours of a live stream really kind of going into this. So yeah, hopefully we'll be able to do that some other time then. But thank you,
Thank you, Geoffrey.
Thank you.
Have a nice
Thanks.
evening. Bye.
Bye.
Thanks.
That was insightful.
Yeah. So,
and now we brought our guest.
Our guest, Mark Reinhold. Maybe a few people in the live stream have heard of him, but Mark is here to talk about the JDK release process.
Hey, Anna. Hey, Billy.
Hey.
Yeah, so we've got a half hour for this. I don't know if we'll fill it. But, if we don't fill it, we can talk about other stuff.
Yeah.
Okay, so you wanted to know about the release process.
Hopefully that's all fresh in memory after today.
I've suppressed it all already. No. Let me see if I can share.
Yeah, we can edit. Just say present and.
Present. Do I want to pick slides? You have no slides. Oh no. Present. Going to share my entire screen? No, I do not want to share my entire screen. Okay.
So folks, we've been saying this in the chat so far, but now is the time for you to ask directly live questions to Mark. He's rare inside, so let's see. Let's take the chance and ask him.
All right. So release process. I can't project my browser here, but I'll describe it briefly, and if you have questions or people in the audience have questions, happy to answer them. So since we do this every 6 months now, right, we have to keep it simple.
Yeah.
So it's kind of, it's as simple as possible, but not simpler. So the basic idea is the mainline development repository is always open. We never close it. And every 6 months, we fork it into a stabilization repository. So that's the beginning of what we call ramp down phase 1. So that's a 6-week period in which there are no new features, no more JEPs, no more smaller enhancements unless you get approval. And we focus bug fixing work on current and targeted bugs from P1 to P3. So if you had a P4 bug sitting around, it's like, well, now it's too late to fix it. It's just not, it's just not going to happen. And the overall theme here is about reducing risk, right? We come into one of these releases, and there's a lot of change for several months, and we gradually need to ramp that down to reduce the risk so that we can ship the GA release on time. And so far, since we switched the 6-month cadence in 2018, we have shipped every 6-month release on time. We want to keep doing that. Okay, so RDP1 is the first level of clamping down on activity. It lasts usually 6 weeks. I think sometimes, depending on how the calendar works out, it might be 7 weeks, but it's usually about 6 weeks, and that's the beginning. After 6 weeks, we go into ramp down phase 2. These names are kind of odd. I think more traditionally, ramp down phase 1 would probably be called feature freeze, and RDP2 would be called code freeze. But for historical reasons, we have these terms, and we've stuck with them. So RDP2 is 3 weeks long, and in RDP2, we only want to fix bugs that are P1 or P2, and only with approval. So the amount of approval you need to get sort of goes higher and higher as we go through this process. So in RDP1, it's still possible to do a small enhancement if it's really well motivated and really low risk. In RDP2, it's basically unheard of to do an enhancement, unless there's like some just horrible design flaw that you really have to fix before the release because it's going to be etched in stone forever or something like that. So after 3 weeks, we get to 3 weeks after RDP2, we get to the initial release candidate. And if we're lucky, and in JDK 21 we were lucky, there was only one release candidate. So the philosophy of release candidates is really important. The idea of a release candidate is you do a build, you take out anything that labels it as an early access release. So if you type java -- version, it no longer says EA. A release candidate is the exact bits that you would be willing to ship if you do not find a P1 bug in the next month and a half, say. So we sorry?
No, continue.
Okay. So we generate the release candidate. From that point on, we will only fix P1 bugs. We encourage broad testing across the ecosystem of the build. Sometimes somebody identifies a P1 bug and we fix it. So there's maybe a second release candidate. I'm pretty sure that since 2018, we've never had a third release candidate, but don't quote me on that. Anyway, so after about 5.5 weeks, we hit the actual GA date, like today, ship the GA release. And in terms of the work that happens for that, there's a lot of stuff happens in the background to get web pages ready, on openjdk.org, on jdk.java.net, on oracle.com, of course. But the bits have actually been, they've been sitting there for 5.5 weeks. So they don't change. And what happens on a day like today is largely about pushing web pages and making sure that all the documentation has been shipped and the Java doc has moved from its early access location to its final location. And there's our amazing release manager Barb O'Connor has this huge wiki page that everybody follows and checks off as they go to make sure everything happens. But one of the cool things about doing this every 6 months is, well, you do it every 6 months. And so you can refine it every 6 months and you don't forget the process. Back when we were doing, 3 or 4 or 5 year releases, every time we'd come up to the tail end of a release, it'd be like, oh yeah, what did we do last time? Did that work okay? Oh yeah, I guess that sort of worked, but it didn't. So let's do it. Let's try it different this time. And then of course you won't be able to rerun the experiment for another 3 or 4 years. So it's really hard to refine your process.
Yeah, it's kind of taking that continuous delivery philosophy of doing the painful thing more often to kind of get that pain or make it less painful.
One thing that
if it hurts, you're not doing it frequently enough.
Yeah.
One thing that I've seen throughout time with all these releases is that the amount of features increases, and it means that the process is becoming easier and easier and somewhat easier once it's repeated every 6 months. And I've seen complaints, people, reminiscing the old process. But I want to say to the people as well that in the beginning, we started with waterfall. I mean, I started development with waterfall, and then we moved to agile, and it wasn't easy. So changes happen, and release process change for the best. And now we get a lot of features delivered every 6 months, and we get to try them and give our feedback, and we have a better communication with the folks that work on them. So overall, kudos. And the process is working really, really great. And we have a question, or we have more questions in the chat. How do you test new features for backward compatibility?
Excellent question. So new features for, well, so how do you test new features? Okay, so I guess this is two questions.
Yeah,
So,
or maybe it's a typo. Maybe it's testing new features for, like making sure they don't break anything. I don't know, but I'll let you answer it the way you want to answer.
Yeah, well, I mean, a new feature hopefully doesn't have any backward compatibility.
Yeah, sure.
Yeah, so it might, depending on whether it's affecting old, it's interacting with old features. So yeah, so testing is really, really important. Inside Oracle, we have a big CI/CD system that's building things all the time. Developers are building on their own machines all the time, and we've got a pretty rigorous test suite with a whole bunch of tiers in it. You can run the tier 1 tests in a small number of minutes. You can run the tier 2 tests in more minutes than that, and so on. And of course, running all the tests takes a long time, and is a thing that we call ATR, all tests run, which we do towards the end of a release. So new features, when they come in, when a new feature comes in, it must come with a set of unit and integration tests. So you can't just pop in a new feature and test it later. That doesn't work. In the very earliest days of Java, yeah, we were guilty of doing that, and it showed. So that's no longer how we work. New features come in with tests. So there's that. As far as compatibility goes, so we've got a large body of unit and integration tests that, of course, we've accumulated over many years, ever since we started doing those, which I think was back in JDK 1.2, 1998 or so. We also have a thing called the JCK, the Java Compatibility Kit, and that's a separate test suite written by a separate team, and the purpose of that test suite is to test for conformance with the Java platform specifications. So the interesting thing about the JCK is it is written by a team that basically has no knowledge of how APIs or language features or VM features were implemented. They get to read the spec, and they only read the spec. And every test they write has to be justified by text in the specification. If you actually look at the tests, they refer to parts of the text. So that's another excellent test for compatibility, both backward and forward. Another big part of testing is testing done outside of Oracle and outside of Red Hat, and testing not done by any contributors to the OpenJDK community, but testing done by developers at large. It's extremely valuable. We've had a lot of good feedback, both from projects that engage closely with us, and also just random developers. They download an early access build, they find something, and they report it, and we go, oh, that's a bug. We better fix it. Thank you very much. So that's another important aspect of the whole story.
And I think it's maybe worth mentioning that JDK 22 EA builds are already available. So if anyone on the live stream wants to help start testing those, we're happy to hear back.
Yep, they've been available for some time.
Yep. Let's see. And I think this might, there's a couple of ways this answer could be approached, but I'll let you decide on how you want to answer this question.
What was the motivation for the shortened LTS cadence of 2 years? There are those who say we should do an LTS every 6 months, but I think that would be overkill. The LTS duration, it's always a balance, right? We need to balance the ability to deliver new features to the more the more slower moving organizations that are just more conservative. They don't want to upgrade their Java install that frequently, but they do want the new features. So it's a balance between how often do organizations like that want to upgrade and how badly do they want the new features. We did 3 years for the first LTS, and first couple LTSs, I guess, and that kind of seemed okay, but our sense was that even the more conservative end users wanted more opportunities to use new features. So we cranked it down to 2. Will we crank it down to 1? Never say never, but I tend to doubt it. The thing about an LTS is that it's a long-term burden for every vendor that chooses to support the LTS release. And remember, these support timelines are measured in 5, 7, 8, even 10 years, sometimes more. So it's a cost for Oracle, it's a cost for Red Hat, it's a cost for Amazon. Whoever signs up to support an LTS release, it's a serious commitment. And if there were an LTS release every year, just think about the staffing and all the machines you'd have to keep around for testing. And oh my gosh, after 10 years, can we even get machines that run that old operating system? Right now, for example, it's sometimes a struggle to find machines to test JDK LTS builds because we still have to run Solaris on Spark hardware, and it's just not a common thing anymore.
Yeah, I imagine that would be a huge. You would keep a lot of developers and support engineers and all that people employed if we were doing LTS releases every year, let alone every 6 months. I mean,
yeah. and then you're sort of maintaining your own computer history museum for all the hardware.
There you go. Yeah.
Well, I'm also thinking about learning. So I think that the current cadence allows you some time to learn, gives you some time to learn and to get acquainted with some features, like not be just given up front a few, like a lot of stuff to learn and then just go and code with them because, well, they're LTS, and so on.
Well, or even better, learn the features in the non-LTS releases as they come out.
True.
Right? And maybe experiment with those features in your code, and then when your organization is ready to go to the LTS, you're all set.
True.
And we've seen plenty of organizations who do that.
Yeah. I think one point I wanted to kind of go back to a little bit earlier and maybe get to some of the questions also later is I think also another great thing. Like I was really excited when I first kind of heard about going to the 6-month release cadence. And you were talking about de-risking, and like there's de-risking on 2 sides. There's one side de-risking for us in that we're getting used to the 6-month release cadence. There's smaller feature changes, so there's less opportunity for breaks involved. But there's also less risk than for Java users that, when JDK 8 came out, like there was I think 81 or something JEPs in it. And then JDK 9 had, I think maybe just over 100 or somewhere close to that. And that's a huge risk profile. There's a lot of opportunities for incompatibilities and breaks involved there. And now, JDK 21 is a fairly big release with, I think it's 15 JEPs. And of course, some of those are really big, like virtual threads. But I think we're seeing that since once people can get over that JDK 8 to 11 hump, that getting from release to release is actually not too difficult. I don't know if you have anything to add to that, but I don't know. I just think that's also a big benefit of that 6-month release cadence is that it's less risky for our users as well.
Yeah, no, definitely having shipping releases that have a relatively smaller amount of change versus the previous release is definitely a big help in terms of reducing risk. While we're here, I will also mention another big change that has enabled the 6-month cadence, and that was the introduction of modules in JDK 9 and the ability, which we finally turned on for real in JDK 16, to strongly encapsulate internals. And yes, this was painful because by the time 9 came around, there were a fair number of popular libraries that had been reaching into the internals of the JDK for many years. But that held us back because we were basically treating all these internal APIs as supported APIs, even though they were never intended to be that. But we didn't want to break people unnecessarily. So in 9, we made the difficult decision that okay, we're gonna put an end to this, and we put an end to it slowly over many releases with lots of warnings. And in 16, finally enabled that. And I think the ability to refactor at will the internals of the JDK has been an important part of supporting the rapid cadence and the delivery of all these features.
Actually, I think a pretty good question as well, pretty related to what we were just talking about, and also with the module system. How has the reception been from major frameworks and tooling? Like, have you noticed a change over time? Because I think I remember when this was first talked about, at least I know a couple of people are a bit concerned. Has the reception become better over time, or?
Sorry, the reception of what are we talking about?
I think the
6-month
cadence.
cadence.
Yeah.
You know, like anything building on top of the JDK, I think that there are frameworks and tools that whose maintainers pay attention, and then there are those who don't. And those that have paid attention, I think, have seen the benefit. I think to name a couple of names, in IntelliJ and the IDEA product, they've paid attention from the beginning. They've contributed lots of bug reports over the years, even the occasional fix, which is great. And IntelliJ, you'll find pretty rapidly supports every release, even the non-LTS ones. Another framework that's worth calling out is the Spring project. They've engaged and they're on top of it, and they're shipping on latest or the nearly latest all the time. They're doing lots of really early testing and giving us feedback. So yeah, there are tools and frameworks out there that are struggling, but for whatever reason, they've either chosen not to invest, or they can't afford to invest, or they're just not being maintained anymore. And well, it would be a problem whether we have the rapid cadence or not. It just might not be as apparent because the cadence would be slower, and you would only notice that some framework or tool was out of date every 3 years instead of every 6 months.
Yeah. So now, since every organization is scrambling to say AI is part of their feature offerings, is there a OpenJDK GGPT as part of the release tools, or do we have any AI in the release tools?
I certainly hope not. Or let me put it more strongly: over my dead body. No, AI tools have their uses, but running a release process, I don't see as one of them. I wouldn't even say that generating code for a code base such as the JDK, that is the foundation of so many complex systems all over the world, run by large businesses, small businesses, other kinds of organizations. You really want ChatGPT generating code for it?
Well, some people like its code.
There's no accounting for taste.
It's true, but I know why. Why some of my friends like it, and why it may be helpful in some cases, but in other cases can be producing confusions. Another question that we have is related to plans of splitting Java base into smaller modules.
No.
Nope. This feels like there's some scars here. But
well, yeah. So when we introduced modules, obviously a big part of that project was designing the extension to the language and the virtual machine and all of that. But another part, and probably the bigger part, was figuring out how to take that spaghetti bowl that we started with of the massive monolithic JDK that we had, that had sort of accreted over almost a couple of decades, and splitting it up. There are a couple of slides I like to show that are basically the before and after picture. If you look up, one of my old DevOps Belgium keynotes, you can probably find it. And we start with big bowl of spaghetti, and then we finish up with the module diagram that we shipped in 9, and which hasn't changed much since. It was an extraordinary effort to get to that module graph, and that's I'll call out that it was basically due to the heroic efforts of Alan Bateman and Mandy Chung in the Oracle Java team. Lots of analysis, lots of corpus analyses to figure out what could we break if we needed to break things. It was hugely difficult. I think it turned out pretty well, and I think splitting Java.base into smaller modules, it's an attractive idea. We tried really hard. If someone else would like to have a go, would like to go for it, be my guest. But I just don't think it's practical, And this is one of those things. If the Java team had the bandwidth and the foresight in 1997 to say, maybe the platform should be modular and we should have modules for applications and all that, then Java base now would actually be, a quarter or a fifth or an eighth of its size. But it's not the platform that we have, and to get there would just break so much existing code.
Yeah,
I don't see
you brought back a bit of PTSD from talking about that spaghetti of the module graph, because I was also remembering I was putting together some presentations on JDK 9, and I remember I was traveling at the time, and then there was a big concern with whether or not modules was going to be part of JDK 9 or not. And while my freak out was pretty small compared to, I'm sure, what was going on inside, I was just thinking like, oh no, what is my presentation going to be in a week after I get back from this vacation if the module system was gone?
No, it made it finally.
Yeah, it did. And like I said, it's been a big part of what's allowed this 6-month release cadence, and it's also been a big part of what has allowed all the additions, like with Project Amber and all the JEFs, that we kind of started to see this more rapid pace of progress. So,
and certainly things like the implementation of Loom, refactored tons of internal code, and that would have been much harder, if not impossible, if we had to. If we had to preserve internal APIs.
Yeah.
There's another question that somebody posted. Well, hopefully you have an answer for this one, but it's more like a wishful thinking.
More insight into the debates of the architects in their own process. Well, we all get into a dark room, we light up our cigars, we drink a and,
okay.
Brian deals the poker deck. No.
Lol.
It's
didn't expect that.
I'm just riffing here. It's there's no one process. I think each of us architects works a little bit differently. Obviously, we all work together as well, but maybe a surprising amount of what we do is, especially towards the beginning of a project, is just kind of quiet contemplation on our own, doing a bunch of research into, well, how has this problem been solved in other platforms? How has it been explored in academia? Often there are lots of good ideas in academic papers, and just a lot of careful thinking and writing to figure out, to just flesh out the problem statement, to explore, outline some alternatives that you want to investigate, and then investigate those, and then you start working with some other people to flesh things out, maybe do some prototypes, and eventually you get a whole project going. It takes a while, on our big projects. It's typically a period of several years, but I'm sorry, but it's hard to characterize the process. The debates, I'm happy to say, are always calm and professional. Well, maybe a little bit heated, but professional and respectful. So that's all good.
A decent amount also happens on the mailing list, right? Yeah, there we go.
I was going to say that most of the conversations that you have transparent access to what was discussed and how people reached to that conclusion, and that decision regarding a certain feature is not just taken out of nowhere.
It is not just taken out of nowhere, and once a project is being developed and evolved publicly, of course, a large part of the architect's time is taken up in answering questions, in defending the design, taking in feedback, sometimes changing the design, sometimes massively in response to feedback. So feedback is great, and sometimes the public debate can get heated, and that's unfortunate, but we we try to remain as professional as we can, even though others might.
Just means we have a passionate user base.
Yes, we do. And that's a good thing.
Yeah.
Yeah, but there's also code of conduct that you kind of adhere when you participate in these debates, and we're all much like adult people and have to know how to behave in public because, by the way, those lists are really public and everybody can see.
They're public and they're archived.
Yes, they're archived and everybody can see what someone wrote.
Yeah.
And do we have time for another question, Billy, or is?
We might. We are currently waiting on our next guest to get onto the stream, so I guess we have an extra minute. See, we've already went 30 minutes on the release process, and here you were.
Who knew?
Who knew?
Well, whatever. I'll talk about anything.
Yeah.
Okay, so somebody asked about JDK 17 can take a noteworthy CVE around ECDSA signatures. Not all vendors. Remember. Yeah, this is more security thing.
Yeah, I don't remember that particular CV off the top of my head. Not all vendors had builds available when the CV was disclosed, as this led changes in the release process. So that question seems to assume that there's one release process followed by all the vendors, and that's not true. Each vendor has its own release process. There is an organization, a group in the OpenJDK community called the Vulnerability Group that coordinates fixes to things like CVEs and other security issues. So any vendor participating in that, every vendor gets access to CVE information and fixes for such issues at the same time. And then it's the vendor's responsibility to actually get that fix into an appropriate build. And the build that they get it into, it might be their 1704 instead of the 1703 that some other vendor managed to get it into. It's all up to the vendor. So you really need to communicate with your vendor if you want to understand which CVEs were fixed in which build.
Yes, I've also noticed this, like people are reporting to me issues with a certain release that something didn't happen. And they mentioned the release, and I was like, "Are you sure it's OpenJDK?" Like, "Oh, I have this from X vendor." Oh, okay, then maybe there's a different story there.
Contact that vendor.
The vendor.
Yeah.
Yeah, but people kind of make the associations, general associations. OpenJDK means anything from any JDK from any vendor can be.
Yeah. And at a high level, that's perfectly understandable.
Well, thank you, Mark. This was really insightful, and we hope to have you more with us. I hope to stream more, actually, and have you more with us. Okay. Speaking about OpenJDK and many other, and Helidon.
Yep.
And yes, wishing you a great evening. And
you too.
To many more peaceful release processes. Bye.
Yes, every 6 months. Thanks.
Bye. Yes.
Bye.
All right. Thank you, Mark. Bye.
Thanks. And now it's time for the community to join the fun.
Yes.
And we're going to start our tour with the first JUG, Paris JUG. Welcome Paris JUG. Oh, wow.
Oh, wait, oops.
Hi. Hello.
Bonsoir.
So we are here in Paris with Rémi Forax. Hello. And
Hi.
Some of the attendees presenting a meeting on Java 21, the launch.
Great. So we have some echo going through. So we'll mute.
Oh, we are mute?
So
okay.
Either you mute us.
Yeah, I muted them. So there's a lot of echo happening. So I think if you guys are gonna do some talking, we'll mute on our side just to make sure there's not a bunch of echo. Yeah. So and there's a bit of a pause. Okay. I'm heading over to you guys.
So that's a rerun. Go ahead. So we are tonight for a great night on the launch for Java 21 and presentation by Remy Forax, Java champion. And well, most of the people of the community, a lot of people from the community. And thank you very much for joining us now.
What? This is gonna be fun. What features did Remy talk to you about, and what were his favorites?
Oops. Oh, don't.
No, pas ça? Okay.
In English.
Yeah.
Small.
I would say it would be the right one to
but-
speak about the feature I already talked, but she talked about Siltar and auto class. What was the name? Unnamed class. Switch on object. Moving away from polymorphism.
String template or processor, maybe more.
Yes. Swing interpretation.
Well, that's all.
That's all for now, but we have another hour of meeting for other presentation. So.
Thank you. That sounds cool. I love the part with like in English. Strongly said. It was really. I was going to say that I'm okay with French, but then I remembered, well, we're live streamed. So that sounds really cool. A lot of language features were introduced to you by Remy. And any feature in particular that excites you from all the ones that were presented?
So someone wants to do a testimony?
Perhaps we can vote on the best feature. Let's start. First, it's we cover pattern matching. Raise your hand for pattern matching. Yeah, half. The second one was yes, with pattern matching.
Okay.
Unnamed class. Yeah, we start with a named class and the main, the instance main method.
All right.
Yeah, that's.
Yeah, I was surprised. I was not one of the pro for this thing, but it seems that we have a lot of people that are interested in that, you know. So.
Yeah, perhaps a lot of teachers or a lot of people want to write scripts.
Yeah, it's
wanted
to get rid of Python.
Yes, get rid of Python. And what was next one? It was string interpolation.
I cheat. I can cheat.
Yeah.
And what's the next feature you're going to present?
The next feature I will. Yeah, but I haven't presented it yet. But it's mostly some API features, sequenced collection will be the next presentation. After drinking.
Yeah, we.
I mean, French and wine and stuff like that.
Yeah, we're gonna go for wine and stuff like that. So prepare the Chateau. All right.
You have one question about pattern matching. Let's go for it.
Stand up, stand up, stand up. Assume.
I'm really interested about compiler feedback. Like, if I missed a case, is the compiler able to explain which case I missed? Because I think after pattern matching, it's a great feature to have confident feedback from the compiler.
Okay. So you have to repeat.
Yes, I have to repeat the question. The question is, when you have a switch on object, when you miss one case, is the compiler able to explain exactly what is the problem and how to fix it? And my answer is currently it works for some, but it's not fully finished.
So we have a lot of feedback, but it's still in produce.
One problem is the problem with is that when you have you are missing too much cases, what you should do in that case. If you miss one, it's easy for the compiler to say this one is missing. If you have more than one which is missing, it's harder. So currently, if you take a look for the compiler, if you are missing one case, you will have an error message which say this case is missing. But if you have more than one, I think we can do a better job in this. Ok.
Retire le micro. Non, tu veux pas.
Okay. So you haven't discussed virtual threads tonight?
What we have...
So not yet, and actually, I don't know if it's in your preview, but we have a full day about that in the forthcoming Paris JUG session.
Anyway, I will still present it, but I have covered most of the language feature, and I will switch to the API.
And to be honest, we also want to be sure that people will stay after the buffet. So we put the virtual thread at the end.
Yes.
So
I'm not sure you're here. So basically, we keep this for after the buffet, so people stay. Does anyone wants to do a testimony? Quelqu'un veut témoigner? Je ferai la traduction à la...
en live.
En live, c'est toujours rigolo. Jérôme? Can?
Let me ask if anybody is developing on 21
On
or did
21 or did
anybody try the 21 early access builds?
Good question. Est-ce qu'il y a quelqu'un dans la salle qui a déjà développé des choses sur 21? Ah, on a quelques personnes. Donc, effectivement, on a une personne qui a... there is a guy that have a sample request to patch some open source project to be, I think, virtual thread enabled. No? Oh, okay. So the pattern matching. Okay. But yeah. Perhaps we will leave you and
What is the next JUG you're gonna call now?
We're going to go to the Karlsruhe JUG after the meeting with you, where we have Nikolai and with a guest. And then we're going to have more guests, and then we're going to end. But one last question for you. How many of you will try JDK 21 after tonight?
Pour tester Java 21.
Après ce soir.
That's pretty cool. That's pretty cool. The sooner you try it, the sooner you get into production with it. Okay. Also, you have some greetings from the Paraguayan JUG to everybody, I think, and also to you. Reading from our chat, and for the people that are all around the world watching us. Thank you very much for joining us. It was great to have you here and to see how many folks have joined you tonight for a great talk. And looking forward to hearing about more events from the Paris JUG. Thanks.
Bye.
Thanks. Au revoir. Bonne soirée. That was a little bit tough to handle, given the audio. That you're on mute, or you're not connected to something.
There we go. Sorry. That is the fun and the chaos of doing things live with live streams, especially when live streaming to a whole group. So sorry about that, and I was to bring my cats. They are currently hiding right now, or not maybe hiding, but they're probably like way over on this other side of my place. So I'll try to see if I can wrangle them here at some point.
They're trying JDK 21, huh?
They are trying JDK 21, exactly. So yeah, but yeah, that is definitely, of course, one thing to be interested in. You know, JDK 21 has been released, so it's absolutely available to be out there to hopefully a lot of people are interested in switching to it. Let's see, let's check through the logs, this artist chat, to see if there's any
questions?
Any questions.
Well, some people were still complaining about null pointer exceptions. But the thing is that, I mean, null pointer exceptions sometimes are unavoidable, but luckily the way that you get an explanation of why that null pointer exception happened and the stack trace you get, it's much readable nowadays than it used to be in the beginning. Yeah. So that's an improvement that has been with Java for a lot of time. It's not come just new to 21. Another thing that I want to stress out, because I saw a lot of comments about virtual threads, excitement about virtual threads, which is indeed a great deal of improvement, is that virtual threads will most probably be present within the frameworks that we're working with. And a lot of frameworks already adopted virtual threads. So not necessarily adopted, but looked into that and prepared themselves for working with virtual threads and have reported improvements and ways of working with that. So folks that work with Spring or with Quarkus, they can find information on how these teams have looked into updating their code bases, besides the Helidon folks that we had on that already are prepared for the future and are working with virtual threads under the hood for NEMA. And seeing improvements on that matter as well. So I pretty much love that the community has prepared itself, and the frameworks that we're working in our daily basis are prepared to embrace virtual threads in their processes as well.
So actually, I think something we can cover while we bridge the gap till Karlsruhe JUG is ready is there is some questions that was earlier in the chats I started that weren't maybe necessarily topics of the live stream, but we can go ahead and cover them now. So one question is asking if there's a plan for providing a GPU programming model. And the answer to that is actually yes, there is a plan around that. I'll add that. I'm sorry about that. But yes, Project Babylon was just announced earlier this month. And it is about adding a programming model that would actually better support GPUs. And I think a lot of this is because of advances from like both Project Panama and then also Project Valhalla that will actually enable a lot of this to happen. So let me hide my screen again. Sorry, my laptop is dying, so I'm kind of down to only one monitor because it is just like slowly ticking down by like percent. Yeah, just only using a single screen. But yeah, I don't know if you had anything to add to that, Anna.
No, I've also saw that question, and I was thinking about Babylon.
Yeah.
But thank you for spotting that, because it kind of went into the sea of comments that keep coming.
Yeah. Yeah.
There's also a question about what's up with Project Valhalla. Value classes will be nice.
Is that the top?
No, it's one of the last ones.
Yeah. Okay. There. Perfect. Thank you. Yeah. Go ahead.
So regarding Valhalla, everybody's waiting for it. Of course, there's a lot of, let's say, things prepared in the background, and we're looking forward to it. But I don't have a timeline for that. However, we're all looking into that. And as you said, Valhalla kind of goes hand in hand with the changes that happened with Panama and also with what's going on right now with Loom. So all these three projects come together to give us a better world. But keep an eye on the project and on the discussions that are going on there, because there are a lot of discussions happening. And as active as it is, a mailing list kind of gives you an idea of what's going on with the project. If something is silent, then that's not good.
Yeah. Actually, on the subject of Valhalla, Dan Smith did an update on it at the JVML or the JVM Language Summit, which was back in August. And so we have all those videos now posted on our channel. I'll try to get that posted up here in a couple of moments.
JVMLS playlist.
Into the live chat. But that will give you a current update on that. Unfortunately, in the scramble for JDK 21, I haven't had a chance to watch that video yet. But I do know, Project Valhalla has been kind of on that back burner for a long time. Or not, I shouldn't say back burner, but it's been developing for a long time. And it's kind of like Project Loom, where it's going to have a pretty profound change to it. So it's just not necessarily something that could be like Project Amber, where you can easily deliver it into small increments over time. And because also Project Amber is just kind of adding new things too as well, it's a little bit easier to have a continual update to it. Whereas Valhalla, that's going to be changing, that's adding value types, that's adding primitive types, that's going to really be changing a lot of the memory model. So it's going to be kind of like how I think Jose mentioned when talking about virtual threads and Project Loom earlier. It's going to be a huge, massive pull request also, I'm sure. So that's just what's taking a while.
True.
Let
me see.
Okay, so here, how are value classes different from records? So the biggest difference is that value classes won't have identity. So like a record class would still have identity to it. So like, let's say, you created two instances of a person, and it's both Billy Corando or something. Like that would be two instances in the memory heap, and they would have two different identities with them. Whereas if it's just a value class, there wouldn't be identity, and it'd be like, you don't have like the number 100 as an integer is not stored in two locations in the memory because they're completely interchangeable. And so we're planning on making that value classes expanded to something like, maybe my name wasn't a good example, but like dates or something, where it wouldn't really make sense to have two instances of September 19th as a date in your system because they're completely interchangeable. So that is some of the benefits that come from value classes.
Another question in the chat. Are you going to fill your cup in the video with actual coffee?
I was just looking at that. I don't know what you're talking about. It's completely full. People keep bringing this up, and
you're drinking a special kind of coffee.
A very special. Hey, have you guys everyone seen Hook with Robin Williams, where you use your imagination, like the Lost Boys are using their imagination to eat food? That's what's happening. I'm using my imagination to be drinking coffee in those videos, and so to me, it's full of coffee.
That's how you get to drink less coffee.
Yeah.
So yeah.
Yeah. Let's see. So a question is, can we do manual memory allocation, or is that already possible with earlier versions? So yeah, that's a Project Panama question. I guess that's with the foreign function memory API. And yeah, I think that's you can do. Project Panama is definitely like not an area I'm good with at all, just because like my background is as a web developer, and so I've never really had to work with native libraries. I don't know if Anna, if you have a better answer.
Well, I just played a bit with Panama, but I haven't, done anything very much in depth. I pretty much did the usual stuff, like because I knew how to work with GNI in the past, and I was like looking into, the transformations and how you work with it from the, like much more pleasant way of working with native libraries than GNI. But not much in regards with memory allocation. But on Inside Java, I think there are quite a few articles on Panama and on performance that you can look into. So if you are looking for information about performance or information about how projects are doing or what is new about the projects or what research has been conducted by different folks, you can check Inside Java by the tag of the project. So there's a tag for Panama, there's a tag for Loom, for Helidon. So you can find, I think, the latest news aggregated there together. And the videos as well, like talks that relate to that specific topic are aggregated there. So you don't need to like spend a lot of time researching on your own on sources of information. And those are reliable sources of information. It's not just something that was pulled out of the blue and shared on Google. Are from experts and people that really took the time to investigate that and to make a thorough research. And a lot of those papers are really good.
Yeah. So yeah, here's a question. I think we can take. So probably Project Valhalla is going to be the biggest thing, kind of on the somewhat horizon. But I think maybe each of us could kind of maybe give an answer to what we think is like our most exciting, what feature we're most excited about. I'll let you go first,
well, I'm
Anna.
actually keeping a closer eye on Helidon, as it promises faster startup, faster time to peak performance, and low memory footprint. So those three for me, as I've been working with Java and containers for a while, are like the dream come true that comes directly within the JDK. And I've seen that the Helidon mailing list has been very active. I think it's been very active since January. Most of the time, a lot of conversations going on there, a lot of folks proposing things, a lot of prototypes. And recently, also in the JVMLS playlist, Mark Reinhold gave a talk on Helidon at JVMLS that you can watch as well. And that one, it does contain something that us developers can relate. There is a case study done on a Spring Boot application. And if you're going to the Project Helidon landing page, you can find the slides, and you can find also the slides that detail more about the project that was tried with Helidon and how were the results in that case. So look at that if you want to be convinced that Helidon is the next cool thing in Java. And yeah, I think that from my point of view, it's Helidon, but that's just me.
Yeah. For me, I'm pretty excited by the paving the on-ramp features. So we had Brian Goetz on just a little bit earlier, and actually it was almost exactly a year ago, or it was exactly a year ago, where he published an article called Paving the On-Ramp, and it was all about kind of laying out how to make Java more easier and more approachable to learn. So like right now, still right now, as far as what final features is concerned, the minimum program for Java is the public static void main hello world. And like it's introducing a whole lot of concepts all at once to new developers. And because of that, that was kind of slowly having an impact on Java being as a first choice for a language to learn for new developers. And so since that, we are trying to work on improving that. So we first saw that with a couple of JEPs here, or actually just one JEP here in JDK 21 that's a preview feature. I think it's 445 that's unnamed classes and methods. That is about improving the process for learning Java. But one of the other nice and interesting benefits of that is it's also really improving the scripting and small utility programming story for Java, something that I've actually started to use a bit more of now since becoming a DevRel. So that's pretty interesting. So luckily, I don't have to keep stalling too much. CloudWorld JUG is here with Nikolai and Boris.
Hi, can you hear me, guys?
There's no echo.
Yes.
We can hear you, and there's no echo, so
Yes.
it's not going to be super
Because
awkward.
of the earplugs. Okay,
Yes.
good. So I take these
Fantastic.
off, and I'll sit down over there, and then I cannot hear you, but
Oh.
I can see my screen. So if you want to communicate with me, wave frantically.
Okay. Are you sure you don't want to have an earplug?
Shouldn't we make
Too
you like
late.
full screen because you're going to talk to
Okay.
your guest?
So do we get a full screen? No, we're not important enough for a full screen.
Wait, hold on. How do I make him full?
Great. Okay, there we are. Hi. So there's the camera. Nice. Okay. So hi. First of all, excuse a slight delay. I think we're somewhat on time. We just had a talk
Is
about
this-
Java 21 and cool new features. It was only an hour long, so we only spoke about like half of it. And I'm here to talk to Boris, who's a good friend of mine. I was a former colleague we're at Dizzy, where I used to work. And so before we get into that and talk about Java 21, maybe it's good to know. Oh, wait, maybe I should turn your mic too. Look at this. All right, wait, we're getting there, hopefully. Give me a sec. There we go. Okay. And does it connect? Yes. Okay. Okay. Good. Before we get there, maybe you can let us know a little bit about the project that we're going to talk about, because Java 21 does not live in a vacuum. We're talking about a specific project you're building on that, right?
Sure. So at Dizzy, we built a large software project. It's a web application built in Java, and it's about 2.1 million lines of Java code, and we're targeting business intelligence, location intelligence markets. So doing analytics on data, analyzing and visualizing that data in a web application.
Okay. So clearly you have a web app, but then you're also doing data crunching. So you also have like lots of just CPU time on a server, or?
We have all kinds of things. We do a lot of visualization and a lot of sort of aggregation of data, really.
Yeah.
So yeah, we do have crunching of data. We do have rendering of images. We have generating of reports. We have normal user input. It's a big mix of things that we do.
Yeah, interesting. So I remember when it was 1.5 million lines of code.
Yeah, it's growing at an alarming rate, I would say.
Wait, I thought every line of code is an important product.
No. You have to reduce it. Yeah.
Okay, good. So, and that is running on which Java version at the moment?
Java 17. So we do try to stay up to date, and we try to stay on those versions that we can get a little bit of longer support for. So
yeah,
we're on 17 now, but we are planning to go to 21 as soon as we branch for our new release, which is in a few weeks. We're going to branch off and prepare a new release, and then for the main line, we're actually planning to transition to Java 21 as soon as possible.
Yeah, that makes sense, though, right? Like if you do a release soon, I wouldn't rush 21 out either. I think
exactly.
That's it for a couple of weeks, and then branch early, and then you can play with all the good new stuff.
That's the idea, and all the developers, a few of them were here today, are already waiting for trying to get their hands on the new features. So it's gonna be cool.
Yeah, I noticed some of the questions seem very specific. Like, okay, so
Yes.
Nikolai, if I want to do this specifically, what is going to happen?
Yeah, there's a lot of enthusiasm. Actually, people have been preparing, have been thinking about what features do we want to use, how do we want to use them. I've actually seen some annotations in the code, some comments saying like, in the future when we have 21, do this. So people are working on that.
Well, that's great. So what is one of the few features that you or the other developers look forward to the most?
So one of them that I wanted to mention that have annotations. So people actually started writing switch expression annotations in our code base that they wanted to say, we could do a switch expression here, but it's a visitor pattern, or it's a matching we have to do on patterns. We have to use sealed interfaces. We want to replace visitors. You talked about that today, and we have a lot of visitors in our code base, and we want to tackle those. And people have been annotating places where they think, like, in the future we can do this, and we can actually replace this with native Java code and do this in a saner way, so to say.
Yeah, nice. Yeah, so I gotta say, like, if you've watched my content, you know that I'm not talking positively about the visitor pattern, but I have to say, it's the best solution for this situation. It's not like the visitor pattern sucks. It's a good solution to a real problem. it just now is a better solution for
It's extremely cumbersome. I mean, there's a lot of code. It is hard to understand. A lot of new developers often have a problem with that. They don't understand.
Yeah, I
the
remember that. That
concepts.
was like, it's weird, just like this back and forth. Yeah.
So that's going to be great. That's one small use case I think that's important for us, and we're going to focus on that. But that's fun for the developers. I think the one that's going to bring a lot of, or I hope is going to bring a lot of real benefits also for our customers is going to be virtual threads.
Yeah. I mean, you said you have a web app, so that's a concern that you have, like how many threads and
Okay. And we do have that. So like you have the standard web application thread pool where you say like every request is a thread and that runs out at some point. But what we also have, I think with many applications have, is a ton of thread pools. Like we have executor services, we have thread pools that are for different things like map rendering, for accessing geo services where we get geo data. We have them for processing, for initializing the application. And all these things need to be tuned separately. So we have, I think, about, I don't know how many monitoring metrics, but we have a ton of monitoring metrics on all kinds of worker queues and all kinds of thread pools where we custom manage that. And it's very hard to identify, like, how big should this one be? How much should we give this one? How big does that one have to be? And it's very hard to tune that and to get a good feeling for that.
Okay, but it's interesting because what you describe, at least, like, so we are making this distinction earlier in this talk, and also it's, for those of you who haven't been there earlier, generally when we talk about virtual threads, there's a distinction between, throughput-oriented, concurrency situations and latency-oriented parallelism situations. But some of what you described seems to be actual parallelism. Yes, like map rendering, isn't that something that you would actually like parallelize? Like, let's put 16 threads on this so the map is done earlier?
You gave us a good warning that if you're thinking about parallelism and concurrency, it seems like a good paradigm to think about this problem. And we do a little bit of the classical, let's calculate something in small bits and try to optimize that. That's not where virtual threads will be coming, but a lot of the stuff we do is waiting for network requests. We wait for database requests. I have just heard file I/O. I didn't know that we have to be a bit careful about file I/O.
Yeah, unfortunately, for the time being, right. Yeah, so file I/O is at the moment not entirely, let's say, virtual threadalized.
Yeah.
So at the moment, you will get a growing carrier thread pool, which is fine if that's like an occasional operation.
Sure.
But if you do a lot of that, then you will notice that scalability will suffer from that. It will never get worse, but it might not get as much better as you would hope.
So that would be interesting if this I/O U-ring stuff that you mentioned on Linux comes in, that this also becomes more performant, because what we do is we have these world like caches, like maps. If you see them in a map like Google Maps or other applications, they are usually built up of small tiles, like small little images. And we cache those on disk because many requests come in from many different clients that want to see the same area of the map, maybe a slightly different part of it, but you can just cache those little tiles and they are on disk in a cache. And so that would be a very interesting use case for us, because we try to assemble a big map view from all these little tiles that are stored on disk, and we need to access those. So that could be one of those approaches where virtual threads would be useful, and where maybe we need to wait or at least hope that the I/O U-ring support.
Yeah, that's a good point. So you don't run Windows servers, I take it.
I have to admit, we do have some customers that run. Yeah, we do actually.
I'm sorry that I had to put you on the spot.
I know. No, but I mean, most of the customers are like Docker containers inside on Linux servers, so that's our big use case. And the way I understood it, I'm not sure if I understood that correctly, but I think if you could write the code in a way that is virtual, that will want to use virtual threads, at least in the case where the threads get pinned or we don't get the full benefit, and at least it's not worse than it used to be before.
Right. So that's definitely my understanding. I hope that it pans out. So again, like there's some minimal overhead. So maybe that would be like in the possible absolute worst case where you would fall back, where every virtual thread would get captured would capture a carrier thread, and you just end up with platform threads. And instead of 10,000 platform threads, I have 10,000 virtual threads on 10,000 carrier threads. So in that specific scenario, you could lose maybe 1% or something. Yeah. But that's a very extreme case, right? Yeah. So overall, I think this, as soon as you have some space where you can benefit from the virtualization, I'm pretty confident that that will make up for this minimal overhead somewhere. Yeah. But yeah, you might run into, it's also generally interesting about optimizations. You remove one bottleneck, it might be great. That bottleneck is now 10x. Yeah, but the next bottleneck might be like 5% later, and you get basically nothing because you run to the next thing that you can't fix.
Yeah. So we're going to have to measure and we're going to have to look, but I think it's exciting that we have this ability now.
Yeah.
Because you also mentioned about completable futures and trying to do like other kinds of async quasi coding, and it's very hard. It's harder. I mean, it's harder to understand. And what I find really convincing and very exciting that is the same old paradigm that we used to know, but we get under the hood, it's completely different, and it could be quite a bit more performant. So that's quite exciting.
Yeah. So one example for that I ran into, not a reactive expert at all, but also with computable futures, you can't forget error handling. Like if something throws an exception, you cannot forget that error. Like the compiler will tell you. But if you have a computable future chain, something throws somewhere, you can't forget to actually check.
Yeah.
And so yeah, that's why it's just a small example, I think, for how Java's concept is you do things like this, and all the way through, from like the beginning to the end of the problem, you run through one thread, maybe you spawn a little here and there, but overall it's one big thing, and it's not cut into small pieces that get then put into a background thread pool who does not know how to handle your errors.
Yeah.
So you said you wanted to, or you will do the fork.
Yes,
right?
We're branching quite soon. And what we are actually doing before the branching is we've been running this since, I don't know how many versions of Java, but many versions. We try to keep one build running on the latest Java version. So we're running on 20. We have one build running on 20 just to test if everything's working.
What do you mean latest is 22 EA?
I'm sorry. I mean the latest before the version that we're going to switch to. And it was really cool. Like,
we'll make it better. We'll improve that.
Yeah, let's see. But actually, yesterday we found a problem that maybe not so obvious. That I can only recommend doing that because we ran into a Maven plugin that was using a dependency, which was it was doing an enforcer rule. So it was trying to check our source code for certain static analysis. We're trying to check like, hey, if we're doing that, let's not do that. And it was using a library that was parsing Java source code. Java parser, I think, was the library. I'm not sure which one it was exactly. And it actually didn't support certain language statements that we had. And so somebody was trying to do a switch expression suddenly in a certain place that was being checked. And this library wasn't quasi familiar with it. And then suddenly we saw that quasi in that place there. So these kind of things can kick up all kinds of errors. So we sometimes find problems in our code. We find problems in the build tools and all kinds of different levels. So
yeah, I think that's very important. That's what I keep saying, right? Like when you update, every version changes things. Like one of my favorite examples, you know the XKCD joke about the spacebar heating?
No, I don't actually.
So it's the XKCD joke. I forgot the number. And the joke is it's from a kind of like a bug checker or something. And the maintainer is like, there was a bug that would run into a high CPU. It would saturate the CPU if you hold spacebar down. And we fixed that now. And then there comes a reply or somebody says, no, but in my Emacs, like the control key is hard to read, so I just had hard to reach. I just hold down spacebar, and I configured Emacs that a sudden rise in temperature, CPU temperature should be interpreted as control. Long story short, that fictive person in this fictive scenario wanted their bug back. Right. So everybody relies on some behavior somewhere. And so it's not even a mistake. Like that joke is clearly hilarious because it's a ridiculous behavior to depend on. But there are other behaviors that are not that obvious that you depend on something that might get changed. And so these things happen, and the only good way to know about them is, well, you can read all the release notes, and you definitely should. But it's also okay to just build. I mean, if you have a problem, then go back to the release notes and find out what it is.
I mean, there are things that we find very late. I remember we had one report from a customer that we switched from concurrent mark and sweep garbage collector to the G1 collector because it's deprecated and no longer there. I think at some version...
Zipzen is already gone. On 17
it's gone, right? It's actually gone, right?
Yeah, 14, I think, was removed.
Yeah, and the customer was trying to actually run the application with concurrent mark and sweep, then saw it didn't work anymore. And so we went to G1, and then we noticed that in their loads, there was a difference. The memory behaved differently. They were looking at their monitoring system, and they were looking at the graphs, like how many people are logged in, and does the memory get freed again? And we were like looking at the peaks, and he was like, the peaks are different. Like there's a different behavior. And we looked at the heap dumps, and we analyzed memory usage, and we tried to figure out if there was a problem, but there wasn't really a problem. It was just, I think, in that point, different behavior where memory was freed at a certain different point.
Yeah, but I mean, I imagine that if you run an application for years and you have a good feeling for what this curve looks like, what it means, what certain aberrations are like, no, that's a problem, but we know what that could be. And that would be scary if that knowledge goes out the window. And so it's a different graph now.
Yes,
all the command line flags are different. All the knowledge about this specific garbage collector is now different. I mean, Java is very careful with removing stuff, but something's got to go. I mean, concurrent mark sweep, I don't know that, but I would expect that probably if some company would say no, we want to maintain this. Sure, but
I think performance is also fine. It wasn't in the end really a problem, but it was funny that this kind of change had this sort of effect. I hadn't thought about it. It wasn't really a bug ticket with us, like, oh, the memory is not being freed in the same way, and what's going on? And then we went with the customer on site and had a look at that, and it looked fine. And so it's funny.
Yeah, and that goes across the board, right? So just changes in the platform like garbage collection, bug fixes, as I just mentioned. A good one is when you have one E23 as a double, and you tell that to print that, it prints 9. I didn't know that before.
Okay.
But it's the interesting thing is that some build of some open source project failed because of the fix. The bug fix now prints the right number. One E23 as a string is now one E23 and not this 9.999 E22. But yeah, there was like, I don't think they did this intentionally. Just like some computation delivered
Yeah.
that result. It's not just that specific result. Overall, there were some bugs in finding the right string representation. And so, yeah, those tests started failing. And in this case, it's pretty clear that it was a bug before. But sometimes behavior changes, and it's not even a bug. It's just like an implementation detail that you should never have relied on, but you accidentally do. And so for all those reasons, that can happen to everybody, to your tools, to your dependencies, to your own code.
I think we had that. I don't know. Did you help us not with looking at this? At least I remember we had some floating point or double calculation precision issues, I think, where some unit tests were suddenly behaving differently. Probably we had the mistakes before, and at some version of Java, I think there was a change and some of the unit tests were starting to fail. And it was a different handling of the double or the floating point precision, I remember. Yeah, so... Yeah. But the great thing is that I think since we managed to move to Java 9, this was the big one. After that, the incremental changes for us have been very very maintainable and manageable. So I think we've tracked all the changes up since 11 or since 9 up into 21 now, and I think we didn't have any huge problems where we're thinking about, oh, we have to spend now, I don't know, how many man days to try to fix that. It's been sort of a smooth ride, and that's what we appreciate, of course, with the Java VM.
Yeah, I think that's really important, that the smaller steps, and they also make predictable changes, like security managers going away. Like everybody yells this from the rooftops, and you get like deprecation warnings, and things on the command line start yelling at you too. And then you have to add a flag to even use it. Right now, at the moment, you have to allow a security manager to even move it, even use it. And so this more releases, if you build on each of them, give you a chance to like gradually be aware of, oh, things change. Okay. So why are you not on 20 right now? Why are you on 17 if all that goes so smoothly?
Well, I'm a bit...
Well, you answer, I got to check the clock, the watch. You give an answer, I'll be back in a second.
I have to be a little bit careful what I say about LTS as a long-term support, as I've understood, but we run on we usually use the Temurin release of OpenJDK, so the build, so to say, and we do enjoy that the what used to be known, or what we used to call the LTS support versions, long-term support version, they do get apparently longer updates, so more patches get merged into that. And for our customers, it's important that they have some sort of stability. So most of our customers use the Temurin build that we recommend and also deliver, but we do have some customers that are running on Oracle builds or that are running on different implementations, and they want to get paid support, and they typically get then longer-term support for these versions. And so what we try to do is, our customers are already willing to say, let's go to the newest version. So they go with us onto the newest version, the long-term support version of Java, and they are fine with us doing that. They are happy that we're on a recent version with security updates. But the trade-off is that we stay on this version that has more support, so that in commercial settings, and this is basically the reason for that is that Cadenza, our software, is basically deployed on premise. So all of our customers are running our software on their own servers. And so we have many, many different variants out of there. We have people with Oracle JDK, we have people with Temurin, we have some people with other vendors, and it's all working fine, but we have to take that into account.
It's also pretty neat, actually, that reasonably works.
It's incredible, and it's especially considering that our customers are almost all German governmental organizations. So you would think like government, it's like, oh, let's stay on Java 8, let's never change. But they are getting pushed from security point of view, from the state, from agencies that are trying to push cybersecurity to stay on a recent version, stay on a supported version, and we can use that energy to sort of move forward to the newest version, which helps me because then I can hire developers that want to work on newer Java. I can use all the cool features. So it's a really great situation. I'm very happy that we have these customers. So
yeah, and I mean, I imagine like in a situation where you also have competition. If they stay on 8 and they don't have access to virtual threads, or once maybe Valhalla comes around and you can use value types, all that stuff that also brings performance boost.
Yeah.
Or they hire the same developers with the same like knowledge in the same spaces, but you can say, look,
you can move to frameworks.
I
mean, today you talked about it, right? Like Spring, at some point they move to a new version. They require a certain version of Java or another framework. It's all connected in that sense. So for us, it's sort of totally useful and sensible to just move to a recent version and to profit from all those things.
Yeah, it's a good sweet spot, right?
Yeah.
It's like if you are in that spot where like you don't have to, as I said earlier in the talk, you don't have to update like the moment it comes out immediately. Right? Just give it some weeks to settle. That's perfectly fine. But if you're in that time where all dependencies, all the new versions are compatible with that, then you can just like pull everything up like in one fluid, like in one constant motion. It's not just once every 6 months, but over time. I know that you manage dependencies like that as well, that they over time get updated.
Yep.
And I think that all plays together really well.
Yeah, that's basically working out well for us. I can only recommend it. If your customers are willing to do that, or if you're maybe self-hosting your application, I think this approach is one that works well.
Yeah, I always say, like, I don't know what the alternative is. Like, unless you know that your project is dead in 10 years, you're going to do it anyway.
Yeah.
And it's not getting easier. I mean, going from 11 to 17 now is not harder than it was like 2 years ago.
Yeah.
But I think going from 8 to 11 actually becomes harder now because you cannot just bump every version to the newest and then just do the switch, because you suddenly run into situations where the framework tells you, but that major version actually doesn't work on that old Java version anymore. Sorry, the new major version doesn't work in the old Java version anymore. And then you have to, when you're like in a really bad spot, you have to make these tandem updates where you have to update your web framework and your like main dependency tree, and then also the Java version, and then you do all of that at once at a big bang.
Yeah.
And that's not fun. Yeah.
Yeah, exactly.
Okay, good. Now we'll give it back to the studio. Has to figure out how to fill the remaining 10 minutes.
We can, or we can keep talking.
Great. Okay, they did not.
All right.
We didn't.
We can also.
We figured out how to do
You know
it.
what? Maybe, you know what?
Wait.
Let's switch chairs. I can get my headphones. I can listen to you.
Okay. Yeah, that'd be good.
So maybe there are audience questions or audience feedback. Maybe somebody out there said something that you want to get back to us with?
You can hear us now?
I can hear you now, yeah. That's
So
how the
people
headset
said
works.
at some point that you were talking too fast.
Yes.
But
Wait.
since the conversation happened between the two of you, it was not a question
Yeah.
yet.
So we're talking too fast. That happens. Like we both like then to do that. Do virtual threads yield on blocking TCP call by JDBC driver, and also how it behaves in database connection pooling? Ron Pressler was on earlier.
Yes.
But my understanding is yes. I think networking is all working fine with virtualization of threads. So yeah.
We'll go to another question. Oh wait.
Maybe that's maybe just to you as well, Forrest. Like if you write code, you have unmodifiable lists, and then you still have an add method that throws. How much do you like that situation?
It's not great. I would say it's not great.
Yeah. So having immutable, like having these immutable collections just like somewhere in there, and they still get all the mutable methods.
Yeah.
It's something you have to look out for. Like, and there's no good way out of that, by the way. Like, there's no easy solution. If you, I wrote a blog post about that years ago. By this point, you would think, can't we just have an unmodifiable list interface? And the answer is no, you can't, because it's not going to do what you think it does. And so that's just what Java is now.
Yeah.
All right. Sorry.
Yeah, I was also checking
Checking the chat, checking other things.
if somebody asked anything else.
I just was going to. I was about to put this into the live chat, but I'll just also say it publicly as well. Is that Stuart Marks is going to be joining us here, Dr. Deprecator as well. You might know him, to talk with us as well. So if you have some questions they think it might be good for Stuart, think about.
You know what? Maybe we look, since when Stuart's already there, maybe we can play the API video, and then we get to Stuart after that, right?
Stuart, nod your head if you accept this challenge.
Yeah, where first of
He's
all,
nodding.
there.
He's not. Okay. Well, you're coming on. Hey, Stuart.
Wow.
Hi.
Did I say 10 minutes? I meant 10 seconds.
Yeah. I thought you were going to play the video first, but I'm on. Looks like I'm on. Glad to be here.
We're gonna play it.
So
yeah, we'll talk for a little bit. We'll play the video, and then you can come back on.
Yeah. So I have to say though that the doctor is not in the house.
Not a house call.
Specifically requested Stuart Marks, and so the doctor.
Well, and that's the case. So somebody removing.
Yeah, we're talking about the good new things. We're not talking about you murdering old features that we're using. Oh, by the way, that's an interesting story that we can tell. So you took applets away, and everybody here in the company loved it.
Yes.
No, applets. Sorry.
GNLP and
what was it?
WebStart.
WebStart. Exactly. Sorry, it was WebStart. Because do you want to tell the WebStart story of Cadenza?
Well, yeah, it was one of the big deployment options that we have. We have a desktop application, a very large Java desktop application, and we were supporting Java WebStart as a way to launch. People liked the fact that they could, have a nice XML descriptor with all the options and easily start it from a web browser, and everybody had the same sort of launch options for distribution. But we had to have special rules in the code base, right? Like in WebStart, you have a security manager running, so there's certain things you can't do in the code. We had static code checks to prevent certain things, like people don't call certain things that they shouldn't be doing. And it was just at some point a hassle to maintain as a separate deployment option. And at one point where you guys started really actively deprecating, I'm really happy for that. It helps us. I mean, if the platform owner starts doing these things, then we can very easily go to the customer and say, like, listen, we have to prepare for this, we have to do that, and what is the steps that we can take, and then they will actually do it. So I'm very happy if not all the things, but a few things get deprecated, and it's very. It's a process that we can plan with, and it's a great thing for a platform. I think that's very important as well.
Yeah, to not keep everything around, right? Yeah. Okay, I think we're going to leave it to you folks.
Thank you.
Okay.
So,
one time. I'll see you later. Bye.
Right.
Bye.
Bye.
So, Stuart, welcome. But first, now people know that you're here to answer their questions. First, we're going to play the API changes video so that folks can get up to speed with what happened within the API, what changed, what updates are there, what deprecations. And after that, we come back to you with more questions. So stay around.
Yep.
Easier as a developer. Once the pattern matches the line, you can directly get index, city, and population. So now you have a factory method. Apart from the big new features that you probably heard about, like virtual threads or pattern matching, there is also a ton of new features scattered here and there in the JDK, like new methods on classes that you're using every day, and that you can use today to write better code. Because there is a major version every 6 months, we will use the JDK 17 as the starting point. We will cover the string class and its friends, the collections framework, the date and time API, the HTTP client API, concurrent programming, the math API, and big integer. And as a bonus, we will talk about the deprecations of some elements, things that you should not be using anymore, that will probably be removed from the JDK in the future, or at least stop working. Being aware of that now will make your life easier when you move to a future version of the JDK. So let us start with something you use daily, our good old friend, the string class. An overload of the indexOf method has been added that allows you to look for a single character or a substring between a begin index and an end index. This is nice, not a revolution, but I'll definitely take it. The character class saw the addition of several methods to support emojis. There are actually 5 of them: isEmoji, isEmoji component, isEmoji modifier, isEmoji modifier base, and isEmoji presentation. All these methods take a code point as a parameter of type int. This method will tell you the code point you pass as an argument as the corresponding emoji property. The other good old string buffer and string builder classes got some attention too. You can now repeat a string of characters a number of times with the repeat method. And by the way, there is an overload of this method that takes a single character. Nice. One of the biggest additions in this topic is an update of the regular expression engine that now supports named groups. Named groups allow you to give capturing groups a name and get them in your code using that name. So on the following example, we are analyzing a line with an index, a city name, and a population. So let us first create a pattern. We want to capture the first group and give it the name index. It's just an integer in a string of character followed by a separator. Then we have a second group that we want to capture, which is the city name followed by another separator. And then the third group we want to capture, which is an integer in a string of character with internal spaces separator. Once the pattern matches the line, you can directly get the 3 capturing groups: index, city, and population. Note that we use the text block to write our regular expression, This regular expression needs to be on one line, but it's more readable to split it on several lines. So to remove the trailing line feed at the end of each line of your source code, you just need to add a backslash. Neat. Several elements have been added to the collections framework, and the biggest of them is, of course, the two new interfaces, sequenced collection and sequence set. If you want to know more about these two, why they've been added, and all the details about how you can use them, you can watch the episode 19 of the JEP Cafe. The link is in the description. Besides this addition, you also have several factory methods to create different types of maps with a given initial capacity. It may look simple to do that, but it is in fact a little tricky. A hash map, for instance, is built on an internal array. And when this array gets full, it is copied in a larger array. The problem is that it's not actually copied. All the key value pairs of the first array need to be rehashed in order to be placed at the right position in a new array. Because the hashing depends on the size of the array, there is little chance that the bucket they will be stored is the same from one array to the other. So you cannot actually just copy the content of the first array to the second one. In order to avoid collisions, an array is considered full when it reaches 75%. So to create a hash map that can store, let's say, 100 key value pairs, you actually need an array of size 134, under the constraints that the size of the array should be a power of 2. So you will actually create an array of size 256. This computation is error-prone, to say the least. So now you have a factory method, and actually several factory methods to do that, and you can forget about it. All you need to do is to call new hash map, pass the number of entries you need, and that's it. You're done. And by the way, you have an equivalent method on hashset, linked hash map, and linked hashset, which is much simpler. A nice addition to the date and time API is the localization of the date-time formatter. You now have a off-localized pattern factory method that takes a format of type string that produces a localized pattern. The corresponding builder has also been updated with an append localized method that takes a localized pattern of type string. Great. Several elements have been added to Java.io. You can now get the car set that the print stream is using to produce its results, which is nice. And you also have several methods that have been added to the zip input stream class to read bytes one by one and several at a time, or to skip them. And in zip input stream, a transfer to method has been added. This method was added on input stream with Java 9, and it is now also defined in zip input stream. This method takes an output stream as a parameter and copies the elements of the input stream to the output stream. Once this method returns, there is no more elements to be read from this input stream. Several classes from the JDK became auto-closable between 17 and 21. Among them, you have HTTP client, executor service, and fork join pool. Auto-closable is a nifty mechanism that allows you to automatically close a resource once you do not need it anymore. Auto-closable is a very simple interface that has only one method, close. So if you want to use it in your application, it's really super simple. And once you have a class that implements this interface, you can use the try with resources statement to create instance of it. Any class will do as long as it implements this auto-closable interface. When your code exits the try with resources block, you have the guarantee that your close method will be called no matter what, which is great and exactly what you need. Basically, all the resources from Java I/O implements this interface. And the same goes for the elements of JDBC. Connection, statement, result set, and the like, they are all auto-closable. And there are many other classes in the JDK that are also auto-closable. And again, any class from your application could be auto-closable. Well, now the good news is that HTTP client, executor service, and fork join pool are joining the family, meaning that you can also use them with this try with resources pattern. Neat. The math class and the big integer class got some attention too. First, a bunch of methods have been added to the math class. 3 overloads of the sealDiv method have been added, along with 2 overloads of sealDiv exact and 2 more of sealMod. Dividing integers may sound simple, but it's actually quite complex. You have several ways to handle rounding, made even more complex when you need to support negative numbers without forgetting about overflow. And remember that you have integer.maxValue and integer.minValue, which can generate some unexpected overflows. That makes many corner cases that you need to handle properly, thus the amount of overloads for these methods. And by the way, you also have another 4 methods added, divide exact and floor divide exact. These 4 actually throw an arithmetic exception in case of an overflow, instead of silently returning integer.minValue or long.minValue. Another method has been added with several overloads to handle the int, long, float, and double primitive types. This method is clamp. This method clamps the provided value between the min and the max you give. And as a bonus, you get a last method, unsigned multiply high, that multiplies 2 longs as unsigned numbers and returns the 64 higher bits as a long. The big integer saw one addition, the capability to perform multiplications in parallel. This implementation is quite complex and uses the fork join framework. As usual, when using these kind of things, be careful, measure your performance gains precisely and in a production environment to make sure that it fits your exact use case and that you're actually improving your performances. Many things have been added in the concurrent programming space, and I'm not going to cover virtual threads here. If you need a deep dive into virtual threads, you can watch the dedicated episode I did for this series on this topic. The link is in the description. I just would like to cover 2 elements here. First, you now have a join method and a sleep method on the thread class that both take a duration as a parameter, which is great. You also have the isVirtual method that tells you if a thread is virtual or not. And don't forget that you have a new way to create thread from the thread class. You have 2 polymorphic builders that you can use to create threads, both platform threads and virtual threads. And if you want to use virtual threads, you also have a new factory method in the executors class to create an executor service that does not pull anything, that just creates virtual threads on demand. That's the executors.newVirtualThreadPerTaskExecutor factory method. Again, all these topics are covered in detail in the episode about virtual threads. One point that I will cover now are the new methods added on the future interface. There are actually 3 of them, result now and exception now. These 2 methods do not declare any checked exceptions, So no more try catch in your code, which is a relief. But just be aware that if you call them and the future you're using is not done, then you will get an illegal state exception. You are really supposed to call these methods when you know that your future produced a result or an exception. And then there is a third one, state, that you can call to check the current state of your future object. The return type is a new enumeration called future.state. It has 4 instances: running, meaning that your task is not done yet; success, meaning that your task completed successfully; failed, meaning that your task completed but with an exception; and cancelled, meaning that your task was, well, cancelled. So you can now monitor what is happening with your task more precisely thanks to this API, which is great. The last thing I would like to quickly mention is the deprecation of at least 2 important elements in a JDK. I'm not going to cover them in detail because it has been done in another episode. So if you need more information on these, please check it. Once again, the link is in the description. Just be aware that finalization is deprecated and that at some point the finalize method of the object class will not be called anymore. Actually, it could even be removed from a future version of the JDK. So if you have some code in your current finalize method in your application, move it somewhere else because at some point this code will not be executed anymore, which is probably a good thing because this code is probably not working as you think it is working. And the second element that is deprecated are the constructors of the wrapper classes: integer, long, float, double, and a line. And this is in preparation of the release of value types and elements delivered by the Valhalla project. These constructors have been deprecated for removal and they will be removed in the future. So make sure that you do not call these methods anymore. And if you are, you can just replace these calls with a call to the corresponding value of factory method, which is basically doing the same thing. If you want to learn more on some of the elements we covered, please check the descriptions. All the links are there. And if you want to learn more about the other new features of the JDK 21, you can check the other episode of this series. Again, the links are in the descriptions. And with this, I'm out of coffee. So that's it for today. Talk to you soon.
Welcome back. It was very insightful from Jose.
As always.
And now, yes, and now let's bring Stuart. Hi, Stuart. Hello again.
Hello. I hope I'm back for good this time.
Yes, yes. We're happy to have you here. And since there were a lot of comments in the chat, and we, I think, already touched on Security Manager, why not tell us what's new about the Security Manager? Within the JDK 21.
Well,
what's
I
new?
think it's going the opposite way.
I know, deprecated for removal, but what's new regarding, making it removed forever?
Yeah,
because there was a
so
question about that.
Yeah, I don't want to pre-announce anything. There's a lot of work going on behind the scenes to get rid of the manager. I'm part of a small group where we're making lots of design decisions. So Security Manager was deprecated for removal in JDK 17, and it is still present in JDK 21. We haven't gotten rid of it yet, so it is still deprecated for removal in JDK 21. So on the face of it, nothing has changed, but we've been doing a lot of work in the background. I think the main takeaway, and this has actually been projected it was talked about a little bit in the JEP, which I think was JEP 411. Do I have that number right? Can somebody look that up?
That sounds familiar.
Yeah,
I'll look it up just to verify.
It's sort of there's this sort of idea of when we're deprecating it for removal, we're not actually going to kill the APIs. And so I know some people, when they said, "Oh, we're deprecating it for removal," that means if you do system.getSecurityManager, that API is going away, and your program will no longer compile, and old binaries that call that will fail with a no such method error. And so, not true. What's going to happen is that the underlying mechanisms of the security manager will be removed, but certain APIs will still have well-defined behavior. In particular, getSecurityManager will always return null. And so lots of library code, if it wants to run both with and without the security manager, what it will do is it will say, if security manager SM equals system.getSecurityManager. If SM not equal to null, that means the security manager is active, then go off and do a bunch of other stuff. Else do nothing. And so what will happen is code that's written that way will have the effect of continuing to behave exactly as it did before with the security manager disabled. And it can't tell the difference that the security manager is actually, the code is actually no longer there anymore. So highly stylized code like that, and there's a lot of it, and a lot of it in the JDK does that as well, would just continue to run as normal as if the security manager were enabled, even when the security manager is simply gone. So there are a few things like that. So lots of code is gonna behave that way. It'll continue to be well behaved, even though the guts of the security manager are going to be taken out. One thing that one thing that scrolled by in the comments was that somebody said, "Oh, well, they can't remove it until they remove all the JDK code that uses it." That's not quite true. Oh yeah, that's exactly it. First, remove all use the security manager in the JDK. That's actually not the hardest thing, because there is, there's a lot of code in the JDK that does exactly what I said. If getSecurityManager not equal null, then do some other stuff. And so since getSecurityManager is going to return null, that code will probably stick around for a while. The more difficult stuff that we have to do in the JDK is the tests. And I think the internal team has done some counting, and I think there are like 4,000 tests that either use the security manager or have a mode that tests with and without the security manager. All of those have to change. So that is probably the biggest implementation task, is making sure that we disable the security manager permanently, but also make sure those tests continue running, because we don't want to, we don't want to be the guys to have the CI turn red for months on end.
Actually, then another question just after that one is, apparently there are no alternatives to it either. So I'm kind of taking it that, I guess maybe they could add if they want to expand it, but maybe it's like, oh, Java is becoming less secure, or maybe there's certain useful API in there that they actually do need later. So I guess take that maybe either of those ways, or other.
Yeah,
concerns about no alternative security manager.
Yeah, the fact is there are a lot of things that that we remove and in fact do not provide an alternative. Like we removed Corba, and there's no alternative to Corba. You basically have to rewrite your application to do something else. Now, the security manager is kind of different, because it's not, you don't write your application on top of the security manager. You just kind of use the security manager in a particular way. And so there's no direct replacement for security manager. That's true. But the reason we're removing it is because the idea of having the idea of having different code in the same JVM having different permissions is obsolete. And so we do not want to replace that, because in fact that was the source of all the complexity and performance issues and difficult maintenance of the security manager in the first place. And so does it make Java less secure? Well, in practice, not really, because, to a first approximation, nobody was using the security manager. So yes, I'm aware that there are a few people who were using the security manager, and it depends on what they were using it for. there are different ways to mitigate that. And so we can dive off into particular use cases that people might want to talk about. But really, you know, most people are saying, I mean, the reaction, I mean, there are a few people who are using it, and yeah, it's, you know, they have to do some work. But most people said, oh, the security manager, oh yeah, that thing that we never used, that we've been told to use for years and never actually used it. They're removing that. Okay.
Yeah. Whenever I bring that up about it being removed, I usually also have the question of like, oh, how many people have used it or heard of it? And no one ever raises a hand.
So we have some other questions from the chat, and I'll take it in a different order. One is about collections. So the current JDK collections cannot be retrofitted with immutable interfaces, and I understand it. Any plans of implementing a completely new one from scratch?
Let's see. So there's so many things behind there, right? So there was a lively conversation in the chat about, I think this does require some backup, some background. So one of the things is, and I think that got posted before we went to Jose's video, a question about, well, unmodifiable list returns a list, an instance of a list interface, and you can still add on it and throws unsupported operation exception. And yeah, I understand that people find that to be an issue, and so you kind of have to know what instances you can call the modification methods on and which ones you cannot. And so it's like, well, I think the obvious thing there is, can't you have a set of interfaces that simply do not have those mutator methods on them? And so the current questioner asks, well, so refers to those as immutable interfaces. And so one of the difficulties is now we have to dig into the semantics of that, right? So what does it mean to have a collection interface that lacks mutator methods? That means something. It means that if you have a reference of that type, you cannot mutate the collection. It does not mean that the collection is immutable. So in fact, somebody else can mutate it, or if you downcast it, then you can mutate it yourself. So now if you really want something that's immutable, then you have to do something completely differently. And so I think the biggest issue is that people look at the interface and structurally say, why are there methods that throw unsupported operation exception? And so they look at the structure of the interface and say the interfaces should be structured differently. But that's not the real question. The real question is, what semantics do you want? You want the semantics that you, the holder of this reference, are not intended to be able to modify the collection, or you, the holder of this reference, cannot, no way, no how, mutate this collection, but somebody else can? Or does the type of the interface mean you, the holder of this reference, cannot mutate the collection, and in fact, nobody else can too? And those are all very different things. And so the question is how and whether to express which of those semantics in the type system. Okay, so that's kind of subtle, but that's the 3-minute summary of that. Now, as a practical matter, would we want to go off and come up with different versions of all these interfaces? Probably not, because it would mean creating a bunch of, either readable or read-only or immutable collection interfaces, and a bunch of new method overloads would have to be changed or added to return the appropriate collection type. And that would be a lot of work. There would be a bunch of compatibility issues. We'd have to consider those very carefully. There would be a bunch of overloaded methods that did almost the same thing. Like, for instance, iterator returns a mutable collection, right? Or sorry, returns a mutable iterator because the iterator method has the remove method on it. So now we're going to have every collection is going to have an unmodifiable iterator or immutable iterator or something like that on it. So now we're going to have overloads for all of those. And so I think, every time I look at that, it gets more and more complicated, and it would provide some value to segregate those interfaces, but it would also have a huge amount of costs. So every time we toe into it, it gets more and more complicated and doesn't provide the value that people think it will. So, any plans of implementing a completely new one? No, not really. I mean, the collection interfaces are here to stay. We're going to continue to enhance them. I think every program uses them. We don't have any plans, but maybe in the far off distant future, we might have a persistent collections library, and persistent collections would be truly immutable. And the idea is that you might have things that look like mutator methods on them, but they don't actually mutate the collection in place. What they do is they return a new edition of the collection with the modification applied, but everybody who has a reference to the old edition of the collection is unchanged. And so persistent collections are a very interesting thing. We think about that a fair amount, but the nature of it would require a completely separate API. So maybe that's a completely new one. It would not be a replacement for the existing collections framework, because people are really used to mutation, and in fact, it's useful in a lot of contexts. So we might have a persistent collections API sometime in the future.
Thank you.
All right. I saw another question in here concerning the auto-closable for. All right, I saw another question here concerning auto-closable for HTTP client. One person was expressing some concern because they would probably want to use HTTP client. And I have you muted. I'll unmute you here in a second because we're getting some echo. All right. You're good.
Oh, okay. I'm not that familiar with the HTTP client API, so I can't. I'm sorry, I can't speak. I'm not familiar with it enough to speak to that in particular.
Okay.
Sorry. Yeah, well, so this is a follow-on discussion that somebody had in the comments. The question is, there's this new state enum that does not have a not yet started, and I claim that you cannot actually use not yet started state, because by the time you want to take any action on it, it might be out of date, and that's different from the other states, which are terminal states. And so if you check to see if future is in a terminal state, it can never change from that state, and so that is safe. So that's why there's no I believe that's why there's no transient not yet running state in the state enum for future.
Let's see. So.
I'm also checking.
Yeah.
Any?
Yeah. Null hostility. Yeah. In general, probably not. Not necessarily the specific case here. And in some ways, it would be nice to allow nulls. Okay, so part of the problem is that the collections framework has gone back and forth over time with whether it permitted nulls or excluded nulls. So the original pre-collections framework, vector and hash table, those rejected nulls. And then when the original collections framework was added in 1.2, the common cases like array list, hash set, hash map accepted nulls. And then the concurrent collections started rejecting nulls again. And unfortunately, the handling of null across the collections framework is pretty darn inconsistent. I know some people have written articles about how, for instance, put if absent uses a different definition of absent from compute if absent. And yeah, that's a problem. It's really hard to, it'd be nice if that were all made consistent somehow, but the problem is you can't make it consistent without breaking somebody who's relying on that behavior. So one of the reasons to avoid nulls, and probably the reasons that the most of the new collections will continue to reject nulls, is that they create ambiguities in the API. So for instance, now it's not particularly true of the set example here, but map has map.get and it returns null. If you say map.get on some key and it returns null, you don't know whether that means a null was actually a value in the map or whether the key was not present in the map. And so you have to make some additional API calls to figure that out. Or you have to use, I forget which one there's another one-shot API, maybe compute if absent will let you distinguish that. We may be doing some fine tuning to make some of these edge cases a little bit more consistent where possible. For instance, I know there's some cases where contains null is rejected and it's like, yeah, maybe just asking contains null should be allowed, but that's different from allowing null to be a member in the collection.
All right, so I'm going to pull up another question. I think you maybe kind of already answered it a bit earlier with the immutable collections, but Buhaki was suggesting maybe an immutable marker interface, like for serializable. All right, let me unmute you.
Okay. You know, I don't want to design this here on the fly. I mean, I guess the question is, what would you want to do with a marker interface? I guess there are a few examples of that in the collections framework already, like random access, right? So there are a few methods that change the behavior depending on whether you know, whether a collection implementation implements random access. I guess, but instead of trying to design what an immutable collection framework or framework that represents immutability should look like, what I'd want to do is understand the use cases, right? So if you wanted to test if you have a marker interface, the only thing you can do is instance of immutable. I suppose you could try to cast it if you wanted, but typically marker interface is tested with instance of. So what would you do with the Boolean that you get from instance of? And you know, I think that leads you off in a different direction. That maybe means that having such an interface is not really what you want. And so maybe it's, you know, I don't know. I'd have to start guessing at what your actual use case is.
Let me see if I can find some more questions. Okay. I don't know if this is something that you'd be able to give an answer for, or I'll.
Yeah, named arguments. Yeah, there's some other languages have named arguments and optional arguments, and those would be nice to have. I think the difficulty is that I think there are different ways you can approach that. They all involve a certain amount of complexity. One of the issues that comes to my mind is overload resolution, right? So if you have a set of overload methods, the rules for choosing the overloaded method that is actually called is quite complicated. And in fact, what we usually try to do is tell people to avoid overloads and use them only in the case where the overload resolution makes things absolutely clear. For instance, based on the number of arguments. Okay, now add optional arguments to the mix. Oh, well, the number of arguments you pass at the call site might differ from the number of arguments for the method that you actually want to end up called. All right, how does that complicate overload resolution? A lot. So anyway, so it's not that it's a bad idea, it's just that it adds a fair amount of complexity. There's another thing too, which is that is this going to be a source level? It's an aspect of the design where is this going to be a source level kind of a syntactic sugar thing where the Java C compiler reduces it to an existing method defined in the class file? Or is the notion of named and optional arguments going to be pushed into the JVM? So that would mean a bunch of different changes to the class file format to support that. And then the VM would also have to get into the game of, okay, given a call site, or like given, for instance, an invoke, well, at the VM level, the call site is expressed in terms of the invoke virtual bytecode. And so that would have to have the VM look at what arguments are being passed with the invoke virtual bytecode, and then try to match that up to what the class actually has. Not an impossible problem, but there's a bunch of complexity there. So you have to trade off that complexity against the value that this feature provides. And I'm not saying that it's not a valuable feature, but it's a high cost, and I would say it's a moderate value. There are a lot of different ways to work around writing APIs in the absence of those features. Okay, given that, there are other things too, which is that from the
Sorry, Stuart, going to stop you for a moment here. There's like a interference coming in from your audio that's starting to become pretty noticeable. I don't know if you can maybe drop from the stream and then rejoin, and Anna and I will fill in for a few minutes during that time. Okay.
And he said like this time, I hope it's for good, but apparently technology works against him.
Yeah, exactly. Sorry that happened too. It's starting to become pretty noticeable, pretty distracting. So let's see. So give us a moment here to see if we can get some questions that Anna and I will be able to answer maybe during the time while Stuart can hopefully rejoin. So maybe a question earlier that was, oh, wait, actually, there we go. That was the answer, but here was a question. What is the difference between new HashMap 16 and different from HashMap.new HashMap 16? And so, yeah, one, luckily, Danis always answered that question. That's like HashMap new HashMap will give you one with 16 elements, and the other one will have an internal array that has 16 elements. And well, let's see. Actually, here, Stuart is back. Hopefully, his audio issues are resolved. So,
hi, how am I sounding now?
Perfect.
Perfect.
All right. Well, it never fails. Try turning it off and on again. All right. So I came in the middle here. So did you want me to answer this question that's on the screen about
no
HashMap?
No, it's okay. It's already answered.
Yeah, you can finish.
We already answered it. Okay.
Yeah. You can finish up. You're still talking about the answer with the name parameters, like some other languages have it. Yeah.
Right. So, but if you were online for Brian Goetz's pattern matching talk earlier, then you kind of see the language team is taking a different direction for naming things, and it's not exactly the same as named and optional parameters. But I think this idea of withers is a very powerful one, which is basically it lets you introduce a scope that has different it has different scoping rules, and certain names are introduced into that scope for you automatically. So you can say record with blah, and so that expression is evaluated in the context of having the component names from the record in scope. Okay, so with that in mind, you can imagine some extensions to that where it's not only going to be records. So if you had a deconstruction pattern on an arbitrary class, then you could have it provide certain things that you could evaluate an expression with those names in scope. And I think that's really powerful. We haven't quite figured out how we would use that sort of thing in APIs yet. And I think one of the things about named and optional parameters is that they're really good for builders. So the builder API pattern is a common workaround for the lack of named and optional parameters. And so, so if you have withers for records, then we see a different direction for solving some of the things that people solve with builders. So, so obviously they're different constructs, but we haven't quite. I think we'd have to start to get some experience with this whole new wither concept and see how they can be employed, and maybe the need for named and optional method parameters will be lessened at that point. Or maybe not. I don't know.
All right, here's a easy question. So someone's really happy with the new sequence collections API. You know that I think you had something to do with that. Why didn't we do it earlier though? But like, where's the idea come from? Yeah. So.
Well, okay. So why did we do it early? So this is one of the things. So Java evolves fairly slowly, even though we have these 6-month releases and you know, it seems like we're cranking out features. It really does take a long time for these features to gestate. And so, for instance, we were just talking about record patterns and stuff. That whole arc of record, I mean, it's not done yet, but the whole pattern matching records, algebraic data type stuff that I hope you remember that Brian talked about, that took several years. Panama is maybe reaching fruition in the next release or two. Valhalla has been working on, I think the team has been working on for 8 years. Now, sequence collections are not nearly as complicated as any of those, but I think I was working on that for 2 years at least. I know it's been so why does it, so you know, I guess there are two questions. Why wasn't it done earlier? Okay, so it depends on where you start. But one of the things I spent a lot of time doing is tracing through as many old articles and bug reports that are in the bug database from long before I actually joined the JDK team. And so among the earliest set of bug reports after the Java collection framework was added by Josh Bloch in 1.2, so that was all the way back in 1998. People recognized the lack of having some kind of collection that was both unique and ordered. And so a set provides uniqueness and a list provides ordering, but so there's a whole series of RFEs for something like, well, I want a list set, or I want a set list, or you know, some combination of those features. And sometimes people were asking for things that were contradictory, but kind of, you know, embedded in those requests is a need for something. Okay, so I think it was in 1.4 when linked hash set and linked hash map were added. And that satisfied some use cases, but there were also a bunch of deficiencies there, right? So linked hash set is a set, and so it maintains uniqueness, but it also maintains ordering. But the only order, well, there was a mode, which is a really kind of a special case hack, if you will, which is you can either choose to have it be insertion ordered or access ordered. And so access ordering is really weird. So for instance, if you on a linked to hash map, if you did get, it would reorder the elements. And so, you know, there was, it satisfied a moderately narrow set of use cases, which is, you know, I want to throw things in but preserve order. Okay, that's great. But there was some follow-on RFEs after that, which is, you know, well, there's not enough control here. Suppose I want to have my own policy for what the ordering should be. If I have a least recently used cache, then the linked hash map works for that and nothing else, right? So it's not very flexible. Linked hash map is a very special purpose thing. So anyway, so I think the gestation of the idea was me going through all of those old bug reports and trying to figure out what the core of the issue was. Also, I have to say that I have a regular job, which is leading our internal core libraries team, and so that takes a lot of my time too. So almost in my spare time, I think about what the core of the problem is. But I think that's the real thing, which is when you take these ideas, there are a lot of ideas floating around, and the easiest thing, well, I think the easiest thing in the world to do, and I think it would be a mistake to do, is look at an idea and say, oh, that sounds like a great idea, and hack it in. Because in the JDK, when you hack it in, then you have to deal with any compatibility issues that might arise from it. But you also have to remain compatible with it, in perpetuity, essentially. So we don't want to add stuff unless we're really sure that that it is the right thing to add. And so it took me quite a while to distill the essence of the problem down to its fundamentals, which is getting this notion of encounter order and understanding how that was manifested in different interfaces across the collections, and then trying to find some way to retrofit that into the collections hierarchy in a useful but minimal way. Plus, along the way, rehabilitating things like linked hash map, which I think are considerably more useful now that you can add, remove, and get things from either end, which has long been missing on linked hash map. So so I don't know if that's a satisfactory answer, but I think the idea came up is that it's based on people's. Okay, so fundamentally though, the ideas are understanding, reading people's requests and then trying to understand what they really need. And that takes a long time and a lot of thinking and discussion. And then, why wasn't it implemented earlier? Well, it takes a long time to do this stuff.
Yeah, no, that's an important element of taking in feedback and then trying to understand what people are really asking, because like you said, people are asking for somewhat contradictory things, but maybe to the same issue overall. And if you obviously you couldn't implement both of them, and if you implement one of them, a lot of people will be upset. So I imagine that's not easy. So I know you're not here as Dr. Deprecator today, but this might be the #1 feature you really would like to have deprecated. So any updates on serialization since your last talk with Brian?
No. So I guess he's referring to the talk Brian and I gave, I guess it was 3 or 4 years ago at DevOps, called Why We Hate Serialization and What We Might Do About It. And no, let's see, what's been going on. I don't think there has been any serious work on serialization for a while. One of the things about serialization is that there's this tension between working on the old and coming up with the new. And so, as you probably are aware of, serialization has historically been a source of a lot of security vulnerabilities. And so kind of as a, it's more than a stopgap, but it's a tactical move, which is we added and have put some investment into serialization filtering. And so that's with old, like old serialization or legacy serialization. So that I think has, cross fingers. Well, put it this way: the security vulnerability situation with Java is considerably improved from where it was several years ago. And I think the addition of serialization filtering, even though that's an enhancement to the old framework, I think that has provided considerable value at dealing with those situations. Okay, now if you go back to that talk that Brian and I gave about why we hate serialization and what we might do about it. So what is the thing that we might do about it, right? So I think the idea there is manifesting itself kind of indirectly through what you heard Brian talk about before, which is deconstruction patterns, right? He talked about, right? So fortunately, I was online for this, so I remember what he was saying. But he said this before as well, right? So the idea of a record is that it is a complete description of the data in a record, and you can, if you construct a record from some data, there's nothing in the record other than that data that you put in. And if you deconstruct a record or destructure, to use the functional programming term, then you can get back out all the data, and there's no hidden state inside the record. And so the idea of serialization is to say, I have some data and I want to present it in a manner, using the facilities of the programming language so that I can hand it over to a framework and have it extract all the data faithfully, or given the data in bit parts, can reconstruct one of my objects, faithfully without any hidden state, and to do that in a type-safe fashion using constructs fully supported in language. So we're not yet at the point of working on a replacement for serialization, but you can kind of start to see the underpinnings of it in this whole construction and deconstruction angle that Brian is pursuing in Project Amber, because that's the main. I'm sorry, I keep referring to this talk that our questioner saw and that I remember, but maybe I don't know how many other people on the stream have seen it. But one of the things we went through, and one of the biggest issues with the current serialization mechanism is that there's too much magic, right? You can create an object and, hey, you say implement serializable, and a bunch of stuff happens. And a bunch of stuff happens that goes on behind the curtains that you, the programmer, are not aware of. And that, in fact, is a source of bugs. And in fact, it's a source of security vulnerabilities. Okay, so one of the main criticisms in our talk was don't provide extra linguistic mechanisms for doing this sort of stuff. And so the Amber, less so the pattern matching, but more the construction and deconstruction, is a first step towards providing full linguistic and type-safe mechanisms that may eventually be a piece of some future serialization mechanism. Okay, so I think I managed to get all the intro and give a roundabout story about what's going on there.
Yeah. Isn't it like 11 methods are called or something like that when doing serialization? I remember when researching for like serialization filters and stuff, like that was like the first time I really got into it, and I'm just kind of like, oh my, it's like read object, write object, I mean, there's just so many, and it's like, it's part of the object API, but you would never know about it unless you actually like really dug into it.
Yeah.
And it gets around to constructor and all that stuff.
Right. Yeah. And that's exactly it. Right. So if you want to do some special stuff, you have to define a write object method or read object or read resolve and write replace. And I don't know, I don't know how many API points there are. There are some hidden fields as well. Yeah. And so the serialization mechanism goes in and does all this stuff reflectively and reads private fields and calls private methods, right? So you have one of these in your IDE and there are squiggles on it. It says this is dead code. It's like, no, it isn't. It gets called.
Yeah. And to put the fine point of it, it's like if you have a constructor and you said like this field cannot be null, and if it's null, like throw illegal argument exception. But with serialization, it can just get around that because it never calls the constructor for it, and that's obviously how you get like an illegal state within your code for that object to be in that could then potentially cause a lot of issues. And then there's also a number of security vulnerabilities where someone can send, some code that's been serialized and, some crazy stuff. And so, but yeah, there is a new question wanted to bring up. I think I tried to answer this a bit earlier. I think Brian covered it a bit earlier about withers. And I think was maybe 23, 24, maybe it could have been further down. I'm trying to remember. I tried to kind of answer in the live chat that maybe as to when this could be seen as a preview feature.
Yeah,
I don't know if you have.
It's pretty early in the design of withers. I mean, okay. They have some prototype syntax, but then there's also a bunch of things about. Okay, so I mean, this is all great conceptually, which is you have a record, and you say record R with blah 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 blah. Okay, well, how does that actually get compiled?
Yeah.
right? So there are lots of things to be done. I'm sure they have some prototypes and some sample syntax, but I think there's a lot more work. So yeah, so it's not. I do not think preview is going to be around the corner for that feature.
Okay, so yeah, I was wrong. I was too optimistic in my. So yeah, it might still be some time down there, but it's definitely it's definitely being seriously considered. You know, I probably won't go beyond that. So another question is, can we get continuation-based generators in the core library since continuations are now part of the JDK?
Yeah, so this is a Ron Pressler question. We do talk about generators a lot. I think there's this question of what we want those to look like. I'm guessing here a little bit. I haven't talked about this with Ron in great detail. As a libraries guy, what I would want to do is come from the outside in, which is to say, what kind of program do you want to write with something called a generator, and what would that look like? And there are a lot of detailed questions to be asked about that, and but I think that's the way that I would recommend approaching it. And I would caution people about this. I think there's this, if you read literature about continuations, there's sort of, it's one of these things, one of these constructs that appears in a bunch of different languages. And there's this object as part of the JDK internals whose name is continuation. And, you know, I think it was named continuation because it was evocative of something that, you know, Ron and his colleagues reminded them of continuations in other platforms. And so as such, it's a fine name. But it's internal because it's not necessarily the thing that we want Java programmers or expect Java programmers actually to use. So I think there's a separate question there, which is, well, actually, we started talking about generators, and you can build generators out of continuations. And so maybe if we were to have generators, we would expose a generator API. Now, if you wanted to expose continuations as part of the programming model, then you would have to go through a similar kind of analysis, which is, what kind of programs are you going to write that are going to need something that's called continuations? And does that differ? Well, I almost guarantee the answer is yes. That will differ from the thing that is inside the JDK right now called a continuation. So what's inside the JDK right now is really purely an implementation construct, and it's not something we want to support as part of the programming model right now. But I think it's something that we're talking about. But there's a bunch of other things going on in Loom as well, like structured concurrency and scope values, and all the other things that Ron is working on at the same time. So there's lots of stuff going on, and I'm not sure that it's quite. I think the thinking about generators and continuations is somewhat less well developed than those other things. So I would look for development in those other areas first.
All right. So we have about 4 minutes left. This could be a good question to end it on. I think much more in your wheelhouse than the previous one. So,
yeah. Okay. So, question from Robert. Good to hear from you. So this is interesting. I guess it's time for me to work in a plug for the DevOps deep dive that Morris Naftalin and I will be giving at DevOps in a couple weeks, because we do plan to go over some advice for using collections, and so I think this is an interesting one because if you know the size of collection, apply that value to the constructor. I think that's true, but I think it's not an unreasonable thing to do. If you know exactly how many things are going to be in the collection, then sure, go ahead and provide the size. And in fact, previously in this chat, there was that question when I had to drop off about, why is there a, hashmap.new hashmap static method? Mm-hmm. Because there are times when you know exactly how many elements or mappings are going to be in some collection, And so you probably want a good way to specify that through the API. Okay, that said, it's probably not the most important thing for you to worry about. And so I think sometimes people go off the deep end. It's like, I have a bunch of stuff, like I'm filtering some collection and I want to put them into an array list. Well, how many do I know? Should I count it first and then allocate the array list and then put them in? So, probably not. Most of the collections grow incrementally, and for the most part, you don't notice the overhead in doing so. Obviously, there is some overhead with the automatic growth, but it would probably be outweighed by any work you had to do to pre-compute the size. And I think in general, people overestimate the amount of work that a collection does when it has to resize itself. So, for instance, if you're adding things to a hash map, so one of the things that we might like to do, and in fact that new API supports that, is if you have a certain number of mappings, then pre-size the hash map with, so that it can accommodate that number of mappings without having to resize. And usually there's some editorial comment along that, which is, yeah, we want to do that to avoid the expense of an expensive rehashing computation of the hash map. And in fact, it's not that expensive. It's an array allocation. And then what the hash map code actually does is it doesn't actually rehash anything. It takes all the hash map internal nodes and just kind of reshuffles them into the new array. So it actually mostly just moves pointers around. So it doesn't actually redo any hash code computations. So, or mostly it doesn't. I mean, it has the hash code cached, and then it has to do a masking operation to figure out where it goes in the new table. But that's about it. So what I would counsel is not worrying too much about pre-sizing collections. And I think another thing, okay, so then I'll plug in one other thing here, which is, and it has to do with what we said earlier about immutable collections and making defensive copies. So one of the things that Morris and I are intending to talk about is this idea of you should treat collections as part of the internal state of some object. In other words, an object should own a collection. Just like an object owns a field, you wouldn't have a public field that allowed anybody to set values into a field, right? So similarly, you wouldn't do the same thing with a collection. So if I had an object that had a list as a field, you wouldn't expose that field, but you also shouldn't just hand out that collection, because then it might allow somebody else to modify it without you knowing about it. And so what should you do in that case? And so I think for simple things, people get along, but sometimes I get people get confused about when they should make defensive copies and when they should wrap the collection with an unmodifiable wrapper. And the short answer is make a defensive copy on the way in and hand out unmodifiable wrappers on the way out. So in your getter, wrap the thing in an unmodifiable wrapper. And it's like, that might seem elementary, but in fact, I did see some code once where somebody was passing in a collection and they wrapped it in an unmodifiable wrapper and stored it in field in this object. It's like, this actually doesn't do what you want it to do. And I feel safe criticizing it because this code was in the JDK. And so it's like, wow, all right. So, you think that everybody knows this stuff, but, and some of these things are elementary, but, and I made sure that got fixed as well. So
that's why I want to tell something to the folks. So from what I know, Devox live streams their talks and also, of course, shares the recordings. So if people want to watch your deep dive, they would probably can do that live probably on European time zone. So they can get more tips regarding this from you and by watching that in live stream. Oh, unfortunately, I have to cut you quite abruptly because
we're a bit behind now. So yeah.
Yes. But thank you very much for joining us.
Okay.
Answering so many questions. And we hope to have you soon again.
Second segment. So thank you. Good to see you.
Thanks.
Thanks for all your questions.
Bye.
Bye. All right. We're going to bring Nikolai briefly back in before we're about to go to Chad, George, and Sar at CloudWorld. But yeah, I guess I don't know if you had anything to say, Nikolai, other than hi or
hi.
Perfect. All right. Off to Chad, George, and Sar at CloudWorld.
Hey, everyone.
All right.
Wow,
Stage
long
is yours.
day. Oh, we lost the rest of our hosts. So is it just you, Nikolai?
Well, we're still here. I'm guessing. I don't know. Did you have a part?
No,
that
I
you
thought we have like a
I don't know what we're doing.
lightweight conversation or something. Can
Oh,
George hear us too?
So George, sorry, yeah. So George can't hear what you're saying.
Yeah, I
Only
know.
me. So you can talk about him, and I'll also filter.
So we can
what-
say a lot of negative.
So wait, so you don't want to
Say good
share your
things.
earplugs? Why did you give him one of your Bluetooth earplugs?
That's a good point. Hold on. Put it in your left
Did
ear.
you clean it off?
All right.
Did you clean it?
I have clean ears, Billy.
Okay.
Right? Is it working?
Hey, George.
Hey!
Hey, how's it going?
It's going good.
All right. All right. So 7.5 hours. You guys have been going. We're coming to you live now in the final 30 minutes from Oracle CloudWorld 2023. I have a Oracle database plushie, and it's going to be next to the Duke plushie here. And we're celebrating.
They fit
What's that?
well.
Yeah,
They fit
yeah.
well.
Yeah.
Nice.
They've been fitting well for some time.
Hey, there we go.
A friend of mine hand knit this for me.
Oh.
My birthday present. It's so cool. I'm trying where to put it so the black part doesn't disappear.
Well, we appreciate all of the 300 or so people that are still on the stream. Many people for the entire 8 hours, I hope. But I'm here with Georges Saab, the Senior Vice President of the Java Platform Group at Oracle. I think many of you already know George. He's also the chair of the OpenJDK Governance Board.
Governing board.
Governing Board. And my name's Chad. I'm part of the Developer Relations Group. And we're going to try and close this thing up. So, George, Java 21.
Yeah.
It's been a long day. It's been 6 years now with a 6-month release cadence.
Yeah.
Tell us, what have you learned in 6 years? What's changed and what surprised you?
Well, let's see. We've learned so much in doing that. You know, when we first got started, there was a lot of skepticism. People were unsure whether it was going to work, whether we were going to be committed to doing this for the long haul. You know, there were even people on my team who said, you know, even like the last phase of stabilization of the Big Bang releases, usually took 9 months to 12 months. So how are we going to do this in 6? And but we were committed to giving it a try because we really felt that having a time-based model where we didn't put things in until they were ready, but we could get smaller increments of change into the hands of developers more quickly was very important, right? And it was a shift that the time had come for. We also felt that by having such a frequent release cadence, that the sort of the worry of something not making one release was going to be less because if it's 4 years until the next release, you're really worried that your feature didn't make it. But if it's if it's 6 months, then it's like I'd rather that I get it right before it goes in. And so that's worked really well. We've been pleased with it. And I think that despite that sort of early skepticism that we saw, over time, people throughout the Java ecosystem have really come to feel that this has been an amazing addition and really sort of helped them as Java developers and made it possible for us to help them with more features. So that's been great. I think one of the sort of surprises, you're asking about that, has really been the way that we could use the 6-month releases in order to try things out in a preview mode. So we hadn't, really thought about this as a vehicle for that kind of preview. But of course, in the sort of past model, once something went in, it really couldn't change. It was kind of final, the concrete was poured. And, that often meant that things, while we took as much care as we could, maybe had some rough edges that were very hard to deal with after the fact. But the very notion that there were these releases coming out more frequently meant that we put something in as a preview, indicating that it still might change, and get feedback from people using it in a much broader set of situations than we could in the lab. Using it on their real life applications, and coming back and telling us, this thing seems a little bit odd, or it sticks out a little bit, or doesn't seem that intuitive, but we still had a chance to fix it. And so that, I think, for me, has been a really, really pleasant surprise. It's something that we try to take advantage of.
Awesome. Can I add something to that?
Go ahead.
Because I think they also go the other way. Things going away also have a much more gradual path out.
Yeah.
So I've just earlier talked to a friend of mine, Boris Terzic, who's a software development lead at a local company, and we talked about the things that are going right, like security manager and finalization that are deprecated for removal, and you get like a gradual increase of threatening and more threatening warnings. You get like a message on our YouTube channel, and then you get a warning on the command line. Then you need to add a command line flag to flip things on that are now freshly off by default. And so just as things come in gradually, things can also go out gradually without being there in 8 and being gone in 9.
That's a great point, because if something you get a warning, but it's 3 years until that warning is made a little bit scarier, by that time you've just gotten inured to the warning. You don't even think about it anymore. So that's a great point. Thank you.
I was also going to kind of mention that with like preview features, at least initially when I was thinking of like hearing preview features, I kind of interpreted it as like, oh, it's not quite done yet. But I think I remember having a conversation with Ron Pressler at one point. He was saying it's like, no, like they're ready. It's just one particular take. And by saying it's preview, it means this API might still change. And we're making sure some feedback that, maybe there isn't something we missed. But otherwise, like they could still be used in production. They just might change a little bit before production. It's not like, oh, like if you're using virtual threads in JDK 20, like you might run into some sort of critical error. It's just that the API isn't maybe fully baked yet.
Yeah, that's exactly right. Thanks, Billy.
Yeah, the preview phase is not earlier and it's later. It's not like in the past the feature was done and now we make the preview before it's done. Now it's like, no, it's done, but let's give it a 6 months, 12 months to simmer and see whether it's like really, really done. Let's make it well done.
Yeah, that's exactly right. I mean, I think it's, almost kind of even the other way around, right? The 6-month cadence means that, people really want to make sure that, something is done and is production quality before they put it in to the next mainline release. So, I think ironically, like people were worried that, we wouldn't have time to test and the quality would suffer. And in fact, it's actually been just the opposite. We did a lot of work before we moved to the 6-month cadence, trying to make sure that all of the tests and all of the infrastructure was in place so that we could do a good job of testing things really, really thoroughly before they even went in. And, as you say, what this preview feature, sort of facility does is gives us an ability to just sort of indicate and set expectations that we think it's done, we think it's final, we think it's production quality, it's ready to go, it's fully specified, it's fully tested. There are TCK tests for it. But, we are, humble enough to know that, like, we're going to hear from people and we have an opportunity to make it even better, before it's in its final form where, it's not going to change for the next 2 days.
Can you imagine releasing pattern matching, for instance, of pattern matching for switch, var, text blocks, local variable type inference, records, record patterns? Let's see, what did I miss? All in one release without a model to actually get feedback on that stuff. Like it would be so. And then the other great thing is we get a real reason, everybody on this stream here, to go and talk about Java every 6 months. We're at the top of Hacker News today. We're at the top of Reddit, and it gives us a reason to go talk about these features and to really promote, how great the progress and the evolution of Java has been, without having to wait another 3 years. I mean, what would Anna, Nikolai, Billy, you guys in the stream here, what would you be doing if it was 3 years until the next release?
Enjoy my time off.
Well, no, Nikolai, we're already at Java 22, so
Sorry,
no sleeping. I mean, I know that you've been on this stream since you were this morning and then to a JUG, and now you're back in your room again, but you got to get working on 22.
Yeah, funnily enough, I do actually have a video to edit started tomorrow.
There we go. Awesome.
So I have one more question for George, and then we actually have some surprise guests roaming around. We'd love to get on if we have a few more minutes. But George,
About 15.
You know, it's been a long day. We've been looking at Java 21. We've looked back some. Give us your perspective on what the future looks like for Java. Where do you see things going? Of course, people can follow the mailing list. They can follow OpenJDK. They can see all of the development process. We're looking at 22 ahead of time. But what is your vision for where the Java platform is going in the future?
Yeah, that's a great question. So, I mean, you mentioned 22, and of course, 22 development has been going for a while, and is going to be wrapping up soon. But we try to look further out into the future, and I think one of the things that we really try to do, I think the team is just amazing at this, is understanding problems and thinking about them really deeply, and sort of thinking about them for the long term. So sometimes we get people who come and they have their solution that we really should just shove into the JDK, and our view is, hey, I understand you think that solution is great, but let's take a step back. Help us understand the problem you think the solution is a solution for. And then what we try to do is really understand the problem, think about alternative ways of solving it, and also think about the things that may have in common with other problems we're trying to solve. And so, looking at the sort of projects that we have that have been delivering for the past few releases, a lot of them come from those kinds of discussions. And we really appreciate all of the great collaboration and discussions we've had with people throughout the industry about things they're working on, challenges they see, what's working well for them, what they feel could be better. But again, talking at that level of what are the problems we should be trying to solve. And one of the things that we tend to find is we could start to work on something for a problem we've heard from one place, but the eventual problem is broader than that, and the solutions that we come up with are more generally applicable. And we also want to make sure those things work together. So I think that's something that we've seen in most of the projects that have been delivering, and also some of the ones that we see working on going forward. So in terms of just some of those areas that I think are really interesting, I think Valhalla has been doing great work. Been very, very thoughtful in what it's doing. It's very ambitious, very wide-ranging, but I'm hoping we're going to see some really exciting things coming out of that soon. A couple of others, Leiden, of course, was a little quiet, but as in recent weeks, we've seen a lot starting to come out of that. I think it's a really promising direction. I'm very, very excited about that. And then there's another one that was actually just proposed last week, which is Babylon. I think that's a really neat project. It's very exciting. I think you can immediately see some neat places that can be used, like things like taking Java code and optimizing it for GPUs. But I think what's kind of cool about it is when you look into Babylon, you realize it's much broader and more broadly applicable than just that one area. So that's going to be neat. And then I guess I would have to say the final thing is looking at how the team is thinking, not in terms of just how do we continue to make Java great for expert developers, intermediate developers, but also what are the things that we can do to make Java more accessible for the next generation of programmers that are coming along. So we went through a lot of years there where people would kind of come along, they would learn some other technology because they thought it was easier, and then they would eventually realize that Java gave them incredible power and really wasn't that hard. It just was a little daunting to get started with. I think taking some of that daunting and making it easier for new programmers or programmers who are new to Java to get started, to get going, to be able to realize some of that power by effectively, as the white paper said, paving the on-ramp, is a great direction. I'm looking forward to seeing what comes from that.
Great. Awesome. So if you give me about 30 seconds, I'm going to bring a few other people in. But first, I want to say thank you very much, George. Congratulations to another great release.
Thanks to you, Chad, and really congrats to the whole team.
Yeah.
Thank you.
Okay.
All right.
I'm going to release George, and then I'm going to bring in a few other people.
Can I say goodbye to George with something that somebody wrote just in chat? That's pretty guys. Thank you for investing so much effort, thought, and time into Java, the updates, and the presentation of it all. I think that goes to all of us.
Yeah, that is so deeply appreciated by all of us.
Okay.
All right.
I'm going to steal that from you.
Okay.
And that.
There you go. And you want this too? There you go.
I get the Duke back.
I wonder who the secret guests could be, given that Char and crew are on the name list.
Okay. So let's see. Let's get all three of you. All three.
We'll just surround it.
Okay, so you hold it like a mic about 1 foot. We're going to test the audio. Why don't you give it a shot?
Testing 1, 2, 3. Testing
Sounds good.
1.
Sounds good. Okay, so why don't you guys, one by one, introduce yourself?
Can you
and
scoot a little bit closer to the center
them
so we
to
can
the
see all of
camera.
you properly?
oh yeah, come this way. Come this way.
Yeah, there we go.
I have some very special people here for the closing of the stream. Why don't you guys introduce yourselves?
Sharat Chander, Shar, with the Java DevRel team and product management. Great to see everybody.
Donald Smith, I run the Java SE product management team, and George is taking our pictures, so we're going to pose. Okay, there we go.
Hey, hi, this is Bernard, the Trevor side. I run the engineering team for George.
So why don't you keep it, Bernard? Because I'm
There
going
we
to
go.
ask you the first question.
Sure.
Big release today.
That's right.
Every release has been really great. 21 so far has gone off like it, almost perfectly. A lot of hard work has gone into it. Is there anything you'd like to mention to all the folks on the stream, or I think some of the folks from your engineering group are listening in? What's something special about 21 that you may have to tell the world?
Yeah, okay, so clearly, big thanks to the team. That's, we're saying it's like the 12 release, 6 months release, on schedule, on time, a lot of work behind the curtain in terms of what we are doing to deliver to you guys the best possible Java releases. Also, kudos to a number of the community members that are providing very valuable feedback on our early access releases. So please encourage everybody to pick up early access of 22. It's already there. We are ready to get feedback from you guys. In terms of the content, clearly Bloom virtual threads is going to have such significant impact to the entire ecosystem. So very excited to see what the team has done here. Also, what we have done with the general ZGC, kind of pushing the limits in terms of garbage collections. Latency is number one issue. We're looking at sub-millisecond, where now basically operating system latency become more relevant than the VM latency, and then continue to scale what we are doing here, which I think is going to be very important for the big data, AI, migrations towards a lot of data. You want to make a lot of analysis, so it's very exciting. But also from my hand, one feature that I feel is as much important is unnamed classes, where basically we are trying to get into what we call the small Java. How can we make this wonderful platform more approachable for the new class of developers, where we need to simplify a lot of the abstractions while remaining as consistent to what the foundation of the platform is. So from my end, a lot of excitement. Thank you to everybody.
Thank you, Bernard. Donald.
Yes, sorry. What was the question?
I haven't asked anything yet.
Oh, okay, good.
Donald, how do you feel about that? I'm just kidding.
I feel like I'm watching all the people walking by, and it's great to see folks.
So tell us about your impressions of the day so far, and give us a little bit of, what are you thinking about the future of Java, and what's important for the next, couple of releases?
Yeah, so, well, it's been a really crazy day. It's been super busy. We're back and forth with lots of meetings. The panel this morning, I think, went really well. Super proud of the team getting that live streamed. It's one of those things, I don't think people can appreciate or understand how hard it is to pull something like that off. And so the fact that you guys did this is like outstanding. So it's my job to be the cynic. And so the whole time I was just like, you'll never do it. It'll never work. The internet will never hold up. The camera won't work right. But it went really well. But after that, we had some press and analyst briefings. We're getting a lot of questions about Loom. I think people are understanding how that's going to be. Okay, somebody almost tripped over the camera, and then my point would have been proven live. But I think people are understanding that Loom, I think, is going to be a game changer, especially for third-party libraries. and applications, ISV applications. So it's really interesting to see how things are going to evolve over the next 2 or 3 years. I have a bit where I ask people whether they think Loom is going to be bigger than generics was, like the impact on the platform, or Lambda, or Loom. And I think most people forget that there was a Java before generics, and especially the younger people are, the more they kind of squint at me when I say, remember Java before generics. So that's really cool. Also, getting a lot of questions about AI and ML. And so we're getting really good at answering that question, because the question ostensibly comes in as, when are you going to have an AI ML, a generative AI library for Java? And it's like, oh, well, let's talk about Panama. Let's talk about Valhalla. Let's talk about Panama. Let's talk about all the things we're doing to make those things possible. And it's been great, because I've been in meetings with George where George explains his view on it, and then Bernard where Bernard gives his view on it. And so I feel like I've gotten like a meta view on it, so which is really cool. And then of course we already have interest in Babylon from JVMLS. In fact, we just did a briefing on that and the GPU stuff. So we got some good feedback for Paul Sandos and the rest of the team on that. How am I doing? Anything else I can talk about?
I think that's good.
All right. Thank you.
Yeah, thank you. All right, so, some people call Shar Mr. Java. So I think it's appropriate that we end at least our portion of the stream here with some comments from Mr. Java.
Okay.
I only have one question for you.
Only one? I only got one question?
Only one question.
Okay.
Is Java still vibrant?
It's more vibrant today than it was 5 years ago, than 10 years ago, than 20 years ago. And here we are talking about Java 21, and I'm sitting here going, why are we talking about Java 21? That's so 8 hours ago. Java 22 is already out there. Early access builds are ready. The innovation pipeline doesn't look more vibrant than it ever has. But everything we've talked about, technology innovation, customer value, ecosystem enablement, all three of those are vibrant because of the people. And I think it's great that we can kind of close out that none of this happens. None of this happens without the people. So a testament to all of the engineers on the JDK team, all of the folks on the engineering team, all of our stakeholders internally that helped supported us, your entire DevRel team that's given it oxygen and gravity. And of course, we can't forget the community. Your team launched dev.java just a couple years ago. It has new dimensions that continues to grow with new features and programs, because we know there's so many developers out there. We have to reach them in the ways they want to be reached. And the fact that you announced the playground, but more importantly, you announced the contributions from outside of the community. So it's not just Oracle contributions, but we have content now from folks like Heinz Kibbutz, Venkat Subramaniam, Gene Boyarsky, Gail and Paul Anderson. I'm missing someone in there. Yet there's so many. Yet we're going to still have more content coming.
Yeah.
There's a backlog. We need to make sure the content quality stays high, but we want to make sure all of that innovation and expertise that are outside of Oracle get featured, because none of what we do, again, I'm going to say this, doesn't happen without the community. So we got to invest in them. We got to nurture them. We have to grow them. We have to focus on the next generation. Your team is now focusing on the edu market, on students. Your question was, is Java still vibrant? It is a shining beacon, a North Star for developers, and I've never been more excited.
Great, and I just want to say a special thanks to Dennis McCogon from the team for really, and David as well, for really working hard to bring the playground home. Shar talked a lot about reaching the next generation of developers. It's really, really important that we, as the Java team, as the Java community, as the DevRel team, continue to reach that next generation of developers. A lot of the things that Donald and Bernard talked about, preparing the platform for them. The playground is another way. the community contributions to dev.java, broadening the content, the work we do on YouTube. Also, shout out to Heather Stevens from the team, who's running our education group. A lot of really exciting things happening there. And to all of you on the team, Nikolai, Anna, Billy, David behind the scenes,
Jim from Japan.
You know, thank you so
David
much. You guys
suddenly
have been at it
thrust
all
into
day.
the front.
Why did you tell him?
Because you wanted a panic look on his face.
So we're gonna sign off unless anybody has a final question for us. I can hear it in my ear. So.
No, so but say thanks to the group for being there, for the cool panel, and for
Thank
Charles'
you.
great answer. There's very little to add. I want to call out once more again, David, who's not just been here all day long, making sure everybody arrives on time, but also has doing the thumbnails and behind-the-scenes work on what we do. Like, it's easy to just hold your face into a camera and be liked for it. David does the hard work, and like it's just like it's really good that we have him behind us.
Okay, thanks guys. We're gonna sign out from here.
Yeah, bye.
I'll let you guys close it up. Bye.
All right. Wow. I think we're finally at the end.
Yeah, 2 more minutes.
What are you?
We have 2 more.
Wow,
Oh,
we
we
are saying that.
Wow. That's right.
There's no Oracle staff standing right outside our frames pointing guns at us. That is not what is going on.
So, Nikolai, did you say that I should stay behind the scene, behind the camera?
No, like no.
Was that a message?
You do your own videos. You find out how much fun it is to edit a video, and then don't get the turquoise thumbnail that you so much deserve. See it given to someone else. Anyway, that's too much inside baseball. I think what Shar said there at the end was like really the perfect thing to close it out with. That it's a technology. There are so many people involved, though, and that one can't live without the other. But while we constantly talk about technology, obviously that's the easy thing to talk about. The other part is kind of like implicit and gets often forgotten to be mentioned explicitly. And there are so many people within Oracle, within OpenJDK, and within the other companies within the community that work so much and so hard to make all of this work, and not just on Java, but just with Java. Without the 9, 10, whoever knows how many million Java developers, none of this would make any sense.
Sorry, I should have brought in one of the cats at some point.
Yes, somebody asked.
Yeah, look, maybe we give you a couple seconds. You can go fetch a cat.
Okay, I'll be right back. Let me see if I can go grab one.
Your kittens are sleeping, right?
No, mine is gone. So mine just shut my laptop like 30 minutes ago.
Okay, good. Yeah, that was great. That was a fun afternoon, day, whatever, depends on where you are. Not everything went perfectly, I hear, but I think most of the things went pretty well. And I'm really looking forward to doing another one.
People want the cats.
Yeah, yes.
Do not end.
You have to get the cat. I mean, look at the cat amount.
I think overall it went very well, especially if we consider all the people that were involved. I mean, all the different places that we had to connect to and so on. So
yeah.
Is he purring?
All right.
Oh man.
Oh man. This was not. There we go. There we go. So this is Vicky. She is not excited to be here. She was sleeping very happily on a cat tree downstairs, but now she's with us. Okay. Bye, Vicky.
So that's a question for 21-hour stream. 21 hours is for beginners. Next year, Java turns 29 or something. So we're going to do a 29-hour stream next May.
Yeah.
You heard it here first, folks. So we reserve the very short streams for the birthdays, and we do a short 8-hour one for a new release. What do you think? I mean, that was a big one, right? It was not only big because of the features that went in, it was also big because, it's a version that gets long-term support. So people are naturally very excited about it. And I think we noticed that.
It's today. It's an LTS release is what you just said?
Oh, that's what I want to say to George. Like how thankful I am for him to just say the right words. I forgot to say it to him. Okay.
All right.
Good. Should we close it out? Is there anything we should do? Does anybody have like a beverage?
No.
I have some iced tea.
And water.
Yeah, that counts.
I also have some water.
Get yourself something. Come on.
I have a bottle of water next to me. So
that counts. Whatever.
Yeah. All right. Thank you, everyone, for joining. I have to say, I was expecting only a few dozen, so this has been fantastic.
Yeah, same. So happy 21st release of Java.
Yeah, awesome.
Yeah.
And try all the features, including the preview ones.
Yes, exactly.
On to JDK 22.
Yeah, exactly. So now it's
next
over.
one.
Tomorrow morning, you're going to wake up. 21 is in the past. Now you're going to download 22 EA, and the hype cycle continues.
There you go.
I know I will.
See you around. Bye.
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 Bye.